Are you ready to revolutionize the world of software development and accelerate your career in DevOps? Devops Basics is your gateway to unlocking the power of continuous integration, deployment, and delivery. Join the ranks of successful DevOps professionals and embark on a transformative journey towards efficiency, collaboration, and innovation. DevOps isn't just a trend, it's a game changer. By breaking down the barriers between development and operations team, you can streamline workforce, reduce time to market, and improve overall product quality. Say goodbye to siloed processes and hello to seamless collaboration, automation, and agility. Did you know that companies implementing DevOps practices experience 200 times more frequent deployments and recover from failures 24 times faster? DevOps is reshaping the industry, and the opportunities for professionals with DevOps skills are soaring. But let's talk about the real impact. DevOps professionals command impressive salaries, with entry-level positions offering a range of $70,000 to $100,000 per year. As you advance in your career, you can unlock even more lucrative opportunities in this rapidly evolving field.
Through a number of key elements today, the first two will be reviewing models that you're already probably using for delivering solutions into your company. And the most popular one is Waterfall, followed by Agile. Then we'll look at DevOps and how DevOps differs from the two models and how it also borrows and leverages the best of those models. We'll go through each of the phases that are used in typical DevOps delivery, and then the tools used within those phases to really improve the efficiencies within DevOps. Finally, we'll summarize the advantages that DevOps brings to you and your teams. So let's go through Waterfall. So Waterfall is a traditional delivery model that's been used for many decades for delivering solutions, not just IT solutions and digital solutions, but even way before that. It has its history that goes back to World War II. So Waterfall is a model that is used to capture requirements and then cascade each key deliverable through a series of different stage gates that is used for building out the solution. So let's take you through each of those stage gates. The first that you may have done is requirements analysis. And this is where you sit down with the actual client and you understand specifically what they actually do and what they're looking for in the software that you're going to build. And then from that requirements analysis, you'll build out a project plan so you have an understanding of what the level of work is needed to be able to be successful in delivering the solution. After that, you've got your plan, then you start doing the development, and that means that the programmers start coding out their solution. They build out their applications, they build out the websites, and this can take weeks or even months to actually do all the work. When you've done your coding and development, then you send it to another group that does testing, and they'll do full regression testing of your application against the systems and databases that integrate with your application. You'll test it against the actual code, you'll do manual testing, you do UI testing. And then after you've delivered the solution, you go into maintenance mode, which is just kind of making sure that the application keeps working. If there's any security risks, that you address those security risks. The problem you have, though, is that there are some challenges, however, that you have with the waterfall model. The cascading deliveries and those complete and separated stage gates means that it's very difficult for any new requirements from the client to be integrated into the project. So if a client comes back and the project has been running for 6 months and they've gone, hey, we need to change something, that means that we have to almost restart the whole project. It's very expensive and it's very time consuming. Also, if you spend weeks and months away from your client and you deliver a solution that they are only just going to see after you spend a lot of time working on it, they could be pointing out things that are in the actual final application that they don't want or are not implemented correctly or lead to just general unhappiness. The challenge you then have is if you want to add back in the client's feedback to restart the whole waterfall cycle again. So the client will come back to you with a list of changes, and then you go back and you have to start your programming, and you have to then start your testing process again, and just you're really adding in lots of additional time into the project. So using the waterfall model, companies have soon come to realize that the clients just aren't able to get their feedback in quickly, effectively. It's very expensive to make changes once the teams have started working. And the requirement in today's digital world is that solutions simply must be delivered faster. And this has led for a specific change in Agile, and we start implementing the Agile model. So the Agile model allows programmers to create prototypes and get those prototypes to the client with the requirements faster. And the client is able to then send the requirements back to the programmer with feedback. This allows us to create what we call a feedback loop, where we're able to get information to the client and the client can get back to the development team much faster. Typically, when we're actually going through this process, we're looking at the engagement cycle being about 2 weeks. And so it's much faster than the traditional waterfall approach. And so we can look at each feedback loop as comprising of 4 key elements. We have the planning, where we actually sit down with the client and understand what they're looking for. We then have coding and testing, that is building out the code and the solution that is needed for the client. And then we review with the client the changes that have happened. But we do all of this in a much tighter cycle that we call a sprint. And that typically a sprint will last for about 2 weeks. Some companies run sprints every week, some run every 4 weeks. It's up to you as a team to decide how long you want to actually run a sprint. But typically it's 2 weeks. And so every 2 weeks, the client is able to provide feedback into that loop. And so you were able to move quickly through iterations. And so if we get to the end of sprint 2 and the client says, hey, you know what, we need to make a change, you can make those changes quickly and effectively for sprint 3. What we have here is a breakdown of the ceremonies and the approach that you bring to Agile. So typically what will happen is that a product leader will build out a backlog of products, and what we call a product backlog. And this will be just a whole bunch of different features, and they may be small features or bug fixes, all the way up to large features that may actually span over multiple sprints. But when you go through the sprint planning, you want to actually break out the work that you're doing so the team has a mixture of small, medium, and large solutions that they can actually implement successfully into their sprint plan. And then once you actually start running your sprint, again, it's a 2-week activity. You meet every single day with the actual sprint team to ensure that everybody is staying on track, and if there's any blockers, that those blockers are being addressed effectively and immediately. The goal at the end of the 2 weeks is to have a deliverable product that you can put in front of the customer, and the customer can then do a review. The key advantages you have of running a sprint with Agile is that the client requirements are better understood because the client is really integrated into the Scrum team. They're there all the time. And the product is delivered much faster than with a traditional waterfall model. You're delivering features at the end of each sprint versus waiting weeks, months, or in some cases years for a waterfall project to be completed. However, there are also some distinct disadvantages. The product itself really doesn't get tested in a production environment. It's only being tested on the developer computers. And it's really hard when you're actually running Agile for the sprint team to actually build out a solution easily and effectively on their computers to mimic the production environment. And the developers and the operations team are running in separate silos. So you have your development team running their sprint and actually working to build out the features. But then when they're done at the end of their sprint and they want to do a release, they kind of fling it over the wall at the operations team. And then it's the operations team job to actually install the software and make sure that the environment is running in a stable fashion. That is really difficult to do when you have the two teams really not working together. So here we have is a breakdown of that process with the developers submitting their work to the operations team for deployment. And then the operations team may submit their work to the production servers. But what if there is an error? What if there was a setup configuration error with the developer's test environment that doesn't match the production environment? There may be a dependency that isn't there. There may be a link to an API that doesn't exist in production. And so you have these challenges that the operations team are constantly faced with. And their challenge is that they don't know how the code works. So this is where DevOps really comes in. And let's dig into how DevOps, which is developers and operators working together, is the key for successful continuous delivery. So DevOps is an evolution of the Agile model. The Agile model really is great for gathering requirements and for developing and testing out your solutions. And what we want to be able to do is kind of address that challenge and that gap between the ops team and the dev team. And so with DevOps, what we're doing is bringing together the operations team and the development team into a single team. And they are able to then work more seamlessly together because they are integrated to be able to build out solutions that are being tested in a production-like environment so that when we actually deploy, we know that the code itself will work. The operations team is then able to focus on what they're really good at, which is analyzing the production environment and being able to provide feedback to the developers on what is being successful. So we're able to make adjustments in our code that is based on data. So let's step through the different phases of a DevOps team. So typically you'll see that the DevOps team will actually have 8 phases. Now this is somewhat similar to Agile, and what I'd like to point out at the time is that again, Agile and DevOps are very closely related, that Agile and DevOps are closely related delivery models that you can use. With DevOps, it's really just extending that model with the key phases that we have here. So let's step through each of these key phases. So the first phase is planning, and this is where we actually sit down with a business team and we go through and understand what their goals are. The second stage is, as you can imagine, and this is where it's all very similar to Agile, is that the coders actually start coding. But they'll start using tools such as Git, which is a distributed version control software. It makes it easier for developers to all be working on the same code base rather than bits of the code rather than them working on bits of the code that they are responsible for. So the goal with using tools such as Git is that each developer always has the current and latest version of the code. You then use tools such as MAVEN and Gradle as a way to consistently build out your environment. And then we also use tools to actually automate our testing. Now, what's interesting is when we use tools like Selenium and JUnit is that we're moving into a world where our testing is scripted, the same as our build environment and the same as using our Git environment. We can start scripting out these environments. And so we actually have scripted production environments that we're moving towards. Jenkins is the integration phase that we use for our tools. And another pointer here is that the tools that we're listing here, these are all open source tools. These are tools that any team can start using. We want to have tools that control and manage the deployment of code into the production environments. And then finally, tools such as Ansible and Chef will actually operate and manage those production environments so that when code comes to them, that code is compliant with the production environment, so that when the code is then deployed to the many different production servers, that the expected results of those servers, which is you want them to continue running, is received. And then finally, you monitor the entire environment. So you can actually zero in on spikes and issues that are relevant to either the code or changing consumer habits on the site. So let's step through some of those tools that we have in the DevOps environment. So here we have is a breakdown of the DevOps tools that we have. And again, one of the things I want to point out is that these tools are open source tools. There are also many other tools. This is just really a selection of some of the more popular tools that are being used. But it's quite likely that you're already using some of these tools today. You may already be using Jenkins. You may already be using Git. But some of the other tools really help you create a fully scriptable environment so that you can actually start scripting out your entire DevOps tool set. This really helps when it comes to speeding up your delivery, because the more you can actually script out the work that you're doing, the more effective you can be at running automation against those scripts, and the more effective you can be at having a consistent experience. So let's step through this DevOps process. So we go through and we have our continuous delivery, which is our plan, code, build, and test environment. So what happens if you want to make a release? Well, the first thing you want to do is send out your files to the build environment, and you want to be able to test the code that you've been created. Because we're scripting everything in our code, from the actual unit testing being done to all the way through to the production environment, because we're testing all of that, we can very quickly identify whether or not there are any defects within the code. If there are defects, we can send that code right back to the developer with a message saying what the defect is, and the developer can then fix that with information that is real on either the code or the production environment. If, however, your code passes the scripting tests, it can then be deployed. And once it's out to deployment, you can then start monitoring that environment. What this provides you is the opportunity to speed up your delivery. So you go from the waterfall model, which is weeks, months, or even years between releases, to Agile, which is 2 weeks or 4 weeks, depending on your sprint cadence, to where you are today with DevOps, where you can actually be doing multiple releases every single day. So there are some significant advantages, and there are companies out there that are really zeroing in on those advantages. If we take any one of these companies, such as Google, any given day will actually process 50 to 100 new releases on their website through their DevOps teams. In fact, they have some great videos on YouTube that you can find out on how their DevOps teams work. Netflix is also a similar environment. Now, what's interesting with Netflix is that Netflix have really fully embraced DevOps within their development team. And so they have a DevOps team, and Netflix is a completely digital company. So they have software on phones, on smart TVs, on computers, and on websites. Interestingly, though, the DevOps team for Netflix is only 70 people. And when you consider that a third of all internet traffic on any given day is from Netflix, it's really a reflection on how effective DevOps can be when you can actually manage that entire business with just 70 people. So there are some key advantages that DevOps has. It's the actual time to create and deliver software is dramatically reduced, particularly compared to waterfall. Complexity of maintenance is also reduced because you're automating and scripting out your entire environment. You're improving the communication between all your teams, so teams don't feel like they're in separate silos, but that are actually working cohesively together. And that there is continuous integration and continuous delivery so that your consumer, your customer, is constantly being delighted. 10 most popular tools that you'll need to have in your DevOps setup. And what we're going to do is we're going to break up the tools into 8 different categories. Now we're going to go through the planning and code-based tools, the building tools, the testing tools, the all-important integration tool, the deployment, operation, and then finally monitoring tools. Something we should also add is that all of these tools are open source. This means that you can get up and running with your DevOps environment immediately without having to worry about licensing costs. So let's jump into the very first tool, which is Git. So Git is a distributed version control tool that allows development teams to be able to share code amongst each other in a way that allows the creation of small to extremely large applications to be created effortlessly. If we look at the architecture of Git and the way that it works, that there are 4 key areas. We have the working directory, the staging area, local repository, and then remote repository. So your working directory is where you actually create all the files that you'll be working on in your application. The staging is the area that you get ready to commit those files to your local repository for version control. And once you actually have then put them into your local repository, then you want to be able to push those files using a push command out to a remote repository such as GitHub or GitLab. In addition, if you have a distributed team, you can then also pull down the latest files. So as a team, you can always be working on all the files all the time, and then go through the whole process again by working on your local files. You can do this whole process really quickly and easily. Git is actually a free tool that you can download and run through command line off your computer. Finally, you want to be able to merge files that you may be working on, say for instance a different branch, which is a new feature. You want to be able to merge those files back into the master directory, the master branch that's running on Git itself. So some of the things to point out with Git, what makes it really useful is that it's absolutely brilliant at being able to track changes in your source code. This is something that source code tools really kind of should be able to do, but Git is exceptionally good at this. Having large teams working at different phases within the project and working on different branches within the project is really easy to do, and the collaboration tools within Git make it so that your teams can work effortlessly with each other. Inherently, you are creating backups of all your code, which is fantastic. And probably the most important part is that the environment itself is a non-linear environment. This means that you don't have to work through specific gates to be able to reach feature, to actually get a feature ready for delivery. You can actually work in a non-linear fashion. So who's using Git? Well, as you can imagine, all of the big technology companies are using Git, including Netflix, Lyft, and Intel, plus many, many other companies. So let's get on to our next tool, which is MAVEN. And the focus on MAVEN is to automate the build process of code that's being checked into a repository, such as a Git repository. So if we have a look at the architecture here, MAVEN itself actually executes what are called POM files, and those POM files actually then look for specific dependencies that will then go against a repository to be able to build out the project. You can actually extend the POM files with plugins, and you can actually then create a specific build profile for your environments, which is actually fantastic because you can really fine-tune the profile. And again, all of this is scripted, and this is something that is common with all the tools that you'll be using in a true DevOps environment, is that you can script all of them, which means that you can automate the processes that are in your DevOps environment and really accelerate the ability to be able to build consistent, high-quality software. Final step for a MAVEN environment is to actually build all the software into in our build server. So a couple of things that are important to notice with MAVEN. One of the things that you'll see that's key with all of the tools that we have here, really easy to use. MAVEN itself has got a pretty simple setup. It's highly available, which means that your teams can rely on the solution being ready for your environment, and you can actually get to it and use it very easily and consistently. You can have multiple builds happening at the same time, which is really important, particularly if you have branched software and you want to be able to test the branches. And the other thing as well is that it's open source, so you have instant access to new features without any additional configuration. So it really helps your teams to get the new code and implement new features within the environment itself, so you're always working on the latest and greatest. As you can imagine, DevOps shops such as Zillow and Zenz and JP Morgan and Chase are already using MAVEN, and you'll see that many DevOps shops are also using MAVEN for their build software. Testing with Selenium is very important, and being able to automate that environment is critical so you can actually guarantee that your code will work. And Selenium itself is designed for testing and automating web applications. It's really good in that environment. If we look at the architecture, the way that it works is that you actually have a client library that goes against the code you're writing, whether that's C#, Python, Java, JavaScript, and then there are specific drivers that go against the web browsers to actually test out the code that you have created so that you can actually see whether it works in the appropriate web browsers. And all of the popular web browsers are supported with Selenium. Selenium is an open source solution. It does allow you to write scripts in multiple different languages, which is a real big bonus. You can as well run parallel test execution, so this balances very well with MAVEN. And as with other tools that we have, it's really easy to use. And Selenium is being used by Google, HubSpot, and Salesforce, as well as many other companies. So let's talk about the really important part, which is integrating all of this. And Jenkins really is the de facto tool in this space. And so the role of Jenkins is to be able to manage and allow for that continuous integration that you need to make DevOps successful. So allowing the development team, to integrate effectively with the ops, the operations team, and do that through testing and management of the code that is being created. So if we look at the architecture here, we have our remote source code repository. It's going to be waiting for a Jenkins pull to be able to create a commit, and then that Jenkins serve master will then push out and distribute the work to multiple slaves so that you can actually have the actual code being pushed around your environment. So Jenkins is really easy to use. It's very mature. It's been around for many years. There are a significant number of plugins that allow for the Jenkins environment environment to be scaled very effectively, and it is portable across multiple platforms. In fact, most of the leading operating systems will support Jenkins. And as you can imagine, Jenkins is being used by companies such as LinkedIn and Microsoft, eBay, Dell, and Cloudera. So let's talk about the other side of DevOps and talk about some of the operations tool. And we'll start off with Docker. So the role of Docker is to make it easy for people to be able to simulate full environments quickly and easily on their desktop for building and testing, but at the same time make that real easy to be able to port those environments across multiple areas. So let me talk a little bit about how that would work. So with the Docker engine, you have a Docker client locally that allows you to emulate the whole Docker environment without having to have the overhead that you would typically have if you're doing virtualization or dedicated servers running specific dedicated operating systems. Because you are scripting the entire environment, Docker is a very scalable and repeatable environment for being able to take across the entire cloud network. So some of the features that are really important for Docker, it's incredibly portable across multiple platforms. The Docker team have done a fantastic job on portability. It does run in isolation. So what this means is that you can actually have multiple Docker environments running on a server concurrently, and they will not interrupt each other. They actually fully isolated sandboxed environments. So the other part to Docker is because it is stripped of needless operating system and host environment APIs and services, the actual startup and boot time for Docker is really very fast, which in turn makes this very scalable and efficient to run. And you can actually reuse volumes very easily. So who's using Docker? Just about everybody. Spotify, Uber, PayPal, BBC. Really, Docker is used by a lot of people. Just a side note, probably something that would complement Docker very well is Kubernetes, and Kubernetes is becoming a very popular alternative to Docker, and so really get to know both of those tools. So let's talk about some of the operation and management tools that you have for your environment, and the three big ones here are Chef, Ansible, and Puppet, and we'll start with Ansible. And Ansible is a configuration software package, and unlike the other two products here, unlike Chef and Puppet, Ansible doesn't actually require a client to run on the host server where you're pushing out a configuration. You can actually have a defined operation configuration, so like a web server configuration or a database configuration or an IoT cloud configuration. You can actually have that running effectively from a script that is written on a client machine and then on your local machine, and then you can push that script that you've created out to your remote servers and have everything work as you'd expect quickly on your remote servers. Just some of the key features of Ansible. It's incredibly lightweight. One of the things that's really important with Ansible is that it's actually very easy to use. There is, unlike the other two tools we'll be covering, unlike Puppet and Chef, Ansible actually has a full GUI that you can use to actually interact and build out solutions. So there is a visual interface that you can actually go in, so you're not just working completely in command line. Companies that are using Ansible include Twitter, EA Sports, Cisco, and NASA, as well as Verizon. So complementing Ansible, but probably a little bit more popular right now, are Chef and Puppet, and we'll cover Chef first. Both Chef and Puppet are somewhat similar in configuration, and both of them rely on having a client-server relationship with their architecture. The way that Chef works is that Chef actually creates recipes, and each recipe is a server configuration setup, and what you actually do is you create individual recipes, and then for your entire network you create what's called a cookbook, and that cookbook actually can be used to control the setup of your entire network. And this works really well for being able to create consistent and highly scalable environments. The things that are great with Chef is that it's actually a very flexible configuration, and you can actually do an awful lot with it. It has really good security features, which are very appealing to, particularly if you have a DevSecOps environment where the security team team are integrated with your DevOps environment, and that's something that's becoming more and more popular. Chef itself is actually pretty easy to use. It is a command line tool, but it is actually fairly easy to use, and the actual scripting of the recipes is something that you can do even if you don't have much scripting experience. It's something, there are so many recipes out and available, you can actually use many of the templates that have already been written and just either copy them or modify them to your environment. As you'd expect, a lot of the companies using Chef are the big technology companies such as Facebook and IBM. Microsoft in particular has really invested heavily in Chef. In fact, you'll find that Chef is probably the most popular management tool used within the Azure environment. So a complementary product to Chef is Puppet, and if we look at Puppet, as you can imagine, it's again another open source configuration tool. The structure, as you can see, is actually very similar in concept to Chef, in which you have a local server that actually has all the configuration environments, the templates and the files and the manifests, and it will actually then communicate with all of your entire environments, such as, and with Puppet they refer to them as nodes, and within your node you have multiple servers. But it's similar in concept to Chef in many ways, in that it's just another way of being able to control your environment. Both are really great tools. In fact, really all three of them, Ansible, Chef and Puppet, are great tools. What you have to do as a DevOps team is really just decide which tool is the one that's appropriate for your environment. So some things that are great with Puppet: it's multi-platform compatible, it's very scalable, and it allows you to push out changes to your environment really fast. And who are using Puppet? You know, got Red Hat, HP, Google. Leading DevOps teams are using Puppet today. So let's get into the two tools that we have that actually monitor our operations environment, Splunk and Nagios. So Splunk is, as you expect, is a monitoring tool, and its goal is for actually monitoring the operations of all the environments that you have, make sure that they're working correctly. And it does this by going through and reviewing your entire environment and writing the operational information to disk, and then searching that environment to make sure everything works correctly. It does a lot of analysis in real time. It is a very easy to set up and use tool for testing for analysis, and to then be able to then troubleshoot any failures that may come up. The thing that's great about Splunk is that you can actually put it in a distributed environment so that it's no single point of failure, which makes it itself inherently very scalable. So Cisco, Facebook, Domino's Pizza, Dubai airports are all customers that are using Splunk today in their DevOps environments. So finally, let's jump into our final monitoring tool, which is Nagios. And very similar to Splunk is Nagios. Probably the big difference is that it's client server setup, but really, again, it's all about being able to monitor and check the status of your entire environment and your network and your servers in real time, and give you the appropriate visualizations, whether it's on your laptop or whether it's an alert that's sent out to your phone, and so you're aware in real time how your network is performing and can then check and adjust to actually making changes. And the bottom line in this kind of architecture with Splunk and Nagios is that it allows you as the operations lead to be able to be ahead of any perceived impact. So say for instance you are putting in specific check marks for your environment, you can actually have alerts being sent out to your team when certain thresholds are met, and so that means that you are aware of problems with your environment before your customer is. There's nothing worse than somebody emailing and saying, hey, your website doesn't work, or like a page is down, or it's slow, or something like this. With Nagios and Splunk, these are tools that really address those kind of problems so that you stay ahead of the curve. So some of the things that are really good with Nagios is Nagios itself is very comprehensive. You can do an awful lot with it, and it allows you to be able to get to the root of monitoring and analyzing your problems within your operations and network environment very quickly. It has a very modular architecture, which also then makes it extremely highly available, because the system itself is not reliant on just a single large application. Actually, the modular architecture allows it to be scalable and very easy to manage across the entire environment. Companies using Nagios include Uber and Hike and Webedia. Again, these are all technology companies, but there's no reason why you shouldn't be using them as well. A little scenario before using Git. One of the challenges that a lot of developers and development teams would have had is developers would be working on different types of code, whether it was database code, whether it was Python, or whether it was Java or .NET, and they would have a central server that they would be pushing all of their source code in. But there was little or no communication that was actually going on in between all the developers. The challenge you had with that scenario is that when people would be checking in code, you could be like, there'd be conflicts and you'd have to roll back different code versions. And this is really kind of the challenge that Git addresses. Git is a tool that allows all of the developers, no matter what stack they're working in, to have access to all of the code. And it makes it much more effective at being able to have development teams work on small, medium, or even massive applications. And some of the biggest applications out there are managed through a Git distributed server environment. So let's jump into what we'll be covering so you have a clear understanding of the value that you're going to get out of watching this presentation. So we're going to go through DevOps and the tools we have available for DevOps. We'll talk about what version control means within a DevOps environment and cover the two different types of version control, centralized and distributed. And then we're going to zero in on Git, which is a really fantastic distributed version control system. And we're going to go through and understand the features, workflow, branches, and commands in Git. We're going to give you a demo and then summarize all of the activities at the end of the presentation. So, what is DevOps? Well, this is one of my favorite questions. I love the idea of what DevOps is. So DevOps really is a culture of being able to deliver solutions faster, where your development teams and your operation teams work effectively together. The idea is to be able to continuously build out solutions and have testing codes that's built into your solutions, so that no matter where they are in the stage of the integration and deployment lifecycle, they're always being tested and you can always have code getting ready to be released out. The idea is that instead of having big releases that you would have maybe once every 2 weeks or once a month, that you would actually have a continuous stream of releases, because you always have code that is being tested. You have your network that's being tested, you have your environment being tested, and you'll be able to provide feedback directly to the appropriate person, whether they're in devs or whether they're in ops, to be able to be successful at being able to deliver solutions faster. The bottom line, your dev team thinks like operations, and your operations team begin to think like developers. It's really a fantastic way of being able to speed up delivery and have your team just think and feel and act in a different cultural environment. So let's have a look at some of the tools that are available to you in DevOps environment. If we look at DevOps, it's really kind of split into two areas. The dev side, you have building, code, planning, and testing. And then on your ops side, you have release, deployment, operating, and monitoring. But the tools really all interact with each other. And what's really great is that the tools are either open source or very, very low in cost. And in fact, most of the tools that you're seeing in front of you right now are open source tools, which means there's no licensing to you, and you can actually effectively manage them and implement them within your team right now. So let's have a look at some of the dev tools that you have for doing code versioning. And so some of the tools that you may have used in the past include Subversion, Team Foundation Service, and Git. These are all different types of version control software that you have out there. One of the oldest ones is Subversion. It's a centralized version control system. It's one of the tools I used years ago. It really is good at doing what it's supposed to do, which is just a very simple version controlled solution. It's open source, so it's free. There's no licensing. There are challenges with working with it because it is a centralized tool rather than a distributed tool, and we'll get into that in a little bit. But for a very basic version control system, it does what you want it to do. Team Foundation Service Solutions is something that many of you in Microsoft world may have been using for a long time. And the thing that's great about TFS is that it's built right into the Microsoft environment. It's the server side, the services side of building out your solutions with Microsoft. Just recently, in the last couple of weeks, at the beginning of September 2018, Microsoft actually just rebranded TFS as Azure DevOps, and so you have Azure Pipelines, and there are 5 now Azure tools that actually replace TFS. But these are all tools that are very similar in concept. The old TFS tools are very similar to the centralized SVN tools, whereas the new tools that are part of Azure are actually much more aligned with Git. So what you're seeing is Microsoft moving from the centralized server to a distributed server with their new Azure DevOps tools, which is fantastic news for every developer listening to this. And then we have Git, and Git is a distributed version control system. It is, again, open source, which means that you can start using it right now without fear of having to have any costs or any penalties. And the thing that's really good about it is that you can use it for almost any kind of digital project. And what it's good at is being able to create that historical record and versioning of your source code, whether you're doing a web application, a mobile application, or you're actually building a Python script for a machine learning solution. So let's dig into what version control systems are and how they can be of value to you. So the role of a version control system is to allow developers to be able to check in their files into a repository. And here you can actually see how we can check in 3 files into a repository, and that repository then becomes a snapshot or a historical record of the files that we're working on. And you want to be able to have it so that the repository is flexible enough so that as you want to be able to scale and add in new files or new versions of a file, that you can actually do that easily within your VCS environment. And the goal is to be able to constantly have each of these versions available so that anybody that wants to be able to check out the file can actually have the latest version or see a history of how that file became what it is today. Let's look at centralized version control systems, and then we'll compare it against distributed version control systems. So a centralized version control system has a central server where all the files are stored, and everybody has to check in and check out from that centralized server, and all of the versions are managed within that server environment. The problem is that if that central server crashes, which doesn't happen but very often, but it can happen, you end up losing all of your files. And I was actually on a project where that actually happened to us, and we lost 6 months of history of how the application was created. Fortunately for us, we actually had a backup, but it didn't have all the historical data, so we were able to at least continue working, but we just lost a lot of files and it took a while to get back into place. So let's now look at and compare this to a distributed version control system. With a distributed version control system, you still have a centralized server that manages the files. But the difference is that as a developer, you check out all of the files for a project. So you can actually manage the whole project locally on your development machine and make your changes. And then you can just check in and out the changes that you've made to the centralized server. The opportunity you have here is that the server itself, if it goes down, you're not going to be in a situation where you lose all of the history, because everybody that's working on the actual application has all of the versions of the code locally on their machine. Now, one of the more popular distributed version control systems that out there is Git. I mean, it really is probably the most popular by a margin compared to a system out there. So, let's dig into, what actually is Git. So Git is a version control system for managing files, and as a developer, you have a Git client on your machine, and you're able to make changes and create local repositories of a program on your computer, and then you can sync up with a remote service such as GitHub or GitLab or the new Azure Labs environment, where you can actually store files remotely and then allow remote teams to have access to those changes in the actual application you made. So you can track your changes easily. The tool is inherently distributed, so it makes it very easy to manage the code for large teams. And you can bring people in very quickly, and you can have people come in as specialists and spin them up quickly and have them work on a piece of the code and then drop them out of the project. If you want to have a check on how this works, go and start contributing to any of the many thousands of open source projects at GitHub, where you can go in with your Git tools and just contribute to those projects. And then finally, one of the things that I really like with Git is that it's not a linear development approach. It's not starting from A and going to Z. It's a non-linear approach, which allows you to have branches that people are working on in parallel to your master branch, where people are actually doing the delivery of the production code. So let's step through some of these features. So Git, as you can imagine, the first thing it does is track history. That's probably the most important part of having a version control system. It's free open source. You can actually go and use it right now. There are no costs for actually using it. It is a non-linear environment that allows people to be able to build out new features in parallel to the master branch so that you can be constantly having the master code out there without and adding in new features without breaking the code. And you can automatically create backups because each developer has a version of the code remotely. It's incredibly scalable. Some of the biggest projects out there now are being managed through Git. And because of this scale, the collaboration becomes a byproduct of teams working together. And branching just is so much easier within Git. So as you can see, this whole thing leads to a very effective distributed environment. So let's step through some of the workflow that we have available for Git. So the way that Git works is that you as an operator, as a developer, you have the Git client on your local development machine, whether that's a Linux machine, a Mac, or a PC, and you connect to a remote server and you pull down the latest working copy, and then you're able to make all of your changes locally, and you can modify the codes, you can review changes, and you can commit those codes to your Git repository that you have locally, and then you can push those changes back up to the remote server. And as soon as you push them into the remote server, those changes then become available to everybody else working on the project. So they can be constantly keeping everybody updated on all the work that is happening. So, typically the way that it would work is, you would start off with having the working file, the working directory that you have locally, and then you would stage those files into a staging area, and then you get those files ready to be committed to your Git repository. And these are all actions that you would do locally and then connect to a remote server. And then later when you go back into work on your project, the first thing you should always do is check out that code so that you always have the latest version of the code and everybody's kept in sync. So let's talk about branching in Git. So the way that branches work is that if you imagine you're working on a project, and projects always have a tendency of getting bigger than you imagine. And what you want to be able to do is keep that main product working and keeping it working effectively. But if you want to be able to add a feature to that product, you may have 2 or 3 different groups that are working on multiple features simultaneously. And what you want to be able to do is give them the freedom to work on those individual features. And the way you do it in Git is that you can create branches off the master, and while you're off the main branch, which is called the master. And so each person could be working on their own separate branch, and then when they want to, they can then later merge those branches back into the main master. And all this time, the main master still works and still able to produce the right code for the customer, but at the same time it allows the developers the freedom to be able to write in their new features. And so we can look at this in a little bit more visually with the master branch, and we can put in small features and large features, and we can then merge them back as we need to. So this kind of covers some of the commands that we have in Git. So the first command you'd want to use is called git init, and that's allowing you to go into a folder on your local PC or your local Mac and convert that folder into a local Git repository, and that creates that repository. Then you want to be able to make changes to that repository, and the commands you'd be using in this instance would be add, commit, or status. You want to be able to sync your repositories with the remote server. So be able to put the code that you have on your computer on the remote server, you use push. You want to get the code from the remote server, you'd use pull and then add origin. And then if you want to do parallel development from the master branch, the main branch, you would use branch, merge, or rebase as ways to be able to do parallel development. And now we're going to go through and do a demo on Git. So we're going to do a demo on Git so you can feel comfortable running the commands in the interface and you're able to get Git running correctly in your environment. So the first thing we're going to do is we're going to set up which version of Git that you have, and then we're going to see if we can establish some global configurations within your Git environment. And we're going to do sandeep.dash as the name, the email address is sandeep.simplylearn, and then we're going to do a list of the different configuration settings we have. So to check the version of Git that we have, we do git -- version in our terminal or command line window. You can also use PowerShell. That'll actually get you running in the same environment as well. All of these tools are going to be command line tools. And then the next thing we're going to do is we're going to assign some global usernames and a global email address so that we can actually access the Git account itself locally on the device. And so we're going to put in config -- global user.name Sandeep, and then git config -- global user.email and sandeep.d@simplilearn.net. And now we're going to check the list of usernames and email IDs in our configuration environment with -list, and you'll see that we have everything in there correctly. Here is our username right here, and our name and our email ID. So if you need any help when you're actually doing any of your work in Git, all you have to do is do git help config or git config -- help, and this will allow you to actually get access to the help screens. So let's just go and type that in: git help config, return, and this takes us to the help page that's running locally on your device. And here we have a breakdown of all the different commands and what those commands actually do within a Git configuration. And we can go ahead and we can do git config -- help, and that will actually take us to the same page. So two ways of doing the same thing. So we're going to go ahead and we're going to create a test repository on our local system, and we're going to do that with make directory called test, and then we're going to move our cursor within command window, terminal window, to the test folder, and then we're going to initialize that folder to become a Git repository. So let's go ahead and do that. So we're going to make a new directory and we're going to call it test, and we're going to move the cursor so it's actually in the test folder. We do cd change directory to test, and you can see now we're actually in the test folder. And now what we have to do is initialize this folder as a Git repository. And so we're going to do this as git init, and it's now a new Git instance that we can actually now use for managing our Git environment. So we're going to create a new file and we're going to call it info.txt, and we're going to put some content in it, and we're actually going to put it in the folder that we've just created, so you can actually see what it's like to test out the Git environment with a file that hasn't been checked into it yet. So let's go ahead and do that. So we open up our folder directory, and here you can see we have the test folder, and we're just going to go ahead and create a default test file. So right click, text, new document, info.txt, open that, and you can put really whatever you want in here. We're just going to put in this information right now: name equals Sam, registration number 12479, and save that file, close it out. Now if we actually go ahead and run a git status command, you'll see that the info.txt file is in red. That's because that file has not actually been checked into the project. It's a new file that we've added, but it hasn't been committed yet into the Git repository. So let's go ahead and see what it takes to actually add the file to the Git repository that we just created. So we're going to do that by doing git add info.txt, and then we're going to commit that into the history of that Git repository. So it now has version control, and we can start doing forking and other kind of similar activities when we connect later to our GitHub Git environment. So we do git add info.txt, and remember we're actually still in the test folder, so it's going to look for that file in that folder and just add it in. And now if we go ahead and do git status, we'll actually be able to see that the info.txt file is in an active color. First of all, we have to commit it, so we go git commit -m, and then we're going to commit, and we add in some quick text here. You can write whatever you want. Committing the text file is now actually committed into the Git repository, and it's still running locally on your PC. So we're going to go make some changes to the file, and we're going to save it, and we want to be able to see how we can use Git to compare the differences between the two files. So let's go over and we're going to make some changes to the info.txt file. Here we are, here's info.txt. We're just going to add in a new line. We're going to add in the line address, and we're going to save that file. And now when we go over to Git, we're going to be able to review the difference. So we're going to do git diff, and here you actually see that we've added in a new address file. So now you can actually see this is the difference between the two documents. Now, as you can imagine, when you have code, this would become more elaborate, where actually will show you code that's been pulled out if you've eliminated any code, or if you added in new code. Really useful. So we're going to go ahead and add our Git username to a remote location so we can actually start testing out the file that we've created into a remote repository. In this case, we're going to use GitHub, and you'll be able to see how we can actually then save that file into a Git repository that somebody else could then access and be able to make edits to. So let's just go ahead and make those changes. So git config -global user.username, and we'll do Simplilearn, and that will associate it with this Git repository that we've just created locally. So Simplilearn-GitHub. So Simplilearn GitHub is the username that we use on GitHub. So we're going to go over to GitHub. Here we are in GitHub, and then correct new repository. And then, as you can see, we're in Simplilearn-GitHub, and we're going to call the new repository test. We're going to make it public so anybody can access it. And you'll see that it automatically adds a README file, and we have our test environment set up correctly. So we'll go ahead and copy the URL link, which is github.com simplilearn-github/test.git. Copy that, and we'll go back over to our command line window. And so now we're going to add the username to the GitHub configuration. So what we're doing is we're connecting the local repository to the remote repository. So we type git remote add origin, and then we'll paste in the address. And this then allows us to connect the local repository that we created in the test folder with the remote repository. And now we're connected. So now that we've connected, we can actually push the file that we have in the local repository on your PC or Mac to the remote repository in the GitHub server environment. So let's go ahead and do that. So we're going to do git push, and push is the command to push the documents from the origin, which is the local file, to master, and master is a remote file. Hey, and there we are. Success. So what we have now is the file that we just created in our local Git repository is actually now in the remote repository as well, so anybody can access it. So let's go have a look at that. So we're going to refresh the GitHub page, and hey, there we are. There's info.txt has been uploaded, and we're ready to go. That's great. That's what you should be seeing. So refreshing your web page on the remote GitHub folder, and it could be any Git service, but we just happen to be using GitHub because it's free to use. You'll be able to see that the local file has been installed and is now part of the Git repository in the remote server. So what we're going to do now is we're going to create 3 more files, and we're just going to call them info.txt, info2, and info3. And then we're going to push them out to the remote server, and we're going to merge everything together into a single environment. So let's go ahead and create those 3 files, and we're just going to add those into the folder. So let's go ahead, create new text document, info1, and then we're going to create info2, and then info3. Get my typing right here. Okay, here we go. There we are. Okay, I'm opening info3, and I'm just going to enter some text in here. And what we're going to do is illustrate how we can do branching. And each of these files I'm going to save and then close out. And now I can go over and so let's create a new branch, and we're going to call this one first_branch. And we go git branch first_branch, and this will be a new branch of the code environment that we're creating. And so hit return, and that allows us to create a new branch. And so what we do is we're going to move to the new branch. So we're going to do git checkout first_branch, and that allows us to move into that branch. And you'll see that info.txt is already there, which is good. That's what we want to see. Now what we need to do is add in the new documents. So here we have the different steps we've taken. We created a branch, we moved to the new branch, and now we're going to go ahead and add the info3 txt to that branch so you can actually see everything coming together. And we're going to go at git add info3.txt. So we're just adding a file like we were previously with our initialization, our first initial Git folder, and that file has now been added to the first branch. So we're going to go ahead and commit the file to the first branch, and then we're going to merge the documents into the master branch so we have everything together. So let's go ahead and do those steps. We're going to do the commit first, and then we're going to merge everything together. All right, so we do git commit -m, and we're just going to say made changes to first branch, and that's just documentation so that we know what we've done. And there we are, we've committed the file. So we had that file info3 txt committed, and now we're going to go ahead and merge the files into the main master, and so we can actually have everything together as one consistent environment. And we do that by typing in. So this lists out what we have in our master file. So we just do ls and that will shows everything in the folder. And we have info.txt, info1.txt, info2.txt, and info3.txt are now all in the first branch. So let's go ahead and we're going to merge. Okay, so actually before we merge, we have to check out the master branch. So we do git checkout master. So it gets us into the master branch, and you'll see that we have just one file there, info.txt. So we're going to list out the files in the master branch. And so what you'll see is info.txt, info1.text, and info2.text are there. But info3 text isn't there because that was created in a separate branch. So let's go ahead and merge the first branch into the master branch. So we do git merge and we do first underscore branch, and there we are, we've merged it in, and excellent, that looks good. So let's go ahead and list out the files that we have in the master branch, and we do ls, and then you'll see that we have 4 files including the info3.txt that we had in a separate branch, now all in the master branch.
So if you're ready to embrace this exciting career path, look no further than Simplilearn's Caltech postgraduate program in DevOps. This comprehensive program will equip you with the knowledge and skills needed to master the DevOps principles, tools, and practices. Dive deep into containerization, orchestration, and automation frameworks like Docker, Kubernetes, and Jenkins. Gain hands-on experience with cloud platforms and learn how to leverage the power of infrastructure as code. Don't miss out on this chance to transform your career and become an invaluable asset to any organization. Click the link in the description to discover more about this DevOps course.
So what are we going to cover today? So we're going to introduce the concept of version control that you will use within your DevOps environment. Then we'll talk about the different tools that are available in a distributed version control system. We'll highlight a product called Git, which is typically used for version control today. And you'll also go through what are the differences between Git and GitHub. You may have used GitHub in the past or other products like GitLab, and we'll explain what are the differences between Git and services such as GitHub and GitLab. We'll break out the architecture of what a Git process looks like. How do you go through and create forks and clones? How do you have collaborators being added into your projects? How do you go through the process of branching, merging, and rebasing your project? And what are the list of commands that are available to you in Git? Finally, I'll take you through a demo on how you can actually run Git yourself. And in this instance, use the software of Git against a public service such as GitHub. All right, let's talk a little bit about version control systems. So you may have already been using a version control system within your environment today. You may have used tools such as Microsoft's Team Foundation services, but essentially the use of a version control system allows people to be able to have files that are all stored in a single repository. So if you're working on developing a new program, such as a website or an application, you would store all of your version control software in a single repository. Now, what happens is that if somebody wants to make changes to the code, they would check out all of the code in the repository to make the changes, and then there would be an addendum added to that. So there would be the version 1 changes that you had, then the person would then later on check out that code, and then be a version 2 added to that code. And so you keep adding on versions of that code. The bottom line is that eventually you'll have people being able to use your code, and that your code will be stored in a centralized location. However, the challenge you run in is that it's very difficult for large groups to work simultaneously within a project. The benefits of a VCS system, a version control system, demonstrates that you're able to store multiple versions of a solution in a single repository. Now let's take a step at some of the challenges that you have with traditional version control systems and see how they can be addressed with distributed version control. So in a distributed version control environment, what we're looking at is being able to have the code shared across a team of developers. So if there are 2 or more people working on a software package, they need to be able to effectively share that code amongst themselves, so that they constantly are working on the latest piece of code. So a key part of a distributed version control system that's different to just a traditional version control system is that all developers have the entire code on their local systems, and they try and keep it updated all the time. It is the role of the distributed VCS server to ensure that each client, and we have a developer here and developer here and developer here, and each of those are clients, have the latest version of the software, and then that each person can then share the software in a peer-to-peer like approach. So that as changes are being made into the server of changes to the code, then those changes are then being redistributed to all of the development team. The tool to be able to do an effective distributed VCS environment is Git. Now, you may remember that we actually covered Git in a previous video, and we'll reference that video for you. So we start off with our remote Git repository, and people are making updates to the copy of their code into a local environment. That local environment can be updated manually and then periodically pushed out to the Git repository. So you're always pushing out the latest code changes you've made into the repository. And then from the repository, you're able to pull back the latest updates. And so your Git repository becomes the kind of the center of the universe for you. And then updates are able to be pushed up and pulled back from there. What this allows you to be able to accomplish is that each person will always have the latest version of the code. So what is Git? Git is a distributed version control tool used for source code management. So GitHub is the remote server for that source code management, and your development team can connect their Git client to that remote hub server. Git is used to track the changes of the source code and allows large teams to work simultaneously with each other. It supports a non-linear development because of thousands of parallel branches and has the ability to handle large projects efficiently. So let's talk a little bit about Git versus GitHub. So Git is a software tool, whereas GitHub is a service, and I'll show you how those two look in a moment. You install the software tool for Git locally on your system, whereas GitHub, because it is a service, it's actually hosted on a website. Git is actually the software that's used to manage different versions of source code, whereas GitHub is used to have a copy of the local repository stored on the service, on the website itself. Git provides command line tools that allow you to interact with your files, whereas GitHub has a graphical interface that allows you to check in and check out files. So let me just show you the two tools here. So here I am at the Git website, and this is the website you would go to download the latest version of Git. And again, Git is a software package that you install on your computer that allows you to be able to do version control in a peer-to-peer environment. For that peer-to-peer environment to be successful, however, you need to be able to store your files in a server somewhere. And typically, a lot of companies will use a service such as GitHub as a way to be able to store your files. So Git can communicate effectively with GitHub. There are actually many different companies that provide similar service to GitHub. GitLab is another popular service, but you also find that development tools such as Microsoft Visual Studio are also incorporating Git commands into their tools. So the latest version of Visual Studio Team Services also provides this same ability. But GitHub, it has to be remembered, is a place where we actually store our files and can very easily create public shareable. Is a place where we can store our files and create public shareable projects. You can come to GitHub and you can do a search on projects. You can see at the moment I'm doing a lot of work on blockchain, but you can actually search on the many hundreds of projects here. In fact, I think there's something like over 100,000 projects being managed on GitHub at the moment. That number is probably actually much larger than that. And so if you are working on a project, I would certainly encourage you to start at GitHub to see if somebody's already maybe done a prototype that they're sharing, or they have an open source project that they want to share that's already available in GitHub. Certainly if you're doing anything with Azure, you'll find that there are 45,000 Azure projects currently being worked on. Interestingly enough, GitHub was recently acquired by Microsoft, and Microsoft is fully embracing open source technologies. So that's essentially the difference between Git and GitHub. One is a piece of software, and that's Git, and one is a service that supports the ability of using the software, and that's GitHub. So let's dig deeper into the actual Git architecture itself. So the working directory is the folder where you are currently working on your Git project. And we'll do a demo later on where you can actually see how we can actually simulate each of these steps. So you start off with your working directory where you store your files, and then you add your files to a staging area where you are getting ready to commit your files back to the main branch on your Git project. You want to push out all of your changes to a local repository after you've made your changes, and these will commit those files and get them ready for synchronization with the service, and will then push your services out to the remote repository. An example of a remote repository would be GitHub. Later, when you want to update your code, before you write any more code, you would pull the latest changes from the remote repository so that your copy of your local software is always the latest version of the software that the rest of the team is working on. One of the things that you can do is, as you're working on new features within your project, you can create branches, you can merge your branches with the mainline code. You can do lots of really creative things that ensure that A, the code remains at very high quality, and B, that you're able to seamlessly add in new features without breaking the core code. So let's step through some of the concepts that we have available in Git. So let's talk about forking and cloning in Git. So both of these terms are quite old terms when it comes to development, but forking is certainly a term that goes way back, long before we had distributed CVS systems such as the ones that we're using with Git. To fork a piece of software is a particular open source project. You would take the project and create a copy of that project, but then you would then associate a new team and new people around that project. So it becomes a separate project in entirety. A clone, and this is important when it comes to working with Git, a clone is identical with the same teams and same structuring as the main project itself. So when you download the code, you're downloading an exact copy of that code with all the same security and access rights as the main code. And then you can then check that code back in, and potentially your code, because it is identical, could potentially become the mainline code in the future. Now, that typically doesn't happen. Your changes are the ones that merged into the main branch, but you do have that potential where your code could become the main code. With Git, you can also add collaborators that can work on the project, which is essential for projects particularly where you have large teams. This works really well when you have product teams where the teams themselves are self-empowered. You can do a concept what's called branching in Git. And so say, for instance, you are working on a new feature. That new feature and the main version of the project have to still work simultaneously. So what you can do is you can create a branch of your code so you can actually work on the new feature, whereas the rest of the team continue to work on the main branch of the project itself. And then later you can merge the two together. Pull from remote is the concept of being able to pull in services, software the team is working on from a remote server. And Git rebase is the concept of being able to take a project and re-establish a new start from the project. So you may be working on a project where there have been many branches and the team has been working for quite some time on different areas, and maybe you kind of losing control of what the true main branch is. You may choose to rebase your project. And what that means though is that anybody that's working on a separate branch will not be able to branch their code back into the mainline branch. So going through the process of a Git rebase essentially allows you to create a new start for where you're working on your project. So let's go through forks and clones. So you want to go through the process. So you want to go ahead and fork the code that you're working on. So let's use this scenario that one of your team wants to go ahead and add a new change to the project. The team member may say, yeah, go ahead and create a separate fork of the actual project. So what does that look like? So when you actually go ahead and create a fork of the repository, you actually go and you can take the version of the mainline branch, but then you take it completely offline into a local repository for you to be able to work from. and you can take the mainline code and you can then work on a local version of the code separate from the mainline branch. It's now a separate fork. Collaborators is the ability to have team members working on a project together. So if someone is working on a piece of code and they see some errors in the code that you've created, none of us are perfect at writing code. I know I've certainly made errors in my code. It's great to have other team members that have your back and can come in and check and see what they can do to improve the code. So to do that, you have to then add them as a collaborator. Now you would do that in GitHub. You can give them permission within GitHub itself. It's really easy to do, super visual interface that allows you to do the work quickly and easily. And depending on the type of permissions you want to give them, sometimes it can be very limited permissions. It may be just to be able to read the files. Sometimes it's being able to go in and make all the changes. You can go through all the different permission settings on GitHub to actually see what you can do. But you'll be able to make changes so that people can actually have access to your repository, and then you as a team can then start working together on the same code. Let's step through branching in Git. So suppose you're working on an application, but you want to add in a new feature. And this is very typical within a DevOps environment. So to do that, you can create a new branch and build a new feature on that branch. So here you have your main application on what's known as the master branch. And then you can then create a sub branch that runs in parallel, which has your feature. You can then develop your feature and then merge it back into the master branch at a later point in time. Now, the benefit you have here is that by default, we're all working on the master branch. So we always have the latest code. The circles that we have here on the screen show various different commits that have been made so that we can keep track of the master branch and then the branches that have come off which have the new features. And there can be many branches in Git. So Git keeps the new features you're working on in separate branches until you're ready to merge them back in with the main branch. So let's talk a little bit about that merge process. So you're starting with the master branch, which is the blue line here, and then here we have a separate parallel branch which has the new features. So if we're to look at this process, the base commit of feature B is the branch. F is what's going to merge back into the master branch. And it has to be said there can be so many divergent branches, but eventually you want to have everything merge back into the master branch. Let's step through Git rebase. So again, we have a similar situation where we have a branch that's being worked in parallel to the master branch, and we want to do a Git rebase. So we're at stage C, and what we've decided is that we want to reset the project so that everything from here on out along the master branch is the standard product. However, this means that any work that's been done in parallel as a separate branch will be adding in new features along this new rebased environment. Now, the benefit you have by going through the rebase process is that you're reducing the amount of storage space that's required for when you have so many branches. It's a great way to just reduce your total footprint for your entire project. So Git rebase is the process of combining a sequence of commits to form a new base commit. And the primary reason for rebasing is to maintain a linear project history. When you rebase, you unplug a branch and replug it in on the tip of another branch. And usually you do that on the master branch, and that will then become the new master branch. The goal of rebasing is to take all the commits from a feature branch and put it together in a single master branch. And it makes the project itself much easier to manage. Let's talk a little bit about pull from remote. Suppose there are two developers working together on an application. The concept of having a remote repository allows the two developers will be actually then checking in their code into a remote repository that becomes a centralized location for them to be able to store their code. It enables them to stay updated on the recent changes to the repository because they'll be able to pull the latest changes from that remote repository so that they are ensuring that as developers, they're always working on the latest code. So you can pull any changes that you have made to your forked remote repository to your local repository. The command to be able to do that is written here, and we'll go through a demo of how to actually do that command in a little bit. Good news is if there are no changes, you'll get a notification saying that you're already up to date. And if there is a change, it will merge those changes to your local repository, and you get a list of the changes that have been made remotely. So let's step through some of the commands that we have in Git. So git init initializes a local Git repository on your hard drive. Git add adds one or more files to your staging area. Git commit -m commit message is a commit changes the Git command, commits changes to head up. So the Git command commits changes to your local staging area. Git status checks the status of your current repository and lists the files you have changed. Git log provides a list of all the commits made on your current branch. Git diff views the changes that you've made to the file. So you can actually have files next to each other and you can actually see the differences between the two files. Git push origin branch name, so the name of your branch command, will push the branch to the remote repository so that others can use it. And this is what you would do at the end of your project. Git config -global username will tell Git who you are by configuring the author name, and we'll go through that in a moment. Git config global user email will tell Git the author of by the email ID. Git clone creates a Git repository copy from a remote source. Git remote add origin server connects the local repository to the remote server and adds the server to be able to push to it. Git branch and then the branch name will create a new branch for you to create a new feature that you may be working on. Git checkout and then the branch name will allow you to switch from one branch to another branch. Git merge branch name will merge a branch into the active branch. So if you're working on a new feature, you're going to merge that into the main branch. A git rebase will reapply commits on top of another base tip. And git rebase will reapply commits on top of another base tip. And these are just some of the popular Git commands. There are some more, but you can certainly dig into those as you're working through using Git. So let's go ahead and run a demo using Git. So now we are going to do a demo using Git on our local machine and GitHub as the remote repository. For this to work, I'm going to be using a couple of tools. First, I'll have the deck open as we've been using up to this point. The second is I'm going to have my terminal window also available. And let me bring that over so you can actually see this. And the terminal window is actually running Git Bash as the software in the background, which you'll need to download and install. You can also run Git Bash locally on your Windows computer as well. And in addition, I'll also have the GitHub repository that we're using for Simplilearn already set up and ready to go. All right, so let's get started. So the first thing we want to do is create a local repository. So let's go ahead and do exactly that. So the local repository is going to reside in my development folder that I have on my local computer. And for me to be able to do that, I need to create a drive in that folder. So I'm going to go ahead and change the directory. So I'm actually going to be in that folder before I actually create and make the new folder. So I'm going to go ahead and change directory. And now I'm in the development directory. I'm going to go ahead and create a new folder. And that's gone ahead and created a new folder called Hello World. I'm going to move my cursor so that I'm actually in the Hello World folder. And now that I'm in the Hello World folder, I can now initialize this folder as a Git repository. So I'm going to use the git command init to initialize, and that's going ahead and initialize that folder. So let's see what's happened. So here I have my Hello World folder that I've created, and you'll now see that we have a hidden folder in there which is called .git. And if we expand that, we can actually see all of the different subfolders that Git repository will create. So let's just move that over a little bit so that we can see the rest of the work. And now if we check on our folder here, we'll actually see this is users Matthew development hello world.git, and that matches up with hidden folder here. So we're going to go ahead and create a file called readme.txt in our folder. So here is our hello world folder, and I'm going to go ahead and using my text editor, which happens to be Sublime. I'm going to create a file, and it's going to have in there the text hello world, and I'm going to call this one readme.txt. If I go to my hello world folder, you'll see that we have the readme.txt file actually in the folder. What's interesting is if I select the git status command, what it'll actually show me is that this file has not yet been added to the commits yet for this project. So even though the file is actually in the folder, it doesn't mean that it's actually part of the project. For us to do that, we actually have to go and select For us to actually commit the file, we have to go into our terminal window, and we can use the git status to actually read the files that we have there. So let's go ahead and use the git status command, and it's going to tell us that this file has not been committed. You can use this with any folder to see which files and subfolders haven't been committed. And what we can now do is we can go and actually add the README file. So let's go ahead and we're just going to select git add. So the git command is add readme.txt. So that then adds that file into our main project, and we want to then commit those files into the main repository's history. And so to do that, we'll hit the git command commit, and we'll do a message in that commit, and this one will be first commit, and it has committed that project. What's interesting is we can now go back into README file, and I can change this. So we can go hello Git. Git is a very popular version control solution, and we'll save that. Now what we can do is we can actually go and see if we have made differences to the README text. So to do that, we'll use the diff command for git. So we do git diff, and it gives us two releases. The first is what the original text was, which is hello world. And then what we have afterwards is what is now the new text in green, which has replaced the original text. So what we're going to do now is you want to go ahead and create an account on GitHub. We already have one. So what we're going to do is we're going to match the account from GitHub with our local account. So to do that, we're going to go ahead and select git config, and we're going to do dash, and it's going to be a global user name, and we're going to put in our username that we use for GitHub. In this instance, we're using the Simplilearn -GitHub account name. And under the GitHub account, you can go ahead and create a new repository name. In this instance, we call the repository hello-world. And what we want to do is connect the local GitHub account with the remote hello-world.git account. And we do that by using this command from Git, which is our remote connection. And so let's go ahead and type that in. Open this up so we can see the whole thing. So we're going to type in git remote add origin https github.com/simplylearn-github, and you have to get this typed in correctly when you're typing in the location hello-world.git. That creates the connection to your Hello World account. And now what we want to do is we want to push the files to the remote location using the git push command. Commit git push origin master. So we're going to go ahead and connect to our local remote GitHub. So I'm just going to bring up my terminal window again. And so let's select git remote, add origin, and we'll connect to the remote location, github.com/simplylearn-hello-world.git. Oh, we actually have already connected, so we're connected to that successfully. And now we're going to push the master, gish. So git push origin master, and everything is connected and successful. And if we go out to GitHub now, we can actually see that our file was updated just a few minutes ago. So what we can actually do now is we can go and fork a project from GitHub and clone it locally. So we're going to use the fork tool that's actually available on GitHub. Let me show you where that is located. And here is our branching tool. It's actually changed more recently with a new UI interface. And once complete, we'll be able to then pull a copy of that to our account using the fork's new HTTP URL address. So let's go ahead and do that. So we're going to go ahead and create a fork of our project. Now, to do that, you would normally go in, when you go into your project, you'll see that there are fork options in the top right-hand corner of the screen. Now, right now, I'm actually logged in with the default primary account for this project. So I can't actually fork the project as I'm working on the main branch. However, if I come in with a separate ID, and here I am, I have a different ID, and so I'm actually pretending I'm somebody else, I can actually come in and select the fork option and create a fork of this project. And this will take just a few seconds to actually create the fork. And there we are. We have gone ahead and created the fork. So you want to select clone or download with this. And so this is the, I select, that'll actually give me the web address. I can actually show you what that looks like. I'll open up my text editor. Oops, that's not correct. I guess that is correct. So I'm going to copy that. And I can fork the project locally and clone it locally. I can change the directory, so I can create a new directory that I'm going to put my files in and then post in that content into that folder. So I can now actually have multiple versions of the same code running on my computer. I can then go into the forked content and use the patchwork command to actually, so I can create a copy of that code that we've just created, and we call it, that's a clone, and we can create a new folder that we're actually putting the work in. And we could, for whatever reason we wanted to, we could call this folder patchwork, and that would be maybe a new feature. And then we can then paste in the URL of the new directory that has the forked work in it. And now at this point, we've now pulled in and created a clone of the original content. And so this allows us to go ahead and fork out all of the work for our project onto our computer. So we can then develop our work separately. So now what we can actually do is we can actually create a branch of the fork that we've actually pulled in onto our computer. So we can actually then create our own code that runs in that separate branch. And so we want to check out the branch, and then push the origin branch down to our computer. This will give us the opportunity to then add our collaborators. So we can actually then go over to GitHub, and we can actually come in and add in our collaborators. And we will do that under settings and select collaborators. And here we can actually see we have different collaborators that have been added into the project, and you can actually then request people to be added via their GitHub name or by email address or by their full name. One of the things that you want to be able to do is to ensure that you're always keeping the code that you're working on fully up to date by pulling in all the changes from your collaborators. You can create a new branch and then make changes and merge it into the master branch. To do that, you would create a folder, and then that folder in this instance would be called test. We would then move our cursor into the folder called test and then initialize that folder. So let's go ahead and do that. So let's create a new folder, and we're going to first of all change our root folder. We're going to go to development, and we're going to create a new folder. We call it test, and we're going to move into the test folder, and we will initialize that folder. And we're going to move some files into that test folder. Call this one test1, and then we're going to do file save as, and this one's going to be test2, and now we're going to commit those files. Git add, git add, and then we'll use the dot to pull in all files, and then git commit -m files committed. Make sure I'm in the right folder here. I don't think I was. And now that I'm in the correct folder, let's go ahead and git commit, and it's gone ahead and added those files, and so we can see the two files that were created have been added into the master. And we can now go ahead and create a new branch. We can call this one git branch test _ branch. And let's go ahead and create a third file to go into that folder. This is file 3. We'll do file save as. We'll call this one test3.txt. And we'll go ahead and add that file. And do git add test3.txt. And we're going to move from the master branch to the test branch. Git check out test _ branch. And it switched to the test branch. And we'll be able to list out all of the files that are in that branch now. And we want to go through and merge the files into one area. So let's go ahead and we'll do git merge test _ branch. And it's, well, we've already updated everything, so that's good. So otherwise it would tell us what we would be merging. And now all the files are merged successfully into the master branch. There we go, all merged together. Fantastic. And so what we're going to do now is move from master branch to test branch. So git checkout test _ branch. And we can modify the files, the test3 file that we took out, and pull that file up. And we can now modify it. And we can then commit that file back in. And we've actually been able to then commit the file with one changes, and we see it's the text-free change that was made. And we can now go through the process of checking the file back in, switching back to the master branch, and ensuring that everything is in sync correctly. We may at one point want to rebase all of the work. It's kind of a hard thing you want to do, but it will allow you to allow for managing for changes in the future. So let's switch to it back to our test branch, which I think we're actually on. We're going to create 2 more files. Let's go to our folder here and let's go copy those. And that's created. We'll rename those tests 4 and 5. And so we now have additional files. And we're going to add those into our branch that we're working on. So we're going to go in and select git add -a, and we're going to commit those files. Git commit -a -m, adding 2 new files, and it's added in the 2 new files. So we have all of our files now. We can actually list them out, and we have all the files that are in the branch. And we'll switch then to our master branch. We want to rebase the master, so we do git rebase master, and that will then give us the command that everything is now completely up to date. We can go git checkout master to switch to the master account. This will allow us to then continue through and rebase the test branch and then list all the files so they're all in the same area. So let's go git rebase test underscore branch, and now we can list, and there we have all of our files.
Today, I'm going to cover a few essential Git commands and walk you through a demonstration for most of it. I begin by installing a Git bash or the Git client and configuring it for its first time usage. Once I'm done with configuring the Git client, I'm going to spin up few repositories locally and work on these repositories using Git commands. Once I'm happy with my local changes, I'm going to commit few of them and then push these changes to a Git server of my choice. For today's demonstration, I plan to use github.com, which is a cloud-hosted free service, and it provides free account registrations for anyone. Eventually, I will cover a few topics regarding Git branching and merging, because these two, in my opinion, are the killer features of the Git distributed version control tool. Git is one of the most popular distributed version control tools of recent times, and like any other distributed version control tool, it allows us to perform various version control tasks without really needing a network connection. Before I jump into my demonstration, let me spend some time explaining to you the Git client-server working model. What does it take for a couple of users to collaborate and start working with Git? The bare minimal thing that any user would need in order to start working with Git is something called as Git bash or the Git client. This comes as an installer for all popular operating systems like Windows, all flavors of Windows, Linux, macOS, and other operating systems. So once you install Git bash, you get a command line utility using which you can fire up your Git commands and ensure that you can bring up repositories. You can work with these repositories by adding files to it. committing changes to it, and all those Git commands would work perfectly well. So you can bring up a small repository and you can work with your repository using this Git bash. But what does it take for you to share this repository with another user who has also got Git bash installed on his system? This is where you would need something called as a Git server. So for user one or one user to share his repository with another user, he would need to collaborate using something called as a Git server. So in the present market, there are a bunch of Git servers which are popularly available. Some of them are free, some of them come with a cost because they are licensed. A bunch of these servers that I can think of are GitHub, which is one of the most popular Git servers that is around in the market for a long time now. It comes with two variants. One is the cloud hosted one, which is the github.com, and then the other one is an enterprise server which comes as a black box that can be installed into your data centers. So typically organizations who don't want their source code to be put up on the cloud would go for this GitHub enterprise servers, wherein they buy these servers and these servers are hosted on their data centers. Other popular variant of the Git server is Bitbucket. This is from the famous Atlassian products, and it integrates very well with all other Atlassian products like Jira. In recent times, there's one other variant of the Git server called GitLab, which is getting very popular these days because GitLab not just provides a Git server, it also provides something called as a runner. This is a part of the continuous integration strategy where as soon as you have a source code check-in that is going in, you have this runner that kicks up and builds your particular project. So all these are bundled together in a GitLab. And GitLab also provides you with a community edition which is almost free of cost. Having said that, there are a bunch of these tools available. For my demonstration, what I'm going to do is I've already registered myself on the github.com by providing my username and my password. And I'm going to use a free account. So whatever repositories that I'm going to put up on this server is all public by default. So I've already registered myself by using my username or my email ID and my password. So this set of authentication is also referred to as HTTPS authentication. So in order for me to share my repository with say user 2, the first thing that I got to do is have an access to a Git server where both user 1 and user 2 are set up. So once I have that, I can push my repository onto this server and provide right kind of access so that user 2 or the other developer who wishes to collaborate with me on this repository can use his credentials as long as he's registered properly on the Git server. He can use his credentials and pull down this repository and work with this repository. So this is the HTTPS way of authenticating and sharing repositories. Another popular way of sharing repositories or working with each other is called as SSH authentication. As many of you would know, SSH means nothing but creation of a private and a public key. A bunch of keys, public and private, are created on the client machine. While I create keys, I will be asked for a passphrase. I need to type in a passphrase and remember my passphrase. And then I take this public key and kind of post it onto my account within my Git server, so that whenever I'm going to connect next time using my command prompt or any of the tools, it's going to challenge me for my passphrase. As long as I remember my passphrase correctly, I can authenticate myself and get into this server. So both HTTPS and SSH are popular ways of communicating with the Git server. Having said this, let me just get started by installing the Git bash on my local system and then fire up some of these Git commands and build up some repositories, make some changes in my repository, commit these changes, and later use my GitHub credential to connect to my GitHub server and push my repositories out there. Let me now go ahead and find my Git bash for my Windows so that I can go ahead and install it. So I just type in Git client for Windows, open up a browser and type in for this. The first one that I find is a GUI tool. I don't need this GUI client, I need this one. So this is the Git client or the Git bash that I was referring to. It's about 40 megs, and let me just download this. Pause this video for some time so that the download happens and come back to you once I have the download. The download seems to be complete. When I'm recording this video, the version that I have, the latest version that is there is 2.19.0, and this is a 64-bit version for Windows. So I've got that downloaded. Let me go ahead and find it and install this exe. All right, I go ahead choosing all the default options. I want it to be installed in C:\program files under the Git folder. Everything looks good for me. I'm not going to make any changes here. Git bash from Windows. Yes, I may want to use git from Windows command prompt. That sounds good for me. OpenSSH, that's fine. Looks good. Looks good. No, I don't want any of these new features. So what I'm doing is installing the git bash or the git client so that I can start using my git commands. And the version that I'm using is 2.19.0, which as I record this video, this happens to be the latest version. All right, so looks good. I don't want to see the release notes. I'll say launch git bash. So what I get is this window. So this is the git command prompt. So let me check if everything is looking good. Say git version, it sounds good. Say git help. All right, a lot of git help commands. Everything looks good. So I ended up installing the git bash. I can go ahead with all other commands. Now that I have git bash installed on my system, let me open up a git bash prompt and start using it. But before I do anything, I just need to configure it for the first time, stating what would be the username and the email ID with which I want the git bash to be configured with. The command to do that is git config -- global, which means that this setting that I'm going to set would be a global setting. User.name, and the name of the user would need to be specified within a double quote. In my case, I am using a Simplilearn account, which is the official account, and this is the particular username of this account. The other setting is nothing but git config -- global. This is also a global setting, and this would be the email ID. The email ID need not contain a double quote. So in my case, this is the email ID that I would be setting up Git to work with. All right, let me check if the configurations were set correctly or not. All right, if you see this, the username and the email ID has been picked up the way I wanted it to be picked up. Looks good so far. All right, so what do we do next? By default, whenever you open up the Git prompt, you're placed into your home directory. Let me create a folder here, which would be a repository folder from where I'm going to create all my multiple Git repositories. So I will create a folder called, let's say, git_demo. All right, there's already a folder called git demo. So let me just delete it in the first place and let me create this git demo again. All right, let me navigate to this particular folder. So this is the folder. Let me open up that folder using a command prompt. This is my git demo. So this would be a folder. So I would use this folder as a base folder for creating all other repositories as a part of this demo. So let me create my first repository. A repository is nothing but a folder. So let me create my first folder called first repo. And let me get into this repo. All right, as of now, this is just an empty folder. If at all I navigate to this, you would see that this folder is empty. There's nothing much in this folder at all at this moment. Okay, so let me create a repository out of this. How do I create a repository of this? It's pretty simple. I just run a git init command. When I say git init, it means it's going to initialize a repository. As of now, the folder contained nothing in it. It was an empty repository. So it initializes an empty repository in this particular folder. If at all I look at my content, you would see that there's a hidden folder. This would be a hidden folder since I've configured my Explorer to view all hidden folders. I see it, otherwise you wouldn't see it. So a folder by name .git is created within this first repo. And this was created because we ran the command git init. If I get into this folder, I see a bunch of directories and other configurations. If you see, there's something called as a hooks directory, a couple of configuration files that are here in this directory. All these relate to one or the other type of a client hook that can be enabled. And there's info, there's objects, there's references, a bunch of stuff that is there. So what is this folder? This is a magical Git folder, and this is created whenever a repository is initialized. So By default, if at all you get into any Git folder or any Git repository, you would see this .git folder. A word of caution, do not get into this folder and try to modify anything, because if you fiddle around with this and corrupt this particular folder, your whole repository will go for a toss. So let me come out of this and let me show you another thing. Now, if you notice here, when I was in the folder, the repository did not have anything after this. Now, when I say git init, there is something called as a master that shows up. So typically what happens is whenever a Git repository is created for the first time, it creates a default branch. The name of the branch is called master. And that is why you would see master within braces. This doesn't mean anything else other than we have a repository out in this particular folder, and by default there is a branch called master, and we are currently on that branch. If at all I create multiple branches in this folder, whenever I navigate to different branches, the branch name within these brackets would change. All right, so far so good. So we created a folder, we made it a Git repository by initializing that with a git init, and then I've not put anything yet in the repository. So let me try to do that. Let me create a few files within this particular repository. So I use a touch command. Touch is a Linux command. It kind of creates this particular folder. If at all you're not comfortable with the file creation by this way, you can always use a file explorer and create some files in this. So I create a file called touchmaster.txt. I'll open up in the notepad. Okay, so this is my first file. That's what I'm going to write inside this. I save this and I come out of this. All right, now let me do a git status command. So what does this tell you? There's no commit set. You're on the master branch. There is an untracked file, and this shows up in red. It also gives you all the commands that is supposed to be run. So if at all you want to add this file, you would say git add and the name of the file, and then you're going to commit it. So what happened is that when the repository was initialized, it was an empty repository. Now that a git notices that there is a new file in this repository called master.txt. If at all you want us to let Git know that you want to track this file, we need to add this to the repository. So the command to add that is called git add. I can specify either the name of the file or I can give a wild character saying git add dot. Now if I run the git status command again, it says there's no commits yet. Added a file, and the file which was earlier in red now shows up in green, and it says it's a new file, master.txt. All right, it also gives you something called git remove command if at all you want to unstage or undo your changes. So what has happened is the file which was earlier untracked is been added into the git index, or it is ready for staging, or it's in a staged state. Now I can go ahead and commit this file if at all that's what I want to do. So let me do that. I'll do a git commit -m and I give a message that I want. I would say this is my first git commit. All right, I run the git status command again and see it says on the branch master, nothing to commit. It's all nice and clean. So typically what happened was I created an empty directory, made it into a git folder by doing a git init. I put a file into it. I made some changes to the file. I added that file into the repository and I committed to the repository. If at all I run the git log command, it says this was the commit ID or the commit number or the commit hashtag, and this is the author. If you notice, this is the email ID and the username that we set earlier, and this was done on this date, and this is the commit message that is there. All of it looks so good. Let me do one more commit into this repository. So I will touch master1.txt. I'll put in another file. I'll open up this particular file, write something into this. All right, I save this change. Let me also open up the older file, make some more change into this. All right, so what I did, I modified the older file that existed. I also added a new file to my repository. Now, if I run the git status command, it says modified this file, which is showing in red, and it says you have one more file, which was an untracked file. All right, now let me add both these files because these are the changes that I want to incorporate. I would say git add dot. I run the git status command again. and it says now this is a modified file, this is a new file. Looks good to me. Let me go ahead and commit this. So git commit with a message that says this is my second commit. All right. If I do a git log now, it shows both the commits. The first commit is the one that shows up at the bottom, and the topmost one is the latest commit that is there. So far, so good. If at all you notice, I'm doing all these git commands without really connecting it to any git server. I don't need any network connection for doing any of these things. I can keep on doing more and more git commands and run git commands the way I want to without really having any connections to the git server. Now that I have my changes the way I wanted, and I've checked in all the code changes into my local repository, I may want to share my repository with somebody else and work in a collaborative way. So the way to do that is, as I mentioned earlier, to host this repository or to push this repository onto a Git server. I already have a GitHub account wherein I've registered myself using my username and password. So I log into my GitHub account using my username and credentials, and let me go ahead and create a new repository. My repository is already there on the local system, so what I essentially need is just a placeholder for my repository so that I can link them together and push the content from my local repository to the server. If you notice, the name of my repository is this first repo. So let me copy this. I would create a folder structure or a repository structure on the server with the same name so that when I pushed my repository from my local box, it will go ahead and get created in the server. So the repository name should be the same as what I created on my local box. Description, I would say this is my first GitHub repository on the server. This is just an optional description that will show up. And if you notice, I can't have any private repositories. So whatever repositories that I'm going to create here would be a public repository. So I choose public, and I don't want to initialize this with a README file or anything of that because I already have a repository with some content with some code checked in. All that I need is a placeholder for my repository on the server. So with this option, with just the name and with an optional description and the repository being public, I go ahead and click on the create repository button. So if you notice, it gives me a bunch of commands that I would need to run in order to create a repository and push it onto the server. And also, important point, it shows me two URLs. One is the HTTPS URL and the other one is the SSH URL. As of now, we do not have any SSH keys that is set up. So let me use this HTTPS URL to connect my local repository with the repository on the server. So I've done all these things. I already have the repository set up. All that I need is a placeholder for me to connect my local repository with the server URL. So this would be the command that I need to copy, which essentially links or adds an origin with the URL of the Git server. I just copy this command and run it here. Git remote add. The name of the remote is called origin, and it points to an HTTPS URL, which is nothing but the placeholder that I've created on the server. All right, so let me check if it's added correctly. Okay, the URL looks good. I'm all set. I've got 2 commits in my repository. I'm done with all the changes. So let me try to push my repository onto the server. The command for doing it for the first time is git push -u. This is for linking the upstream origin master. So git push -u upstream linking origin master, link the master branch of my local repository with the master branch on the server repository. And where is it going to push? It is going to push by default to an origin, and the origin points to this URL. All right, let me try doing this. So it essentially opens up an URL asking me the credentials with which I need to log into my GitHub server. So let me just copy and paste the username and the password with which I have registered. I would say login. Okay, success. So I'm able to create a repository on the server and the content seems to be pushed, and it created a new branch called master. It has linked the master branch from the local repository with the master branch on the server. So let me go back to my server and refresh this page and see if all my commits have come in. Master1.txt. If at all I see the commits, there seem to be 2 commits. This is my first commit, this is my second commit. And if at all you notice, each of this commit comes with a hash key or a hash ID, which contains the details of my commits. In this commit, the files were added. This was the line that was added. If you look at the second commit, I added these lines. I made this, one line chain that was there. I also added this new file which was not existing. These are the 2 commits that existed. And if you see the timestamp of the commit, this is the commit which was committed 15 minutes ago. So what does this mean is that the commit is the timestamp when we actually committed the code in the client. The pushing is just after we have committed the change, we have pushed it. So there's no timestamp of the push that happened. This completes the first part of the tutorial wherein I created a repository on the client and then I pushed it to the server after creating a repository skeleton on the server. Now let me demonstrate to you the SSH configuration that is required for creating a pair of SSH keys and ensuring that I connect to the GitHub server using the SSH mechanism. So for doing that, I need to first create a pair of private and public key. The command to do that is ssh keygen -t. I will use the RSA mechanism for creating my keys, capital C, and I need to specify the email ID using which I'm going to connect to, or I need to create the keys for. Alright, so generating a private and public key pair, it says, let me know what folder should I create the keys in. So by default, the keys are created in the user home directory under a .ssh folder. So this is pretty good for me. So let me go ahead and say that, that's fine. Enter a passphrase. So let me enter some passphrase. Keep in mind that I would need to remember my passphrase because when I'm going to authenticate myself using SSH mechanism, it will challenge me for this particular passphrase. I need to enter the right passphrase so that I get authenticated. So the key is generated and by default it is created in this particular folder. So let me go over to that particular folder. And this is the folder where the keys is generated. You would see a public key and a private key that is created. Let me open up the public key with a notepad and then copy the contents of the whole file. And now I would need to stick it in on the server so that I can get myself authenticated using SSH keys. So I've logged in to GitHub using my credentials and go to my settings. And you would see an SSH and GPG keys. Let me click on that. As of now, there are no SSH key or GPG keys. So I would click on new SSH key and let me paste my public key that I've copied. And I would say add SSH key. It prompts me for my password just to make sure that I've got the right kind of authentication to be adding a new key. So this one looks good. That means the keys were added successfully. Let me check if my SSH keys are working well. So I do SSH -T. I would say git at github.com. This is just to double check if my SSH keys are authenticated correctly. Are you sure you want a connection? Yes. You want to continue? Yes. All right. Now a check for my passphrase. Let me enter my passphrase. I hope I remember it correctly. All right. Pretty good. I've been successfully authenticated. So that means now my SSH keys are good. And just by using my passphrase, I can connect to my GitHub server using SSH. All right. So for the second use case, what I would do is create a repository on the server with some content in it. and then clone that repository. Cloning is nothing but making a copy of that repository, linking the origin so that I create an exact replica of the repository which is there on the server on my local drive. So let me first create a repository on the server. I will create a new repository. Let me give a name for my repository and let me kind of initialize that with the README file. I would call this my second repo. Give some description. This is my second repo that is created straight on the Git server, on the GitHub server to be precise. It's a public repository. This time I'm going to choose this option. The reason being that I don't want to create just a skeleton as of now. I want to create a repository with some README file in it. A random README file with no content in it, but then I want a repository to be created on the server. Alright, I say create a repository. So a random README file with some content in it gets created, and I can see there are two URLs to this repository, HTTPS and SSH. So this time, let me copy the SSH URL so that I will use this URL to clone this repository on the server, rather from the server to my local box. Alright, so let me navigate to my root folder, the folder that I created for making all my repositories, Git repositories. If you see, my first repository is already here. So let me clone my repository, the second repo that I created on the server. The command to do that is git clone the URL of the repository that I want to clone. Oops, looks like I didn't copy the URL correctly. Let me copy that again. Copy this URL. All right. So if you notice, there is no HTTPS to it. I'm just cloning the URL, that is SSH URL of the repository. It asks for my passphrase again. Okay. So I just had first repository earlier. Now I have something called a second repo. This is an exact replica of whatever was the repository content that was created on the server. So if I get into the repository, there's just a simple README file that is there. Let me try to add a new file out here. I would say notepad, second.txt, some text file I'm going to put in here. Yes, definitely you will not find that file there. This is my second file that I will push onto the server. I'm going to put in some content out there. I'm going to save this. And if I do git status, it says this is a new untracked file. Do you want to add this file onto the repository? Do you want to track this file? Yes, I definitely want to track this file. Let me also commit my change to the file with a message. This is my first commit for the second repo. I give in some particular message. And this time around, since I cloned my repository from a server, the origin is already set for me. I don't really need to add the origin and all that stuff, because what happened in the first case was that I was creating a repository from my local box and then pushing it on the server, which is why I had to set up the upstream branches and stuff like that. In this case, I have cloned an existing repository from the server. So when I clone, I get the replica along with all references to my repository. So I don't need to do anything more other than push the content. I would just say git push. To be on the safer side, I would say origin and master. It asks me for the passphrase. Okay, it pushed the content onto the server. Let me see if the contents have come in here. Okay, wonderful. I had only one commit. Now I see my second commit. So what was added as a part of the second commit? It says a new file was added. All this line that never existed got added. This is the second file, the content exactly what I pushed onto the server. Now this completes the tutorial wherein I created a repository on the server, cloned it, made some changes to the repository and pushed it to the server using SSH. A quick recap of all the Git commands that we ran till now. Git init is used to initialize a repository. So if at all you're creating a local repository, you can get into any of the folder which is not a Git repository and run this command. Whenever you run this command, a magical folder by name .git gets created in the folder And from that time onwards, Git will start tracking any changes that happen to that particular folder. It also creates a new repository and a branch. By default, the branch that is created is called the master branch. Git add dot is a wildcard character for adding any number of new files into your Git repository. If you have a bunch of files, 1 file, 2 file, 10 files, a folder containing multiple files in it, all of them could be added into the repository using this command. So once you add any number of files into the repository, you can keep on adding more and more files into the repository. Once you're done with that, you want to commit the changes that has happened in the repository, you use the git commit command. Git commit -m with a meaningful message. This will commit all the work items that you've done in terms of the files that got changed, the files that got added, all this with one particular message. Git status will give you the status of all the files and folders, any file that got added, any file that got created, any file that was deleted, all the status of the files will be obtained using the git status command. Git log will show you all the commit history with the latest history or the latest commit showing up on top. Git add remote origin. This command is used whenever you want to link any local repository to a server. And this is when you want to really push a repository from the local to the server for the first time. Git push -u origin and master. This is the command that you would use whenever you want to push contents from the local repository to the server. Git clone and the URL of the server. This is the command that you would run whenever you have an existing repository on the server and you want to make a fresh clone or a fresh copy of that particular repository onto your local box. More than often, many developers or Git users find themselves in situations where they would want to go back in history and modify or change some of the files that they recently committed or checked into the repository. Now, from a perspective of Git, this is a very simple activity. However, from a perspective of version control tool, you will have to be really cautious about the change that you're going to do. In case the changes are pretty local, none of the developers or none of the other users who are collaborating with you would be affected by this change, you're good to go ahead and make this change. However, if your repository has been pushed to the server and you're trying to modify something from history, this would have a very bad or adverse effect on all the other users who will be using it. You need to be really cautious while running these commands. In case your repository contents are local, you've not pushed your changes to your repository, and if at all you made some changes to the repository, maybe to fix a defect or to include a new feature, and you missed few things, you can go ahead and modify this with some of these commands. Let's say I have this simple repository called undo repo, and if at all I look at the logs of these, I have the commit histories which are like this. I have about 5 commits that is there in my repository, and in C1 I've added a file, in C2 I've added another file, in C3 I've also added some file, in C4 I've made some changes to M1 and M3, and in C5 I've added another file called M4. Now this is my commit history. Now let's say I made these 2 commits, but possibly I want to club them together along with some other changes because whatever changes I did not really fix things the way I expected it to fix. So there is a git command called git reset. This would allow me to go back in history, to go back to any of the snapshot, get rid of all this commit history or the commit messages, but retain the changes that were made as a part of these commits. So if at all I need to go back in history and go back to this particular commit, and however I just want to get rid of these commits that are there in terms of the commit messages, but I want the changes that were there as a part of these commits to still exist, I would do command called git reset -soft. Now this would go back or unwind my changes back to this particular snapshot, getting rid of all the commit messages that were there as a part of these 2 commits, but a soft would ensure that the file changes that were done as a part of these 2 commits would still exist or full remain. So the command for that is git reset -soft, which is the snapshot that I want to get back to. If this is the commit that I want to get back to, I just copy this and I paste this. All right, it doesn't give me any message, but if at all I do a git log pretty one line, what it says is C1, C2, now the head, which is nothing but the current pointer, which was earlier pointing to C5, it's gone back to C3. Now what happened to the changes that were there as a part of C4 and C5? If at all you do a git status, if you see the changes that were a part of C4 was some changes to M1 and M2, and C5, a new file got M4 got added. If at all I do a git status, you would see those changes still exist. However, from the git history or the git commit history, C3 is the topmost commit that exists as of now. C4 and C5 have been gotten rid of, but the changes that were there still exist. Alright, now I can make some more changes that I want if as a part of my commit, and possibly go ahead and commit this whole thing as a new commit altogether. Maybe I'll open up a notepad and possibly create a new file called m6.txt and say one new file that was missed out. I make this change. I go to a git status. All these files are still there. I would say git add dot. I would say git commit -m C4 rewriting history, and I do a git log pretty. There you go. So C1, C2, C3 still existed, and whatever was a part of C4 and C5, the older ones, I've gotten rid of this. Along with those old changes, I also added a new file. I made some changes and I was able to commit it. Now if you look at my git history, it's all nice and clean. However, do this activity only when you don't push your git repository to the server. One other most powerful and useful command while undoing or resetting the history is something called as revert. This is a safe way of undoing some things. Remember what I talked about when exactly you can do a reset? It's only when your changes are local and is not being pushed to the repository. Take this scenario wherein, let's say I have a git server and I have the changes which are C1, C2, C3, and possibly C4. Alright, so this is a bunch of commits that has happened. This was the oldest commit and this is the newest commit. And if at all developer 1 is the one who's responsible for pushing these contents in the first place. So he has got C1 to C4 on his history. I'm going to jump all these C2 and C3 and get into C4, and he's pushed all these contents out here. And there are a bunch of people from the server who has pulled this repository, and all of them are at the same level. Now imagine a use case where developer 1 then figures out that by mistake he put in the C3, which was the wrong thing to do, and possibly he could have done a better job of fixing this in a different way. So he wants to get rid of the C3 or C4 or any one of these commits. If he's going to do that and push it to the server, first of all, the Git server would not allow him to go back in history. But assuming that he forcibly pushed something, what would happen to all these people who are looking to work ahead from C4? All of them would be affected in an adverse way. So in short, never go back in history. If at all you need to undo something, go ahead and put in a new commit to undo something. Let's take this example. Maybe if at all a developer 1 wants to get rid of C3, better way to do that is by adding a new commit which is ahead, say let's say C5. And what does this commit do? This commit possibly gets rid of C3. Instead of going back in history, it actually is taking your Git history ahead. But as a part of this commit, you're undoing some part of the work that was done as a part of C3. In short, you're removing a commit, but to remove a commit, you're adding a new commit. And this is why you're doing it, because there are a bunch of other people who are you're using this repository collaboratively and who are planning to get ahead in terms of history. They cannot afford to go back in history and modify something in history. All right, the command to do this is called the git revert command. So let me take up this repository, which has got a bunch of commits in it. And if at all I do a git log, pretty one line, I have these bunch of commits. In C1, I've added a file. In C2, I've added another file. In C3, I've added one more file. And in C4, I made some changes. And this is the latest commit and this is the oldest commit. So if at all I see the contents of the Git folder, it contains M1, M2, M3, and M4. And let's say looking at the previous use case that I mentioned, I may want to get rid of this particular commit. I want to get rid of the C3, which is nothing but I've added a file called m3.txt, but I added it by mistake. I need a better way of fixing it. Possibly I'll look at it later on, but for now, I don't want this particular commit and the changes that were made as a part of that commit to exist. So the better way to do that is using the git revert command. So git revert and the commit ID, whatever I want to revert. So if I want to revert this, I copy this particular commit ID, and bear in mind that considering a reset, revert works on one commit at a time. So I can do one commit revert at a time. I can club a bunch of them together and do one commit, but otherwise the revert always works on one commit at a time. So git revert, paste this. Essentially what I'm trying to do, I'm trying to undo this particular commit. While I'm undoing this commit, what does git do? It safely adds a new commit, and a part of this new commit, it undoes whatever changes that were done as a part of this commit. So if I say git revert this, all right, I forgot to mention a message, which is why this window is showing up, but that message is good for me. I say write and quit. All right, and if I do a git log, all right, if you see this, C1 still is there in history, and our history is going ahead. From C5, I see another commit. But what was there as a part of this commit? Actually is getting rid of this commit C3. So if at all I see my files here, there's only M1, M2, and M4. M3 was added as a part of C3. Now I've gotten rid of M3 by getting rid of the revert command for C3. So this is a better way of undoing things. Now that we have acquainted ourselves with few of those basic Git commands, let me get into a very interesting topic regarding Git, which is about branching. The topic is interesting because Git deals with branches in a completely different way compared to any other version control tool. In most of the version control tools, whenever you create a new branch, a complete copy or a subset of the whole repository is created, which in my opinion is very cost inefficient because it's a very expensive operation, both in terms of time and the disk space. However, in Git, you just create a very lightweight movable pointer whenever you create a branch. There is no folder or no copy of the repository that is created. In short, the branches are very inexpensive in Git. So go ahead and create any number of branches that you need. However, once you create your branches, do all the work relating to that branch in that specific branch. And once you've completed your task, go ahead and merge your branches back into your base branch and then delete the branch. Let me go ahead and create a repository with some branches in this and give you a demonstration of that. So let me go back to my base directory, which is git demo, and then I'm going to create a new folder here. I'll create a folder called org details. All right, this is my folder here. All right, I navigate into this folder and let me create a repository here. I initialize a repository and .git folder is created without any files in it. So let me create a few files in it. Say notepad name.txt. Organization name. I create a name.txt within this. Maybe I'll create one more file in this. Notepad employees.txt. Simplilearn has over 3K employees. I just put in some content in this. Save this content. All right. So if at all I do a git status, I just see two files in it. So let me go ahead and add these two files and let me commit my changes. So git commit -am or -m, first commit. So if I do a git log, I see only one commit and there are two files here. You can see those two files that is here. Alright, so at this stage, let me go ahead and create a new branch. And the command for creating a new branch is git branch name of the branch. So let me name my branch as Bangalore branch, BLR branch. And this created a branch. But I don't see any changes in the folder structure or in the file that exists here. I've just created this branch. So if at all I do a git branch, I see these two branches. And whatever star means I'm currently in this master branch. So let me go ahead and get into the BLR branch. At this moment, the number of files that exist in this repository is same. There's absolutely no change in any of the branches. Both master and BLR branch point to the same snapshot. So let me get into the other branch, and the command to do that is git checkout BLR branch. Now I actually switched into Bangalore branch. If you see the content of the files, this is exactly two files the way it was earlier, because I've created a branch from my base branch, which is the master branch, and when I created a branch, there were two files existing here. If you see the content of these files, they would all be the same. Alright, so let me create a file that is specific to Bangalore branch. So I would just say notepad. Maybe I want to put down the address of this organization specific to Bangalore in this address.txt. So I say notepad address.txt. I'll say Simplilearn Bangalore office. Say located in some address. I would say Bangalore. That is the content of this file. And I'm creating all this new file in this BLR branch. So I would say git add dot, and I would say git commit -m Bangalore branch commit. Alright, if you see this, now I have an address.txt which is there only in the Bangalore branch that I'm presently on. Now let me switch back to my master branch. The command to do that is git checkout master branch. If you remember, when I forked out or when I created a new branch from the master branch, I didn't have this address.txt in it. So let me go back to git checkout master branch and keep noticing this particular. What happened to the address.txt? It kind of disappeared. Now, how did that happen? It's all because of this magical git folder. So what happened is, now git knows that when you are in the master branch, the file that was there in the Bangalore branch, which was called the address.txt, didn't exist. So git is playing around with the file system snapshot. So if I come back, let's say I come back to git checkout Bangalore branch. If you see this, the address.txt file appears. So this particular file is only present in the branch, and git is playing around with the file system snapshot by moving the pointers across and ensuring that whenever I'm switching to Bangalore branch, I see this address.txt. When I go back to my master branch, I don't see this Bangalore branch contents, which is the address.txt. Alright, now that I created this branch, maybe I may need to push this onto the server. So let me go ahead and create a particular repository structure on the server, similar to whatever we did in our previous exercise. So the name of the folder needs to be exactly this one. So let me copy this and let me create a repository very quickly. I'll go here and say new repository. Alright, this is the name of the repository, git branch demo. This is what I'm going to put in as a description. I would say public. I don't want any readme files in it because I already have a repository. I would just say create a repository. Alright, let me use the SSH URL. Yeah, this is the SSH URL. This is good for me. So let me copy this URL. Let me add it here. I'm linking my local repository with the server. And let me come back to my master branch. Let me first push my master branch. So I would say git push -u origin master. It asks for my passphrase. All right. I pushed my master branch. It looks good. It says new branch master is created. So if I go back to my server and I do a refresh, if you see, it says only one branch, and it says what is the name of the branch, master. If you see the contents, there is employees.txt and name.txt. Now let's try to push the other branch that is there. The command to do that is a little different compared to the way we created it on the client, because on the client we created the branch with a git branch command. Now this branch doesn't exist on the server, and I need to push this new branch onto the server. So the command would be git push -u origin and the name of the branch that I want to specifically push. All right, now it created a branch out here. Let me do a refresh of this. All right, it says 2 branches. If I get into this Bangalore branch, I would see the address.txt. If at all I go back into master branch, I would not see this address.txt. Wonderful. Now let me do one thing. Let me try to get the changes from the branch that I created back into the master branch. That is what I would mean by merging. I would want the changes that is there as a part of the Bangalore branch to come back into my master branch. So if I go to git checkout, Bangalore branch, I see this address.txt. This is there only as a part of Bangalore branch. Now, assuming that I'm done with the changes from the Bangalore branch, I want to get those changes back into my master. So let me come back to my master branch. And the way to merge in the changes is git merge. So what is it that you want to merge? I want to merge the Bangalore branch changes. And where will it merge? It will merge it into the current branch that I'm on. Presently, I'm in the master branch. So this command would merge the changes from the Bangalore branch into your master branch. So with this, if you'll keep looking here, the content that was there that was added as a part of Bangalore branch, which was nothing but the address.txt, this file should appear as soon as we do a merge. All right, so it happened quickly, and you would see this address.txt that is here. So if you see, let's check the contents in terms of the git log. All right, so there was only one branch that we had earlier, which had only one commit. Right now, we are at this Bangalore branch commit, which was there as a part of the Bangalore branch commit. So with this change, let me push this change onto the server as well. Git push origin master. Okay, those changes were pushed to the server, and now if at all I do a refresh out here, okay, I'm in 2 branches. The branches is master. Even if I'm in master branch, I should see this address.txt that is there. Even if I'm in the Bangalore branch, the content is all same because we have merged these 2 branches. Now that I've merged this branch, I don't need this branch anymore. So I would go ahead and delete this locally as well as push it onto the server so that it gets deleted from the server as well. So delete branch locally. The command is git branch -d and the name of the branch. Only thing you need to ensure is that you should not be currently on that branch which you're trying to delete. So I would say git branch, and I'm presently in the master branch, so I can go ahead and delete the other branch. So git branch -d Bangalore branch. All right, this got rid of our Bangalore branch locally. If at all I do a git branch -v, it shows there's only one branch as of now. However, this branch would still exist on the server because server doesn't know anything about the changes that we have done. we need to specifically push our changes onto the server. Okay, there are two branches still here. So let me go ahead and push these changes so that the branch gets deleted from the server as well. The command to do that is git push origin -- delete and the name of the branch. All right. So this went ahead and deleted the branch from the server. Let's check that. Okay. If you see now, there's only one branch. These are the basic steps that you would need to know before you work with any of the branches within Git. And as I said before, the branches are very inexpensive in Git. Go ahead and create any number of branches that you want, but just ensure that once you create your branch, finish off your task, and once you finish off your task, go ahead and delete the branch. And before you delete the branch, please ensure that you merge in the branches so that you get in or take in the work that was done as a part of that particular branch. To summarize, the Git branching commands are as follows. To create a new branch, you issue a command git branch, the name of the branch, and this would automatically spin off or create a new branch from the existing branch from where you issue this command. If you are on the master branch and if you execute this command git branch new underscore branch, it creates a new underscore branch from the master branch. Once you create a new branch, in order to get into this branch, you would type in git checkout, the name of the branch. This would automatically switch the file system snapshot between different branches. Now the branches that are created are by default created on the local repository. In case you want to push any specific branch onto the server, you would have to issue a command git push -u origin and the name of the branch. So this will ensure that the contents of the new branch are pushed onto the server. At any time, if you want to list out all existing branches on your local repositories, the command would be git branch -av. Assuming that you did all your work in a new branch and you're happy with the changes, you would want to bring back those changes into the master branch. The command to merge the contents of any new branch into a master branch would be git merge and the name of the branch. And this would automatically merge the branch contents that you specified into the branch on which you currently reside. If at all you're on the master branch and if you issue a command git merge new underscore branch, this would merge the contents of the new branch onto the master branch. So once you merge the contents of any branch, you would possibly want to go ahead and delete this branch. So the command to delete those branch locally is git branch -D and the name of the branch. This again would delete the branch locally. In order to make this change on the server, which is in order to remove this branch from the server, the command to do that is git push origin --- delete and the name of the branch. This would also delete the branch that you created on the server.
So if you're ready to embrace this exciting career path, look no further than Simplilearn's Caltech postgraduate program in DevOps. This comprehensive program will equip you with the knowledge and skills needed to master the DevOps principles, tools, and practices. Dive deep into containerization, orchestration, and automation frameworks like Docker, Kubernetes, and Jenkins. Gain hands-on experience with cloud platforms and learn how to leverage the power of infrastructure as code. Don't miss out on this chance to transform your career and become an invaluable asset to any organization. Click the link in the description to discover more about this DevOps course.
If we talk in the literal sense, MAVEN means accumulator of knowledge. MAVEN is a very powerful project management tool, or we can call it a build tool, that helps building, documenting, and managing a project. But before we move forward and dive deep into the basics of MAVEN, let's understand what is meant by the term build tool. A build tool takes care of everything for building a project. It generates a source code, generates documentation from a source code, it even compiles the source code and packages the compiled codes into jar of zip files. Along with that, the build tool also installs the packaged code in local repository, server repository, or central repository. Coming back to MAVEN, it is written in Java or C#, and it is based on Project Object Model or POM. Again, Let's have a pause and understand what is meant by this term, Project Object Model. A Project Object Model, or POM, is a building block in MAVEN. It is an XML file that contains information about the project and configuration details used by MAVEN to build a project. This file resides in the base directory of the project as pom.xml file. The POM contains information about the project and various configuration details. It also includes the goals and plugins used by MAVEN in a project. MAVEN looks for the POM in the current directory while executing a task or a goal. It reads the POM, gets the needed configuration information, and then runs the goal. Coming back, MAVEN is used to building and managing any Java-based project. It simplifies the day-to-day work of Java developers and helps them in their projects. Now, when we know the basics of MAVEN, let's have a look at some reasons to know why is MAVEN so popular and why are we even talking about it. So, let's have a look at the need for MAVEN. MAVEN, as by now we know, is popularly used for Java-based projects. It helps in downloading libraries or jar files used in the project. To understand the part of why do we use MAVEN or the need of MAVEN, let's have a look at some problems that MAVEN solved. The first problem is getting the jar files. In a project, getting the right jar files is a difficult task, where there could be conflicts in the versions of the two separate packages. However, it makes sure all the jar files are present in its repositories and avoid any such conflicting scenarios. The next problem it sorted was downloading dependencies. We needed to visit the official website of different software, which could be a tedious task. Now, instead of visiting individual websites, we could visit mvnrepository.com, which is a central repository of the jar files. Then MAVEN plays a vital role in the creation of the right project structure in servlets, struts, etc. Otherwise, it won't be executed. Then MAVEN also helps to build and deploy the project so that it may work properly. So the next point is what exactly MAVEN does. It makes the building of the project easy. The task of downloading the dependencies and jar files that were to be done manually can now be done automatically. All the information that is required to build the project is readily available now. Finally, MAVEN helps manage all the processes such as building, documenting, releasing, and other methods that play an integral part in managing a project. Now, when we know everything about MAVEN, let's look at some companies that use MAVEN. There are over 2,000 companies that use MAVEN today. The companies that use MAVEN are mostly located in the United States and in the computer science industry. MAVEN is also used in industries other than computer science, like information technology and services, financial service, banking, hospital and care, and much more. Some of the biggest corporations that use MAVEN are as follows. First we have Via Varejo, then comes Accenture, followed by JP Morgan Chase & Company, then comes Craftbase, and finally we have Red Hat.
So this is what we're going to be covering in this session. We're going to cover what life is like before using Jenkins and the issues that Jenkins specifically addresses. Then we'll get into what Jenkins is about and how it applies to continuous integration and the other continuous integration tools that you need in your DevOps team. Then specifically, we'll deep dive into features of Jenkins and the Jenkins architecture. And we'll give you a case study of a company that's using Jenkins today to actually transform how their IT organization is operating. So let's talk a little bit about life before Jenkins. Let's see this scenario. I think it's something that maybe all of you can relate to. As developers, we all write code and we all submit that code into a code repository, and we all keep working away, writing our unit tests, and hopefully we're running our unit tests. But the problem is that the actual commits that actually get sent to the code repository aren't consistent. You as a developer may be based in India, you may have another developer that's based in the Philippines, and you may have another team lead that's based in the UK, and another development team that's based in North America. So you're all working at different times, and you have different amounts of code going into the code repository. There's issues with the integration, and you're kind of running into a situation that we like to call development hell, where things just aren't working out and there's just lots of delays being added into the project, and the bugs just keep mounting up. The bottom line is the project is delayed. And in the past, what we would have to do is we'd have to wait until the entire software code was built and tested before we could even begin checking for errors. And this just really kind of increased the amount of problems that you'd have in your project. The actual process of delivering software was slow. There was no way that you could actually iterate on your software, and you just ended up with just a big headache with teams pointing fingers at each other and blaming each other. So let's jump into Jenkins and see what Jenkins is and how it can address these problems. So Jenkins is a product that comes out of the concept of continuous integration that you may have heard of as power developers, where you'd have two developers sitting next to each other coding against the same piece of information. What they were able to do is to continuously develop their code and test their code and move on to new sections of code. Jenkins is a product that allows you to expand on that capacity to your entire team. So you're able to submit your codes consistently into a source code environment. So there are two ways in which you can do continuous delivery. One is through nightly builds and one is through continuous. So the approach that you can look at continuous delivery is modifying the legacy approach to building out solutions. So what we used to do is we would wait for nightly builds, and the way that our nightly builds would work and operate is that as code developers, we would all run and have a cutoff time at the end of the day that was consistent around the world, that we would put our codes into a single repository. And at night, all of that code would be run and operated and tested to see if there were any changes, and a new build would be created. And that would be referred to as the nightly build. With continuous integration, we're able to go one step further. We're able to not only commit our changes into our source code, but we can actually do this continuously. There's no need to race and have a team get all of their code in at an arbitrary time. You can actually do a continuous release, because what you're doing is you're putting your tests and your verification services into the build environment. So you're always running cycles to test against your code. This is the power that Jenkins provides in continuous integration. So let's dig deeper into continuous integration. So the concept of continuous integration is that as a developer, you're able to pull from a repository the code that you're working on, and then you'll be able to then at any time submit the code that you're working on into a continuous integration server. And the goal of that continuous integration server is that it actually goes ahead and validates and passes any tests that a tester may have created. Now, if on the continuous integration server a test isn't passed, then that code gets sent back to the developer, and the developer can then make their changes. It allows the developer to actually do a couple of things. It allows the developer not to break the build, and we all don't want to break the builds that are being created, but it also allows the developer not to actually have to run all of the tests locally on their computer. Running tests, particularly if you have a large number of tests, can take up a lot of time. So if you can push that service off to another environment, like a continuous integration server, it really improves the productivity of your developer. What's also good is that if there are any code errors that have come up that may be beyond just the standard CI test, so maybe there's a code, the way that you write your code isn't consistent, those errors can then be passed on easily from the tester back to the developer too. The goal from doing all of this testing is that you're able to release and deploy, and your customer is able to get new code faster, and when they get that code, it simply just works. So let's talk a little bit about some of the tools that you may have in your continuous integration environment. So the cool thing with working with continuous integration tools is that they are all open source, or at least the ones that we have listed here are all open source. There are some that are private, but typically you'll get started with open source tools, and it gives you the opportunity to understand how you can accelerate your environment quickly. So Bamboo is a continuous integration tool that specifically runs multiple builds in parallel for faster compilation. So if you have multiple versions of your software that runs on multiple platforms, this is a tool that really allows you to get that up and running super fast so that your teams can actually test how those different builds would work for different environments. And this has integration with Ant and MAVEN and other similar tools. So one of the tools you're going to need is a tool that allows you to automate the software build, test, and release process. And BuildBot is that open source product for you. Again, it's an open source tool, so there's no license associated with this. So you can actually go in and you can actually get the environment up and running, and you can then test for and build your environment and create releases very quickly. So BuildBot's also written in Python, and it does support parallel execution jobs across multiple platforms. If you're working specifically on Java projects that need to be built and tested, then Apache Gump is the tool for you. It makes all of those projects really easy. It makes all the Java projects easier for you to be able to test with API level and functionality level testing. So one of the popular places to actually store code and create versioning of your code is GitHub, and it's a service that's available on the web, just recently acquired by Microsoft. If you are storing your projects in GitHub, then you'll be able to use Travis Continuous Integration, or Travis CI, and it's a tool designed specifically for hosted GitHub projects. And so finally, we're covering Jenkins, and Jenkins is a central tool for automation for all of your projects. Now, when you're working with Jenkins, sometimes you'll find that there's documentation that refers to a product called Hudson. Hudson is actually the original version of the product that finally became Jenkins, and it was acquired by Oracle. When that acquisition happened, the team behind Hudson was a little concerned about the direction that Oracle may potentially go with Hudson, and so they created a hard fork of Hudson that they renamed Jenkins, and Jenkins has now become that open source project. It is one of the most popular and continuously contributed projects that's available as open source, so you're always getting new features being added to it. It's a tool that really becomes the center for your CI environment. So let's jump into some of those really great features that are available in Jenkins. So Jenkins itself is really comprised of 5 key areas around easy installation, easy configuration, plugins, extensibility, and distribution. So as I mentioned, for the easy installation, Jenkins is a self-contained Java program, and that allows it to run on most popular operating systems, including Windows, Mac OS, and Unix. You can even run it on Linux. It really isn't too bad to set up. It used to be much harder than it is today. The setup process has really improved. The web interface makes it really easy for you to check for any errors. In addition, you have great built-in help. One of the things that makes tools like Jenkins really powerful for developers and continuous integration teams and your DevOps teams as a whole, when you have plugins that you can then add in to extend the base functionality of the product. Jenkins has hundreds of plugins, and you can go and visit the Update Center and see which other plugins that would be good for your DevOps environment. Certainly check it out. There's just lots of stuff out there. In addition to the plugin architecture, Jenkins is also extremely extensible. The opportunity for you to be able to configure Jenkins to fit in your environment is almost endless. Now, it's really important to remember that you are extending Jenkins, not creating a custom version of Jenkins. And that's a great differentiation because the core foundation remains as the core Jenkins product. The extensibility can then be continued with newer releases of Jenkins. So you're always having the latest version of Jenkins and your extensions mature with those core foundation. The distribution and the nature of Jenkins makes it really easy for you to be able to have it available across your entire network. It really will become the center of your CI environment, and it's certainly one of the easier tools and more effective tools for DevOps. So let's jump into the standard Jenkins pipeline. So when you're doing development, you start off and you're coding away on your computer. the first thing you have to do when you're working in the Jenkins pipeline is to actually commit your code. Now, as a developer, this is something that you're already doing, or at least you should be doing. You're committing your code to a Git server or to an SVN server or similar type of service. So in this instance, you'll be using Jenkins as the place for you to commit your code. Jenkins will then create a build of your code, and part of that build process is actually going through and running through tests. And again, as a developer, you're already comfortable with running unit tests and writing those tests to validate your code. But there may be additional tests that Jenkins is running. So for instance, as a team, you may have a standard set of tests for how you actually write out your code so that each team member can understand the code that's been written. And those tests can also be included in the testing process within the Jenkins environment. Assuming everything passed the tests, you can then get everything placed in a stage and release ready environment within Jenkins. And finally, you're getting ready to deploy or deliver your code to a production environment. Jenkins is going to be the tool that helps you with your server environment to be able to deploy your code to the production environment. And the result is that you're able to move from a developer to production code really quickly. This whole process can be automated. Rather than having to wait for people to actually test your codes or going through a nightly build, you're looking at being able to commit your code and go through this testing process and release process continuously. As an example, companies Etsy will release up to 50 different versions of their website every single day. So let's talk about the architecture within Jenkins that allows you to be so effective at applying a continuous delivery DevOps environment. So the server architecture really is broken up into two sections. So on the left-hand side of the section, you have the code the developers are doing and submitting that code to a source code repository. And then from then, Jenkins is your continuous integration server. And it will then pull any code that's being sent to the source code repository and will run tests against it. It'll use a build service such as MAVEN to actually then build the code. And at every single stage that we have that Jenkins manages, there are constant tests. So for instance, if a build fails, that feedback is sent right back to the developers so that they can then change their code so that the build environment can run effectively. The final stage is to actually execute specific test scripts. And these test scripts can be written in Selenium. So it's probably good to mention here that both MAVEN and Selenium are plugins that run in the Jenkins environment. So before we were talking about how Jenkins can be extended with plugins, MAVEN and Selenium are just two very popular examples of how you can extend the Jenkins environment. The goal to go through this whole process, again, it's an automated process, is to get your code from the developer to the production server as quickly as possible, have it fully tested, and have no errors. So it's probably important at this point to mention one piece of information around the Jenkins environment, that if you have different code builds that need to be managed and distributed, this will require that you need to have multiple builds being managed. Jenkins itself doesn't allow for multiple files and builds to be executed on a single server. You need to have a multiple server environment with running different versions of Jenkins for that to be able to happen. So let's talk a little bit about the master-slave architecture within Jenkins. So what we have here is an overview of the master-slave architecture within Jenkins. On the left-hand side is the remote source code repository. And that remote source code repository could be GitHub, or it could be Team Foundation Services, or the new Azure DevOps code repository, or it could be your own Git repository. The Jenkins server acts as the master environment on the left-hand side, and that master environment can then push out to multiple other Jenkins slave environments to distribute the workload. So it allows you to run multiple builds and tests and production environments simultaneously across your entire architecture. So Jenkins slaves can be running the different build versions of the code for different operating systems, and the server master is controlling how each of those builds operate. So let's step into a quick story of a company that has used Jenkins very successfully. So here's a use case scenario. Over the last 10 or 15 years, there has been a significant shift within the automotive industry where manufacturers have shifted from creating complex hardware to actually creating software. We've seen that with companies such as Tesla, where they are creating software to manage their cars. We see the same thing with companies such as General Motors with their OnStar program. And Ford just recently have rebranded themselves as a technology company rather than just an automotive company. What this means, though, is that the software within these cars is becoming more complex and requires more testing to allow more capabilities and enhancements to be added to the core software. So Bosch is a company that specifically ran into this problem, and their challenge was that they wanted to be able to streamline the increasingly complex automotive software by adopting continuous integration and continuous delivery best practices with the goal of being able to delight and exceed the customer expectations of the end user. So Bosch has actually used CloudBees, which is the enterprise Jenkins environment. So to be able to reduce the number of manual steps such as building, deploying, and testing, Bosch has introduced the use of CloudBees from Jenkins. And this is part of the enterprise Jenkins platform. It has significantly helped improve the efficiencies throughout the whole software development cycle, from automation, stability, and transparency, because Jenkins becomes a self-auditing environment. Now, the results have been tangible. Previously, it took 3 days before a build process could be done, and now it's taken that same 3-day process and reduced it to less than 3 hours. That is significant. Large-scale deployments are now kept on track and have expert support, and there is clear visibility and transparency across the whole operations through using the Jenkins tools.
Implement the CI processes over here. Now, what is the purpose of Jenkins here? Now, Jenkins is normally a kind of a CI tool which we use for performing the build automations and the test cases automation there. It's one of the open source tool which is available there, and one of the most popular CI tool also available into the market. Now, this tool makes it easier for the developers to integrate the changes to the project here. So we can easily integrate the changes, and whatever the modifications we want to manage, we will be able to do that with the help of Jenkins. Now, Jenkins also achieves the continuous integration with the help of couple of plugins. Each and every tool which you want to integrate have its own plugins which is available there. For example, you want to integrate Maven, we have a Maven plugin in Jenkins which you can install, you can configure. In that case, you will be able to use the Maven there. Now, you can deploy the Maven to build tool onto the Jenkins server, and then you can prepare or you can configure any number of Maven jobs in case of Jenkins. So what exactly the Maven or the Jenkins really do is, the Maven when integrates with Jenkins through the particular plugin, so you can able to automate the builds, because for automation the build you require some integration with the Maven, and that integration is what we are getting from the Maven plugin. So in Jenkins you have to install the Maven plugin, and once the plugin is installed, so what you can do is that you can proceed with the configurations, you can proceed with the setup, and this particular plugin can help you to build out some of the Java based projects which is available there in the Git repositories. And once that is done, you will be able to go ahead and you will be able to process a complete integration of Maven within Jenkins. Right, so let's see that how we can go for the integration. Now I have already installed the Maven onto the Linux virtual machine which we are using. So using the apt utility or using the yum utility, you can actually download the Jenkins package and the Maven package onto the server, onto the virtual machine. And now I'm going to proceed further with the plugin installation and the configuration of a Maven project. So I have a GitHub repository which is having a Maven project, Maven source code and the Mavenized test cases over there. So let's log into the Jenkins and see that how it works. So this is the Jenkins interface which we have over here. Now in this one, what we can do is that we can create some Maven jobs over here, and once those jobs are created, we will be able to do a custom build onto this Jenkins. So first of all, we have to install the particular plugin here. For that, we have to go to the Manage Jenkins. In Manage Jenkins, you have the Manage Plugins option there. So you have to click on that. Now here you will be having different tabs like updates, available, installed, advanced. All these different tabs are available there. So what you can do is that you can click on the available one. When you go to the available tab, so what will happen that here you can actually put up that what exactly plugin you want to fetch here. So I can put a plugin called MAVEN. Now you can see that the very first one, the MAVEN integration tool, is available. So I'm going to select that particular plugin and click on download now and install after restart. Now once that is done, so what will happen that the plugin will be downloaded, but in order to reflect the changes we have to do a couple of restart. Now for that you don't have to go to the virtual machine. You have the option here itself that will allow you to do the restart over here when you click on this button. So you check this option and say that restart Jenkins when the installation is done. So what will happen that the installation will be automatically attempted whenever the particular plugin installation is completed here. So you just have to refresh the page again and you will be able to see that the particular Jenkins is being processed as such here, right? So you can see that the screen is coming up that Jenkins is restarting. So it will take a couple of 5 to 6 seconds to do the restart and the login screen to come up again over there. You can do the refresh also if you feel. Automatically it will be reloaded once the Jenkins is ready, but sometimes we have to refresh it so that we can get the screen over there. So once the login is done, so my MAVEN integration is done. So next thing which I will be doing is that I will be creating a MAVEN related project. So I'm going to put the admin user and the password. So whatever the user and password you have created, you are going to put that so that you will be able to log into the Jenkins portal. Now this is the Jenkins which is available here. So all you have to do is that you have to click on create a new job or new item. So both the option is pretty much same only. So here you will be able to see a MAVEN project here. So I'm going to select like MAVEN build. That's the name which I'm going to give here, and the MAVEN project I'm going to select here and then press OK. Now here you will be providing the first of all the repository from which you will be checking out the source code. Now I can have a discard old builds over here. So if I feel that I want to have like a log rotation, so all the previous builds should be deleted. So I'm just saying that dates to keep build should be 10 over here, and the number of builds which I need to keep over here is 20. You can adjust these settings according to your requirement, but over here we are doing a kind of configurations which we are trying to do a lot of configurations and settings here. So these are the particular settings which we are looking forward as such over here. So now we are going to have the log rotation here. So we can have it like how many days we want to keep and how many number of builds we want to keep here. So both the values we are providing over here. And then now I'm going to put the Git integration here, like the repo URL. So I have this repository here in which I have the Java source code and some particular unit test cases, and I also have the particular source code, and it's kind of a MAVEN project. So that's what I'm trying to clone over here with the help of this plugin. So this plugin will download this repository, it will clone it onto the Jenkins server, and then depending on our integration with MAVEN, the MAVEN build will be triggered here. So now I'm going to process with the MAVEN here. So you can see here that it's saying that Jenkins needs to know that where the MAVEN is installed, because that MAVEN version it needs to configure, it needs to process on that part. So I'll just do the save over here, and or I can click on this tool configuration. So I'll just save or do the apply, click on this tool configuration here. Now here you have the options like where you can have the JDK installation, but what happens that since Jenkins is running there, so JDK is automatically installed. So in the tools configuration you don't have to put the JDK configuration, but at least for the MAVEN configurations you have to provide that where exactly the MAVEN is available there. So I'm just saying that MAVEN 3 I want to process, and the latest MAVEN Apache web server I want to configure here. So I just want to have I just want to save this setting so that it will be automatically download the latest version Apache 3.6.3 version there, and that same should be utilized over here in this case. Now I'm just going to the MAVEN build configuration here and click on the configure part. So these Git repository is available here, and in the build step it automatically builds up that what Maven environment you want to select. So you see that previously, since I did not configure my Maven environment, so it was throwing an error. But once I have configured that I have to download it during the build process or before the build, that utility should be downloaded. So instead of doing the physical installation of Maven on the server, what I have chosen over here is that I have selected the particular version, like I have selected that particular 3.6.3 version should be installed for the Maven purposes over here. Now once that is done, I'm going to put the particular steps over here. You can have it like clean install, you can have clean compile test, clean test, or test alone you can give. It's just a part of the setup or the goals which you want to configure here. It by default says that pom.xml file is the current one in the current directory you need to refer. You need to pick on that one. What it's up to you only that how you want to configure and how you want to process as such these information. So according to your requirement, you can say that okay, I just want to go for these particular goals, and you can say like save over here. The particular configuration will be saved. Now you can just click on the build now, and you will be able to see that the first of all the git clone will happen, and then the desired Maven executable will be the build tool will be configured, and according to that it will be processed here. So you can see here that the Maven is getting downloaded, it's getting configured here, and once it's configured, because I have explained over there that 3.6.3 version I have to select, so that specific version will be configured and will be picked up over here. Now even if you don't have the Maven installed on the physical machine on which the Jenkins is running, still you will be able to do the processing using this particular component here. So you can see here that we have some particular test cases executed, and in the end we are able to get a particular artifacts also there. Since I did not call upon the package or install goal, that's the reason why the particular artifacts was not generated, var file or jar file, whatever the packaging mode is available at POM level. But still what happens that my test cases do gets executed, and that's what I have got over here in this case. So this is a kind of a mechanism where we feel that how we can configure a Git repository. Once the Git repository is configured, you are going to integrate the Maven plugin. In the Maven plugin, you are going to configure in the tools configuration that this and so version I want to configure to run my build. And once that is done, after that you just have to trigger the build and click on the build now option, and once that is done, you will be able to get a particular full-fledged build or compilation happened onto the Jenkins, and this log will give you the complete details that what are the different steps which has happened on this one.
So let's take a little scenario of a developer and a tester before you had the world of Docker. A developer would actually build their code and then they send it to the tester, but then the code wouldn't work on their system. The code doesn't work on the other system due to the differences in computer environments. So what could be the solution to this? Well, you could go ahead and create a virtual machine to be the same of the solution in both areas. But we think Docker is an even better solution. So let's kind of break out what the main big differences are between Docker and virtual machines. As you can see between the left and the right hand side, both look to be very similar. What you'll see, however, is that on the Docker side, what you'll see as a big difference is that the guest OS for each container has been eliminated. Docker is inherently more lightweight, but provides the same functionality as a virtual machine. So let's step through some of the pros and cons of a virtual machine versus Docker. So first of all, a virtual machine occupies a lot more memory space on the host machine. In contrast, Docker occupies significantly less memory space. The boot up time between both is very different. Docker just boots up faster. The performance of the Docker environment is actually better and more consistent than the virtual machine. Docker is also very easy to set up and very easy to scale. The efficiencies, therefore, are much higher with a Docker environment versus a virtual machine environment. And you'll find it is easier to port Docker across multiple platforms than a virtual machine. Finally, the space allocation between Docker and a virtual machine is significant. When you don't have to include the guest OS, you're eliminating a significant amount of space, and the Docker environment is just inherently smaller. So after Docker, as a developer, you can build out your solution and send it to a tester. And as long as we're all running in the Docker environment, everything will work just great. So let's step through what we're going to cover in this presentation. We're going to look at the Devops tools and where Docker fits within that space. We'll examine what Docker actually is and how Docker works. And then finally, we'll step through the different components of the Docker environment. So what is DevOps? DevOps is a collaboration between the development team and the operation team, allowing you to continuously deliver solutions and applications and services that both delight and improve the efficiency of your customers. If you look at the Venn diagram that we have here, on the left-hand side we have development, on the right-hand side we have operation, and then there's a crossover in the middle, and that's where the DevOps team sits. If we look at the areas of integration between both groups, developers are really interested in planning, code, building, and testing, and operations want to be able to efficiently deploy, operate, and monitor. When you can have both groups interacting with each other on these 7 key elements, then you can have the efficiencies of an excellent DevOps team. So planning and code base, we use tools like GIT and GITHUB. For building, we use Gradle and MAVEN. Testing, we use Selenium. The integration between dev and ops is through tools such as Jenkins. And then the deployment operation is done with tools such as Docker and Chef. Finally, Nagios is used to monitor the entire environment. So let's step deeper into what Docker actually is. So Docker is a tool which is used to automate the deployment of applications in a lightweight container so the application can work efficiently in different environments. Now, it's important to note that the container is actually a software package that consists of all the dependencies required to run the application. So multiple containers can run on the same hardware. The containers are maintained in isolated environments. They're highly productive and they're quick and easy to configure. So let's take an example of what Docker is by using a house that may be rented for someone using Airbnb. So in the house, there are 3 rooms and only 1 cupboard and kitchen. And the problem we have is that none of the guests are really ready to share the cupboard and kitchen because every individual has a different preference when it comes to how the cupboard should be stocked and how the kitchen should be used. This is very similar to how we run software applications today. Each of the applications could end up using different frameworks. So you may have a framework such as Rails, Perfect, and Flask, and you may want to have them running for different applications for different situations. This is where Docker will help you run the applications with the suitable frameworks. So let's go back to our Airbnb example. So we have 3 rooms and a kitchen and cupboard. How do we resolve this issue? Well, we put a kitchen and cupboard in each room. We can do the same thing for computers. Docker provides the suitable frameworks for each different application. And since every application has a framework with a suitable version, this space can also then be utilized for putting in software and applications that along. And since every application has its own framework and suitable version, the area that we had previously stored for a framework can be used for something else. Now we can create a new application, in this instance a 4th application that uses its own resources. You know what? With these kinds of abilities to be able to free up space on the computer, it's no wonder Docker is the right choice. So let's take a closer look to how Docker actually works. So when we look at Docker and we call something Docker, we're actually referring to the base engine, which actually is installed on the host machine that has all the different components that run your Docker environment. And if we look at the image on the left-hand side of the screen, you'll see that Docker has a client-server relationship. There is a client installed on the hardware. There is a client that contains the Docker product, and then there is a server which controls how that Docker client is created. The communication that goes back and forth to be able to share the knowledge on that Docker client relationship is done through a REST API. And this is fantastic news because that means that you can actually interface and program that API. So we look here in the animation, we see that the Docker client is constantly communicating back to the server information about the infrastructure, and it's using this REST API as that communication channel. The Docker server then will check out the requests and the interaction necessary for it to be the Docker daemon, which runs on the server itself, will then check out the interaction and the necessary operating system pieces needed to be able to run the container. Okay, so that's just an overview of the Docker engine, which is probably where you're going to spend most of your time. But there are some other components that form the infrastructure for Docker. Let's dig into those a little bit deeper as well. So what we're going to do now is break out the 4 main components that comprise of the Docker environment. The 4 components are as follows: the Docker client and server, which we've already done a deeper dive on, Docker images, Docker containers, and the Docker registry. So if we look at the structure that we have here, on the left-hand side, you see the relationship between the Docker client and the Docker server. And then we have the REST API in between. Now, if we start digging into that REST API, particularly the relationship with the Docker daemon on the server, we actually have our other elements that form the different components of the Docker ecosystem. So the Docker client is accessed from your terminal window. So if you are using Windows, it's going to be PowerShell. On Mac, it's going to be your terminal window. And it allows you to run the Docker daemon and the registry service. When you have your terminal window open, so you can actually use your terminal window to create instructions on how to build and run your Docker images and containers. If we look at the images part of our registry here, we actually see that the image is really just a template with the instructions used for creating the containers which you use within Docker. The Docker image is built using a file called the Docker file. And then once you've created that Docker file, you'll store that image in the Docker Hub or registry. And that allows other people to be able to access the same structure of a Docker environment that you've created. The syntax of creating the image is fairly simple. It's something that you'll be able to get your arms around very quickly. And essentially what you're doing is you're creating the option of a new container. You're identifying what the image will look like, what are the commands that are needed, and the arguments for within those commands. And once you've done that, you have a definition for what your image will look like. So if we look here at what the container itself looks like, is that the container is a standalone executable package which includes applications and their dependencies. It's the instructions for what your environment will look like. So you can be consistent in how that environment is shared between multiple developers, testing units, and other people within your DevOps team. Now, the thing that's great about working with Docker is that it's so lightweight that you can actually run multiple Docker containers in the same infrastructure and share the same operating system. This is its strength. It allows you to be able to create those multiple environments that you need for multiple projects that you're working on. Interestingly though, within each container, that container creates an isolated area for the applications to run. So while you can run multiple containers in an infrastructure, each of those containers are completely isolated. They're protected so that you can actually control how your solutions work there. Now, as a team, you may start off with 1 or 2 developers on your team, but when a project starts becoming more important and you start adding in more people to your team, you may have 15 people that are offshore, you may have 10 people that are local, you may have 15 consultants that are working on your project. You have a need for each of those developers or each person on your team to have access to that Docker image. And to get access to that image, we use the Docker registry, which is an open source server-side service for hosting and distributing the images that you have defined. You can also use Docker itself as its own default registry and Docker Hub. Now, something that has to be very in mind though is that for publicly shared images, you may want to have your own private images, in which case you would do that through your own registry. So once again, public repositories can be used to host the Docker images, which can be accessed by anyone. And I really encourage you to go out to Docker and see the other Docker images that have been created, because there may be tools there that you can use to speed up your own development environments. Now, you will also get to a point where you start creating environments that are very specific to the solutions that you are building. And when you get to that point, you'll likely want to create a private repository so you're not sharing that knowledge with the world in general. Now, the way in which you connect with the Docker registry is through simple pull and push commands that you run through terminal window to be able to get the latest information. So if you want to be able to build your own container, what you'll start doing is using the pull commands to actually pull the image from the Docker repository. And the command line for that is fairly simple. In terminal window, you would write docker pull, and then you put in the image name and any tags associated with that image and use the command pulls. So in your terminal window, you would actually use a simple line of command once you've actually connected to your Docker environment. And that command will be docker pull with the image name and any associated tags around that image. What that will then do is pull the image from the Docker repository, whether that's a public repository or a private one. Now, in reverse, if you want to be able to update the Docker image with new information, you do a push command where you would take the script that you've written about the Docker container that you define and push it to the repository. And as you can imagine, the commands for that are also fairly simple. In terminal window, you would write docker push the image name, any associated tags, and then that would then push that image to the Docker repository. Again, either a public or a private repository. So if we recap, the Docker file creates a Docker image that's using the build commands. A Docker image then contains all of the information necessary for you to be able to execute the project. Using the Docker image, any user can run the code in order to create a Docker container. And once a Docker image is built, it's uploaded to a registry or to a Docker hub where it can be shared across your entire team. And from the Docker hub, users can get access to the Docker image and build their own new containers. So let's have a look at what we have in our current environment. So today, when you actually have your standard machine, you have the infrastructure, you have the host operating system, and you have your applications. And then when you create a virtual environment, what you're actually doing is you're actually creating virtual machines, but those virtual machines actually are now sitting within a hypervisor solution that sits still on top of your host operating system and infrastructure. And with a Docker engine, what we're able to do is we're able to actually reduce significantly the different elements that you would normally have within a virtualized environment. So we're able to get rid of the bins and so we're able to get rid of the guest OS, and we're able to eliminate the hypervisor environment. And this is really important as we actually start working and creating environments that are consistent, because we want to be able to make it so that it's really easy and stable for the environment that you have within your dev and ops environment. Now, critical is getting rid of that hypervisor element. It's just a lot of overhead. So let's have a look at a container as an example. So here we actually have a couple of examples. On the right hand side, we have different containers. We have one container that's running Apache Tomcat with Java. A second container is running SQL Server in a Microsoft.NET environment. The third container is running Python with MySQL. These are all running just fine within the Docker engine and sitting on top of a host OS, which could be Linux. It really could be any host OS within a consistent infrastructure. And you're able to have a solution that can be shared easily amongst your teams. So let's have a look at an example that you'd have today if a company is doing a traditional Java application. So you have your developers working in JBoss on his system, and he's coding away, and he has to get that code over to a tester. Now, what will happen is that tester will then, typically in your traditional environment, then have to install JBoss on their machine and get everything running and hopefully set up identically to the developer. Chances are they probably won't have it exactly the same, but they'll try and get it as close as possible. And then at some point, you want to be able to test this within your production environment, so you send it over to a system administrator who would then also have to install JBoss on their environment as well. Yeah, this just seems to be a whole lot of duplication. So why go through the problem of installing JBoss 3 times? And this is where things get really interesting, because the challenge you have today is that it's very difficult to almost impossible to have identical environments if you're just installing software locally on devices. The developer's probably got a whole bunch of development software that could be conflicting with the JBoss environment. The tester has similar testing software, but probably doesn't have all the development software. And certainly the system administrator won't have all the tools that the developer and tester have, their own tools. And so what you want to be able to do is kind of get away from the challenge you have of having to do local installations on 3 different computers. And in addition, what you see is that this uses up a lot of effort, because when you're having to install software over and over again, you just keep repeating doing really basic foundational challenges. So this is where Docker comes in, and Docker is the tool that allows you to be able to share environments from one group to another group without having to install software locally on a device. You install all of the code into your Docker container and simply share the container. So in this presentation, we're going to go through a few things. We're going to cover what Docker actually is, and then we're going to dig into the actual architecture of Docker and kind of go through what Docker container is and how to create a Docker container. And then we'll go through the benefits of using Docker containers and then the commands and finalize everything out with a brief demo. So what is Docker? So Docker is, as you'd expect, because all the software that we cover in this series is an open source solution, and it is a container solution that allows you to be able to containerize all of the necessary files and applications needed to run the solution that you're building. So you can share it from different people in your team, whether it's a developer, tester, or system administrator. And this allows you to have a consistent environment from one group to the next. So let's kind of dig into the architecture so you understand why Docker runs effectively. So the Docker architecture itself is built up of two key elements. There is the Docker client, and then there is a REST API connection to a Docker daemon, which actually hosts the entire environment. Within the Docker host and the Docker daemon, you have your different containers, and each one has a link to a Docker registry. The Docker client itself is a REST service, so as you'd expect, a REST API that sends command line to the Docker daemon through a terminal window or command line interface window. And we'll go through some of these demos later on so you can actually see how you can actually interact with Docker. The Docker daemon then checks the request against the Docker components and then performs the service that you're requesting. Now, the Docker image itself, all it really is a collection of instructions used to create a container. And again, this is consistent with all the DevOps tools that we have. The DevOps tools that we're looking to use throughout this series of videos are all environments that can be scripted. And this is really important because it allows you to be able to duplicate and scale the environments that you want to be able to build very quickly and effectively. The actual container itself has all of the applications and the dependencies of those applications in one package. You kind of think of it as a really effective and efficient zip file. It's a little bit more than that, but it's one file that actually has everything you need to be able to run all of your solutions. The actual Docker registry itself is an environment for being able to host and distribute different Docker images among your team. So say, for instance, you had a team of developers that were working on multiple different solutions. So say you have a team of developers and you have 50 developers and they're working on 5 different applications. You can actually have the applications themselves, the containers, shared in the Docker registry. So each of those teams at any time check out and have the latest container of that latest image of the code that you're working on. So let's dig into what actually is in a container. So the important part of a Docker container is that it has everything you need to be able to run the application. It's like a virtualized environment. It has all your frameworks and your libraries, and it allows the teams to be able to build out and run exactly the right environment that the developer intended. What's interesting though is the actual applications then will run in isolation, so they're not impacting other applications that's using dependencies on other libraries or files outside of the container. Because of the architecture, it really uses a lot less space, and because it's using less space, it's a much more lightweight architecture. So the files, the actual folder itself is much smaller. It's very secure, highly portable, and the boot up time is incredibly fast. So let's actually get into how you would actually create a Docker container. So the Docker container itself is actually built through command line, and it's built of a file and Docker image. So the actual Docker file is a text file that contains all the instructions that you would need to be able to create that Docker image. And then we'll actually then create all of the project code within inside of that image. Then the image becomes the item that you would share through the Docker registry. You would then use the command line, and we'll do this later on, select Docker run and then the name of the image to be able to easily and effectively run that image locally. And again, once you've created the Docker image, you can store that in the Docker registry, making it available to anybody within your network. So something to bear in mind is that Docker itself has its own registry called Docker Hub, and that is a public registry, so you can actually go out and see other Docker images that have been created and access those images. As your own company, you may want to have your own private repository, so you want to be able to go ahead and either do that locally through your own repository, or you can actually get a licensed version of Docker Hub where you can actually then share those files. Now, something that's also very interesting to know is that you can have multiple versions of a Docker image. So if you have a different version control, different release versions, and you want to be able to test and write code for those different release versions because you may have different setups, you can certainly do that within your Docker registry environment. Okay, so let's go ahead and we're going to create a Docker image using some of our basic Docker commands. And so there are essentially really, kind of just two commands that you're going to be looking for. One is the build command, and another one is to actually put it into your registry, which is a push command. So if you want to get an image from a Docker registry, then you want to use the pull command, and a pull command simply pulls the image from the registry, in this example using NGINX as our registry, and we can actually then pull the image down to our test environment on our local machine. So we're actually running the container within our Docker application on a local machine. We're able to then have the image run exactly as it would in production. And then you can actually use the run command to actually use the Docker image on your local machine. So just a few interesting tidbits about the Docker container. Once the container is created, a new layer is formed on top of the Docker image layer. It's called the container layer. Each container has a separate read-write container layer, and any changes made in that Docker container is then reflected upon the particular container layer. And if you want to delete the container layer also gets deleted as well. So, why would using Docker and containers be of benefit to you? Well, some of the things that are useful is that containers have no external dependencies for the applications they run. Once you actually have the container running locally, it has everything it needs to be able to run the application. So there's no having to install additional pieces of software, such as the example we gave with JBoss at the beginning of the presentation. The containers are really lightweight, so it makes it very easy to share the containers amongst your teams, whether it's a developer, whether it's a tester, whether it's somebody on your operations environment. It's really easy to share those containers amongst your entire team. Different data volumes can be easily reused and shared among multiple containers. And again, this is another big benefit, and this is a reflection of the lightweight nature of your containers. The container itself also runs in isolation, which means that it is not impacted by any dependencies you may have on your own local environment. So it's a completely sandboxed environment. So some of the questions you might ask is, can you run multiple containers together without the need to start each one individually? And you know what? Yes, you can with Docker Compose. Docker Compose allows you to run multiple containers in a single service. And again, this is a reflection on the lightweight nature of containers within the Docker environment. So we're going to end our presentation by looking at some of the basic commands that you'd have within Docker. So we have here on the left-hand side, we have a Docker container and then the command for each item. We're actually going to go ahead and use some of these commands in the demo that we're going to do after this presentation. You'll see that in a moment. But just, some of the basic commands we have are committing the Docker image into the container. Kill is a standard kill command to terminate one or more of the running containers so they stop working. Then restart those containers. But certainly you can look at all of the commands here and try them out for yourself. So we're going to go ahead and start a demo of how to use the basic commands to run Docker. So to do this, we're going to open up terminal window or command line, depending whether you're running Linux, PC, or Mac. And we're going to go ahead, and the first thing we want to do is see what our Docker image lists are. So we can go sudo docker images, and this will give us, well, first we'll enter in our password. So let's go enter that in. And this will now give us a list of our Docker images. And here are the Docker images that have already been created in the system. And we can actually go ahead and actually see the processes that are actually running. So I'm going to go ahead and open up this window a little bit more, but this will show you the actual processes and the containers that we actually have. And so on the far left-hand side, you see under names, we have learn, Simplilearn, b_cool. These are all just different ones that we've been working on. So let's go ahead and create a Docker image. So we're going to do sudo docker run -d -p 0.0.0.0 :80:80 Ubuntu, and this will allow us to go ahead and run an Ubuntu image, and this will run the latest image. And what we have here is a hash number, and this hash number is a unique name that defines the container that we've just created, and we can go ahead and we can check to make sure that the container actually is present. So we're going to do sudo docker.ps, and this actually shows on there. So it's not in a running state right now, but that doesn't mean that we don't have it. So let's list out all the containers that are both running and in the exit state. So let's do sucker ps-a, and this lists all the containers that I have running on my machine. And this shows all the ones that have been in the running state and in the exit state. And here we see one that we just created about a minute ago, and it's called learn. And these are all running Ubuntu, and this is the one that we had created just a few seconds ago. Let's open it up, and there we go. So let's change that to that new Docker container to a running state. So scroll down, and we're going to type sudo docker run -it -name my so this is going to be the new container name. It's going to be my Docker. So this is how we name our Docker environment, and we'll put in the image name, which is Ubuntu, and -bin -bash, and it's now in our root, and we'll exit out of that. So now we're going to go ahead and start the new my Docker container. So sudo docker start my, and we'll get the container image, which will be my Docker, return, and that started that Docker image. And let's go ahead and check against the other running Docker images to make sure it's running correctly. So sudo docker ps, and there we are. Underneath name on the right hand side, you actually see my Docker along with the other Docker images that we created. And it's been running for 13 seconds. Quite fast. So we want to rename the container. Let's use the command sudo docker rename. We can take another Docker image. Let's grab this one and we'll put it in rename, and we'll rename, and we'll put in the old container name, which is image, and then we'll put in the new container name, and let's call it purple. So now the container image that had previously been called image is now called purple. So we do sudo docker ps to list all of our Docker images, and if we scroll up, and there we go, purple. How easy is that to rename an image? And we can go ahead and use this command if we want to stop a container. So we're going to write sudo docker stop, and then we'll have to put in the container name, and we'll put in my Docker, the container that we originally created, and that image has now stopped. And let's go ahead and prove that. We're going to list out all the Docker images, and what you see is that it's not listed in the active images. It's not on the list on the far right hand side. But if we go ahead and we can list out all of the Docker images, so you actually see it's still there as an image, it's just not in an active state, it's what's known as in an exit state. So here we go. And there's my Docker. It's in an exited state. So that happened 27 seconds ago. So if we want to remove a container, we can use the following command. So sudo docker rm will remove my Docker, and that will remove it from the exited state. And we're going to go ahead and we're going to double check that. And yep. Yep. It's not listed there under exited state anymore. It's gone. And there we go. That's where it used to be. All right, let's go back. So if we want to exit a container in the running state, so we do sudo kill and then the name of the container. I think one of them is called yellow. Let's just check and see if that's going to kill it. Oops, no, I guess we don't have one called yellow. So let's find out the name of a container that we actually have. So sudo docker kill. Oh, we're going to list out the ones that are running. Oh, okay, there we go. Yellow isn't in that list, so let's take, let's take Simplilearn. And so we can actually go ahead and let's write sudo docker kill Simplilearn. And that will actually kill an active Docker container. Boom, there we go. And we list out all the active containers. You can actually see now that the Simplilearn container is not active anymore. And these are all the basic commands for Docker container.
So if you're ready to embrace this exciting career path, look no further than Simplilearn's Caltech postgraduate program in DevOps. This comprehensive program will equip you with the knowledge and skills needed to master the DevOps principles, tools, and practices. Dive deep into containerization, orchestration, and automation frameworks like Docker, Kubernetes, and Jenkins. Gain hands-on experience with cloud platforms and learn how to leverage the power of infrastructure as code. Don't miss out on this chance to transform your career and become an invaluable asset to any organization. Click the link in the description to discover more about this DevOps course.
We're going to break up this presentation into 4 key areas. We're going to talk about life before Kubernetes, which some of you are probably experiencing right now. What is Kubernetes? The benefits that Kubernetes brings to you, particularly if you are using containers in a DevOps environment. And then finally, we're going to break down the architecture and working infrastructure for Kubernetes so you understand what's happening and why the actions are happening the way that they are. So let's jump into our first section of life before Kubernetes. So the way that you have done work in the past, or you may be doing work right now, is really building out and deploying solutions into 2 distinct areas. One is a traditional deployment where you're pushing out code to physical servers in a data center, and you're managing the operating system and the code that's actually running on each of those servers. Another environment that you may potentially be using is deploying code out to virtual machines. So let's go through and look at the 2 different types of deployment that you may be experiencing. When you have applications running on multiple machines, you run into the potential risk that the setup and configuration of each of those machines isn't going to be consistent and your code isn't going to work effectively, and there may be issues with uptime and errors within the infrastructure of your entire environment. There's going to be problems with resource allocation, and you're going to have issues where applications may be running effectively and not effectively and not load balanced effectively across the environment. The problem that you have with this kind of infrastructure is that it gets very expensive. You can only install one piece of software or one service on one piece of hardware, so your hardware is being massively underutilized. This is where virtual machines have become really popular. With a virtual machine, you're able to have better resource utilization and scalability at much less cost. And this allows you to be able to run multiple virtual machines on a single piece of hardware. The problem is that VMs, or for virtual machines, are not perfect either. Some of the challenges you run with VMs is that the actual hardware and software needed to manage the VM environment can be expensive. There are security risks with VMs. There are security risks with VMs. There have been data breaches recorded about solutions that run in virtualized environments. You also run into an issue of availability, and this is largely because you can only have a finite number of virtual machines running on a piece of hardware. And this results in limitations and restrictions in the types of environment you want to be running. And then finally, setting up and managing a virtualized environment is time consuming. It can take a lot of time, and it can also get very expensive. So how about Kubernetes? Well, Kubernetes is a tool that allows you to manage containerized deployment of solutions. And inherently, Kubernetes is a tool that is really a next level maturity of deployment. So if you can think of your maturity curve as deploying code directly to hardware in a data center, and then deploying your solutions to virtual machines, the next evolution of that deployment is to use containers and Kubernetes. So let's kind of go through and look at the differences between a virtual machine and Kubernetes. And we've got a few here that we want to highlight, and you'll get an understanding of what the differences are between the two. So first of all, with virtual machines, there is inherently security risks. And what you'll find as we dig through the architecture later in the presentation is that Kubernetes is inherently secure. And this is largely because of the legacy code, the legacy of Kubernetes and where it came from. And we'll talk about that in just a moment. But Kubernetes is inherently secure. Virtual machines are not easily portable. Now, with that said, they are technically portable. They're just not very easily portable. Whereas with Kubernetes, it's working with Docker container solutions. It is extremely portable. That means that you can actually spin up and spin down and manage your infrastructure exactly the way that you want it to be managed, and scale it on the demands of the customers as they're coming in to use the solution. From a time-consuming point of view, Kubernetes is much less time-consuming than with a virtual machine. A few other areas that we want to kind of highlight from differences. Virtual machines use much less isolation when building out the encapsulated environment than Kubernetes does. For instance, with a virtual machine, you have to run hypervisor on top of the OS and hardware, and then inside of the virtual machine, you also have to have the operating system as well. Whereas in contrast, on a Kubernetes environment, because it's leveraging Docker container or container-like technologies, it only has to have the OS and the hardware, and then inside of each container, it doesn't need to have that additional OS layer. It's able to inherit what it needs to be able to run the application. This makes the whole solution much more flexible and allows you to run many more containers on a piece of hardware than versus running virtual machines on a single piece of hardware. So as we highlighted here, VMs are not as portable as Kubernetes, and Kubernetes is portable, directly related to the use of containerization. And because Kubernetes is built on top of containers, it is much less time consuming because you can actually script and automatically allocate resource to nodes within your Kubernetes environment. This allows the infrastructure to run much more effectively and much more efficiently. So this is why, if we look at our evolution of the land of time before Kubernetes, why we are running into a solution where Kubernetes had to come about, because the demand for having more highly scalable solutions that are more efficient was just really a natural evolution of this software deployment model that started with pushing out code to physical hardware and then pushing code out to virtual machines, and then needing to have a solution much more sophisticated. Kubernetes would have come about at some point in time. I'm just really glad it came about when it did. So What is Kubernetes? Let's dig into the history of Kubernetes and how it came about. So in essence, Kubernetes is an open source platform that allows you to manage and deploy and maintain groups of containers. And a container is something like Docker. And if you're developing code, you're probably already using Docker today. Consider Kubernetes as the tool that manages multiple Docker environments together. Now, we talk a lot about Docker as a container solution with Kubernetes. The reality is that Kubernetes can actually use other container tools out there, but Docker just simply is the most popular container out there. Both these tools are open source. That's why they're so popular. And they just allow you to be able to have flexibility in being able to scale up your solutions. And they were designed for the post-digital world that we live and exist in today. So a little bit of background, a little bit of trivia around Kubernetes. So Kubernetes was originally a successor to a project at Google, and the original project was Google Borg. Google Borg, it does exactly what Kubernetes does today, but Kubernetes was rewritten from the ground up and then released as an open source project in 2014 so that people outside of Google could take advantage of the power of Kubernetes containerization management tools. And today it is managed by the Cloud Native Computing Foundation. And there are many companies that support and manage Kubernetes. So for instance, if you're signing up for Microsoft Azure, AWS, Google Cloud, all of them will leverage Kubernetes, and it's just become the de facto tool for managing large groups of containers. So let's kind of step through some of the key benefits that you'd experience from Kubernetes. So we have 9 key benefits. The first, it is highly portable. It is 100% open source code. And this means that you can actually go ahead and contribute to this code project if you want to through GitHub. The ability to scale up the solution is incredible. What's the history of Kubernetes being part of a Google project for managing the Google network and infrastructure kind of really sets the groundwork for having a solution that is highly scalable. Out of the high scalability also comes the need for high availability. And this is the desire to be able to have a highly efficient and highly energized environment that also you can really rely on. So if you're building out a Kubernetes management environment, you know that it's going to be available for the solutions that you're maintaining. And it's really designed for deployment. So you can script out the environment and actually have it as part of your DevOps model so you can scale up and meet the demands of your customer. Then what you'll find is that the load balancing is extremely efficient, and it allows you to distribute the load efficiently across your entire network so your network remains stable. And then also the tool allows you to manage the orchestration of your storage. So you can have local storage such as an SSD on the hardware that the Kubernetes is maintaining. Or if the Kubernetes environment is pulling storage from a public cloud such as Azure or AWS, you can actually go ahead and make that available to your entire system. And you can inherit the security that goes back and forth between the cloud environments. And one of the things you'll find consistent with Kubernetes is that it is designed for a cloud-first environment. Kubernetes as well is that it's really a self-healing environment. So if something happens or something fails, Kubernetes will detect that failure and then either restart the process, kill the process, or replace it. And then because of that, you also have automated rollouts and rollbacks in case you need to be able to manage the state of the environment. And then finally, you have automatic bin packaging, so you can actually specify the compute power that's being used from CPU and RAM for each container. So let's dig into the final area, which is the actual Kubernetes architecture. And we're going to cover this at a high level. There's actually another video that you can that Simplilearn has developed, which digs deeper into the Kubernetes architecture. And so the Kubernetes architecture is a cluster-based architecture, and it's really about 2 key areas. You have the Kubernetes master, which actually controls all of the activities within your entire Kubernetes infrastructure. And then you have nodes that actually are running on Linux machines that are controlled by the master. So let's kind of go through some of these areas. So if we look at the Kubernetes master to begin with, we'll start with etc. This is a tool that allows for the configuration of information and the management of nodes within your cluster. And one of the key features that you'll find with all of the tools that are managed within either the master environment or within a node is that they are all accessible via the API server. And what's interesting about the API server is that it's a RESTful based infrastructure, which means that you can actually secure each connection with SSL and other security models to ensure that your entire infrastructure and the communication going back and forth across your infrastructure is tightly secured. Scheduler goes ahead and actually, as you'd expect, it actually manages the schedule of activities within the actual cluster. And then you have the controller, and the controller is a daemon server that actually manages and pushes out the instructions to all of your nodes. So the other tools really are the infrastructure, and you can consider them the administration side of the master, whereas controller is the management. It actually pushes out all of the controls via the API server. So let's actually dig into one of the actual nodes themselves, and there are three key areas of the nodes. One is the Docker environment, which actually helps and manage and maintain the container that's actually inside of the node. And then you have the kubelet, which is responsible for information that goes back and forth, and it's going to do most of the conversation with the API server on the actual health of that node. And then you have the actual Kubernetes proxy, which actually runs the services actually inside of the node. So as you see, all of these infrastructures are extremely lightweight and designed to be very efficient and very available for your infrastructure. And so here's a quick recap of the different tools that are available. And it really breaks down into two key areas. You have your Kubernetes master and the Kubernetes node. The Kubernetes master has the instructions of what's going to happen within your Kubernetes infrastructure. And then it's going to push out those instructions to an indefinite number of nodes that will allow you to be able to scale up and scale down your solution in a dynamic way. Let's have an overview of the Kubernetes architecture. So Kubernetes is really broken up into three key areas. You have your workstation where you develop your commands and you push out those commands to your master, and the master is comprised of four key areas which essentially control all of your nodes, and the node contains multiple pods, and each pod has your Docker container built into it. So consider that you could have really almost an infinite number of infinite number of nodes being managed by the master environment. So you have your cluster, which is a collection of servers that maintain the availability and the compute power, such as RAM, CPU, and disk utilization. You have the master, which is really components that control and schedule the activities of your network. And then you have the node, which actually hosts the actual Docker virtual machine itself and be able to actually control and communicate back to the master the health of that pod. And we'll get into more detail on the architecture later in the presentation. So you keep hearing me talk about containers, but they really are the center of the work that you're doing with Kubernetes. And the concept around Kubernetes and containers is really just a natural evolution of where we've been with internet and digital technologies over the last 10-15 years. So before Kubernetes, you had tools where you're either running virtual machines or you're running data centers that had to maintain and manage and notify you of any interruptions in your network. Kubernetes is the tool that actually comes in and helps address those interruptions and manages them for you. So the solution to this is the use of containers. So you can think of containers as that natural evolution from 15, 20 years ago. You would have written your code and posted it to a data center. More recently, you probably posted your code to a virtual machine and then moved the virtual machine. Now you actually just work directly into a container, and everything is self-contained and can be pushed out to your environment. The thing that's great about containers, they're isolated environments, very easy for developers to work in them, but it's also really easy for operations teams to be able to move a container into production. So let's kind of step back and look at a competing product to Kubernetes, which is Docker Swarm. Now, one of the things that we have to remember is that Docker containers, which are extremely popular, are built by the company Docker and made open source. And Docker actually has other products. One of those other products is Docker Swarm, and Docker Swarm is a tool that allows you to be able to manage multiple containers. So if we look at some of the benefits of using Docker Swarm versus Kubernetes, one of the things that you'll find is that both tools have strengths and weaknesses. But it's really good that they're both out there because it helps it really kind of justifies the importance of having these kind of tools. So Kubernetes was designed originally from the ground up to be auto-scaling, whereas Docker Swarm isn't. The load balancing is automatic on Docker Swarm, whereas with Kubernetes you have to manually configure load balancing across your nodes. The installation for Docker Swarm is really fast and easy. I mean, you can be up and running within minutes. Kubernetes takes a little bit more time, is a little bit more complicated. Eventually you'll get there. I mean, it's not like it's going to take you days and weeks, but it is a tool that's, when you compare the two, Docker Swarm is much easier to get up and running. Now, what's interesting is that Kubernetes is incredibly scalable, and that's its real strength, is its ability to have strong clusters. Whereas with Docker Swarm, its cluster strength isn't as strong when compared to Kubernetes. Now, you compare it to anything else on the market, it's really good. So this is kind of a splitting hairs kind of comparison, but Kubernetes really does have the advantage here if you're looking at the two compared to each other for scalability. I mean, Kubernetes was designed by Google to scale up and support Google Cloud network infrastructure. They both allow you to be able to share storage volumes. With Docker, you can actually do it with any container that is managed by the Docker Swarm, whereas with Kubernetes, it manages the storage with the pods, and a pod can have multiple containers within it, but you can't take it down to the level of the container. Interestingly, Kubernetes does have a graphical user interface for being able to control and manage the environment. The reality, however, is that you're likely to be using terminal to actually make the controls and commands to control your either Docker Swarm or Kubernetes environment. It's great that it has a GUI to get you started, but once you're up and running, you're going to be using terminal window for those fast, quick administrative controls that you need to make. So let's look at the hardware components for Kubernetes. So what's interesting is that Kubernetes is extremely light. Of all the systems that we're looking at, it's extremely lightweight. It allows you to have, if you compare it to like a virtual machine, which is very heavy, Kubernetes is extremely lightweight and hardly uses any resources at all. Interesting enough, though, is that if you are looking at the usage of CPU, it's better to actually take it for the cluster as a whole rather than individual nodes, because the nodes will actually combine together to give you that whole compute power. Again, this is why Kubernetes works really well in the cloud, where you can do that kind of activity rather than if you're running in your own data center. So you can have persistent volumes such as a local SSD, or you can actually attach to a cloud data storage. Again, Kubernetes is really designed for the cloud. I would encourage you to use cloud storage wherever possible rather than relying on physical storage. The reason being is that if you connect to cloud storage and you need to flex your storage, the cloud will do that for you. I mean, that's just an inherent part of why you'd have cloud storage. Whereas if you're connecting to physical storage, you're always restricted to the limitations of the physical hardware. So let's kind of pivot and look at the software components as compared to the hardware components. So the main part of the components is the actual container, and all of the software running in the container runs on Linux. So if you have Docker installed as a developer on your machine, it's actually running inside of Linux. That's what makes it so lightweight. And really, one of the things that you'll find is that most data centers and cloud providers now are running predominantly on Linux. Inside of the container itself is then managed inside of a pod, and a pod is really just a group of containers bundled together. And the Kubernetes scheduler and proxy server will then actually manage how the pods are actually pushed out into your Kubernetes environment. The pods themselves can actually then share resources for both networking and storage. So pods aren't pushed out manually. They're actually managed through a layer of abstraction part of their deployment. And this is the strength of Kubernetes. You define your infrastructure, and then Kubernetes will then manage it for you. And there isn't that problem of manual management of pods if you have to manage the deployment of them. That's simply taken away, and it's completely automated. And the final area of software services is on ingress, and this is really the secure way of being able to have communication from outside of the cluster and passing of information into that cluster. And again, this is done securely through SSL layers, and allows you to ensure that security is at the center of the work that you have within your Kubernetes environment. So let's dive now into the actual architecture before we start looking at a use case of how Kubernetes is being employed. So Kubernetes, again, is we looked at this diagram at the beginning of the presentation, and there are really three key areas. There's the workstation where you develop your commands, and then you have your master environment, which controls the scheduling, the communication, and the actual commands that you have created, and pushes those out and manages the health of your entire node network. And each node has various pods. So we break this down. So the master node is the most vital component. With the master, you have four key controls. You have etc., controller manager, scheduler, and API server. The cluster store, etc., this actually manages the details and values that you've developed on your local workstation, and then we'll work with the controller, schedule, and API server to communicate that out, those instructions of how your infrastructure should look like to your entire network. The control manager is really an API server, and again, this is all about security. So we use RESTful APIs, which can be packaged in SSL to communicate back and forth across your pods and the master, and indeed the services within each of them as well. So at every single layer of abstraction, the communication is secure. The schedule, as the name would imply, really schedules when tasks get sent out to the actual nodes themselves. The nodes themselves are dumb nodes. They just have the applications running on them. The master is really doing all of the work to make sure that your entire network is running efficiently. And then you have the API server, which has your REST commands and the communication back and forth across your network that is secure and efficient. So your node environment is where all the work that you do with your containers gets pushed out to. So a work is really it's a combination of containers, and each container will then logically run together on that node. So you'd have a collection of containers on a node that all make logical sense to have together. Within each node, you have Docker, and this is your isolated environment for running your container. You have your kubelet, which is a service for conveying information back and forth to the service about the actual health of the Kubernetes node itself. And then finally, you have the proxy server, and the proxy server is able to manage the nodes, the volumes, the creation of new containers, and actually helps pass the health of the container back up to the master to see whether or not the container should be either killed, stop started, or updated. So finally, let's see where Kubernetes is being used by other companies. So, Kubernetes is being used by a lot of companies, and they're really using it to help manage complex existing systems so that they can have greater performance, and with the end goal of being able to delight the customer, increase value to the customer, and hence increase value and revenue into the organization. So an example of this is a company called BlackRock, where they actually went through the process of implementing Kubernetes. So BlackRock had a challenge where they needed to be able to have much more dynamic access to their resources. They were running complex installations on people's desktops, and it was just really, really difficult to be able to manage their entire infrastructure. So they actually then pivoted to using Kubernetes, and this allowed them to be able to be much more scalable and expansive in the management of their infrastructure. And as you can imagine, Kubernetes was then hooked into their entire existing system and has really become a key part of the success that BlackRock is now experiencing of a very stable infrastructure. And the bottom line is that BlackRock is now able to have confidence in their infrastructure and be able to give that confidence as back to their customers through the implementation and more rapid deployment of additional features and services as one of the key tools that you would have within your DevOps environment. So the things that we're going to go through today is we're going to cover why you would want to use a product like Ansible, what Ansible really is and how it's of value to you in your organization, the differences between Ansible and other products that are similar to it on the market and what makes Ansible a compelling product. And then we're going to dig into the architecture for Ansible. We're going to look at how you would create a playbook, how you'd manage your inventory of your server environments, and then what is the actual workings of Ansible. As a little extra, we're going to also throw in Ansible Tower, one of the secret source solutions that you can use for improving the speed and performance of how you create your Ansible environments. And finally, we're going to go through a use case by looking at Hootsuite, a social media management company, and how they use Ansible to really improve the efficiency within their organizations. So let's jump into this. So the big question is, why Ansible? So you have to think of Ansible as another tool that you have within your DevOps environment for helping manage the servers. And this definitely falls on the operations side of the DevOps equation. So if we look here, we have a picture of Sam, and like yourselves, Sam is a system administrator, and he is responsible for maintaining the infrastructure for all the different servers within his company. So some of the servers that he may have that he has to maintain could be web servers running Apache, they could be database servers running MySQL. And if you only have a few servers, then that's fairly easy to maintain. I mean, if you have 3 web servers and 2 database servers, and let's face it, wouldn't we all love just to have 1 or 2 servers to manage? It would be really easy to maintain. The trick, however, is as we start increasing the number of servers, and this is a reality of the environments that we live and operate in, it becomes increasingly difficult to create consistent setup of different infrastructures such as web servers and databases for the simple reason that we're all human. As if we had to update and maintain all of those servers by hand, there's a good chance that we would not set up each server identically. Now, this is where Ansible really comes to the rescue and helps you become an efficient operations team. Ansible, like other system solutions such as Chef and Puppet, uses code that you can write and describe the installation and setup of your servers. So you can actually repeat it and deploy those servers consistently into multiple areas. So now you don't have to have one person redoing and refollowing setup procedures. You just write one script and then each script can be executed and have a consistent environment. So we've gone through why you'd want to use Ansible. Let's step through what Ansible really is. So, this is all great, but, how do we actually use these tools in our environment? So Ansible is a tool that really allows you to create and control 3 key areas that you would have within your operations environment. First of all, there's IT automation. So you can actually write instructions that automate the IT setup that you would typically do manually in the past. The second is the configuration and having consistent configuration. Imagine setting up hundreds of Apache servers and being able to guarantee with precision that each of those Apache servers is set up identically. And then finally, you want to be able to automate the deployment so that as you scale up your server environment, you can just push out instructions that can deploy automatically different servers. The bottom line is you want to be able to speed up and make your operations team more efficient. So let's talk a little bit about pull configuration and how it works with Ansible. So there are 2 different ways of being able to set up different environments for server farms. One is to have a key server that has all the instructions on, And then on each of the servers that connect to that main master server, you would have a piece of software known as a client installed on each of those servers that would communicate to the main master server and then would periodically either update or change the configuration of the slave server. This is known as a pull configuration. An alternative is a push configuration, and the push configuration is slightly different. The main difference is, as with a pull configuration, you have a master server where you actually put up the instructions. But unlike the pull configuration where you have a client installed on each of the services, with a push configuration, you actually have no client installed on the remote servers. You simply are pushing out the configuration to those servers and forcing a restructure or a fresh, clean installation in that environment. So Ansible is one of those second environments where it's a push configuration server. And this contrasts with other popular products like Chef and Puppet, which have a master-slave architecture with a master server connecting with a client on a remote slave environment where you would then be pushing out the updates. With Ansible, you're pushing out the service and the structure of the server to remote hardware, and you are just putting it onto the hardware irrelevant of the structure that's out there. And there are some significant advantages that you have in that you're not having to have the extra overhead weight of a client installed on those remote servers having to constantly communicate back to the master environment. So let's step through the architecture that you would have for an Ansible environment. So when you're setting up an Ansible environment, the first thing you want to do is have a local machine. And the local machine is where you're going to have all of your instruction and really the power of the control that you'd be pushing out to the remote server. So the local machine is where you're going to be starting and doing all of your work. Connected from the local machine are all the different nodes pushing out the different configurations that you would set up on the local machine. The configurations that you would write, and you would write those in code, are within a module. So you do this on your local machine for creating these modules, and each of these modules is actually consistent playbooks. The local machine also has a second job, and that job is to manage the inventory of the nodes that you have in your environment. The local machine is able to connect to each of the different nodes that you would have in your hardware network through SSH clients, so a secure client. Let's dig into some of the different elements within that architecture. And we're going to take a first look at playbooks that you would write and create for the Ansible environments. So the core of Ansible is the playbook. This is where you create the instructions that you write to define the architecture of your hardware. So the playbook is really just a set of instructions that configure the different nodes that you have, and each of those set of instructions is written in a language called YAML. And this is a standard language used for configuration server environments. Did you know that YAML actually stands for YAML Ain't Markup Language? That's just a little tidbit to hide behind your ear. So let's have a look at one of these playbooks it looks like. And here we have a sample YAML script that we've written. So you start off your YAML script with 3 dashes, and that indicates the start of a script. And then the script itself is actually consistent of 2 distinct plays. At the top we have play 1, and below that we have play 2. Within each of those plays we define which nodes are we targeting. So here we have a web server in the top play, and in the second play we have a database server that we're targeting. And then within each of those server environments, we have the specific tasks that we're looking to execute. So let's step through some of these tasks. We have an install Apache task, we have a start Apache task, and we have an install MySQL task. And when we do that, we're going to actually execute a specific set of instructions. And those instructions can include installing Apache and then setting the state of the Apache environment, or starting the Apache environment and setting up and running the MySQL environment. So this really isn't too complicated, and that's the really good thing about working with YAML, is it's really designed to make it easy for you as an operations lead to be able to configure the environments that you want to consistently create. So let's take a step back though. We have 2 hosts. We have web server and database server. Where do these names come from? Well, this takes us into our next stage, and the second part of working with Ansible, which is the inventory management part of Ansible. So the inventory part of Ansible is where we maintain the structure of our network environment. So what we do here is part of the structure in creating different nodes is we've had to create two different nodes here. We have a web server node and a database server node. And under web server node, we actually have the names that we're actually pointing to specific machines within that environment. So now when we actually write our scripts, all we have to do is refer to either web server or database server, and the different servers will have the instructions from the YAML script executed on them. This makes it really easy for you to be able to just point to new services without having to write out complex instructions. So let's have a look at how Ansible actually works in real world. So the real world environment is that you would have the Ansible software installed on a local machine, and then it connects to different nodes within your network. On the local machine, you'll have your playbook, which is the set of instructions for how to set up the remote nodes. And then to identify how you're going to connect to those nodes, you'll have an inventory. We use secure SSH connections to each of the servers, so we are encrypting the communication to those servers. We're able to grab some basic facts on each server, so we understand how we can then push out the playbook to each server and configure that server remotely. The end goal is to have an environment that is consistent. So let's ask you a simple question. What are the major opportunities that Ansible has over Chef and Puppet? Really like to hear your answers in the comments below. Pop them in there and we'll get back to you, and really want to hear how you feel that Ansible is a stronger product, or maybe you think it's a weaker product as it compares to other similar products in the market. Here's the bonus. We're going to talk a little bit about Ansible Tower. So Ansible Tower is an extra product that Red Hat created that really kind of puts the cherry on the top of the ice cream, or is the icing on your cake. Ansible by itself is a command line tool. However, Ansible Tower is a framework that was designed to access Ansible. And through the Ansible Tower framework, we now have an easy to use GUI. This really makes it easy for non-developers to be able to create the environment that they want to be able to manage in their DevOps plan without having to constantly work with the command prompt window. So instead of opening up terminal window or a command window and writing out complex instructions only in text, you can now use drag and drop and mouse click actions to be able to create your appropriate playbooks, inventories, and pushes for your nodes. All right, so we've talked a lot about Ansible. Let's take a look at a specific company that's using Ansible today. And in this example, we're going to look at Hootsuite. Now, Hootsuite, if you've not already used their products, and they have a great product, Hootsuite is a social media management system. They are able to help with you managing your pushes of social media content across all of the popular social media platforms. They're able to provide the analytics, they're able to provide the tools that marketing and sales teams can use to be able to assess a sentiment analysis of the messages that are being pushed out. Really great tool and very popular. But part of their popularity drove a specific problem straight to Hootsuite. The challenge they had at Hootsuite is that they had to constantly go back and rebuild their server environment, and they couldn't do this continuously and be consistent. There was no standard documentation, and they had to rely on your memory to be able to do this consistently. Imagine how complex this could get as you're scaling up with a popular product that now has tens of thousands to hundreds of thousands of users. This is where Ansible came in and really helped the folks over at Hootsuite. Today, the DevOps team at Hootsuite write out playbooks that have specific instructions that define the architecture and structure of their hardware nodes and environments, and are able to do that as a standard product. Instead of it being a problem in scaling up their environment, they now are able to rebuild and create new servers in a matter of seconds. The the bottom line is Ansible has been able to provide Hootsuite with IT automation, consistent configuration, and free up time from the operations team so that instead of managing servers, they're able to provide additional new value to the company. There are going to be 6 things that we're going to step through. The first is really looking at what is the world that many of you already work in today? How do you administer your networks and your systems today? Then we're going to look at how Chef can be the tool that really helps improve the efficiencies of creating a consistent operations environment. We're going to look at the tools and the components and the architecture that it takes to construct Chef. And then finally, we're going to take a use case of one of the many companies that is using Chef today to improve the efficiency of their operations environment. So let's take a step back at what life was like before Chef. This may well be the life that you're experiencing right now. So as a system administrator, typically the way that you work is that you are responsible for the uptime of all of the systems within your network. And you may have many systems that you are responsible for. Now, if one system goes down, that's not a problem, because as a system administrator, you can get notifications and you can jump right onto the problem and solve it. When things start getting really difficult, however, is when you have multiple systems and you are not able as a single person to get to all those systems and solve them as quickly as possible. The problem that you start having is that your environments are not in sync. If only this could all be automated. Well, this is where Chef comes to the rescue for you. So let me take some time and introduce you to the concepts behind Chef and why it's a tool that you would probably want to be using in your environment. So what actually is Chef? So Chef is a way in which you can use code to fix your physical hardware environment. So what does that look like? Well, the way that we write out scripts in Chef is that you can actually code your entire environment. So you don't have to actually be managing your environment on a hardware by hardware basis, but actually use scripts called recipes that will actually manage the environment for you. So Chef will actually ensure that every system is automatically set to the right states that meet the requirements that you have defined in your code. So you don't have any issues where hardware starts to fail, because it references the code to reset the state within that environment. And that makes you a happy system administrator. So let's go through the mechanics of how this actually works with Chef. So Chef is ultimately an automation tool that converts infrastructure to code. And you'll often hear the term infrastructure as code, or IAC. And this really starts as an output of the work that Chef has done. Because you take the policies that you as an organization have created and you convert that into a scripted language that can then be implemented automatically. This enables Chef to be able to manage multiple systems very easily. And considering how broad and deep our systems become, it's very easy to see how this can help you as a system administrator. The code is then tested continuously and deployed by Chef so that you're able to guarantee that your standards and appropriate states for your hardware and operating environment are always maintained. So let's step through the different components that are available in Chef. So the first one is actually creating the actual recipes for Chef. So you actually work on these on a workstation and you'll write out your code, which is referred to as a recipe. And that recipe will be written using a language called Ruby. Good thing for you is that there are lots of examples of Ruby recipes that have been created by the open source community. A lot of examples. Knife is the command tool that you use that communicates between the recipes and the server. So your recipe is the instruction and Knife is the tool that makes that instruction work and sets the appropriate state on the server environment. When you create more than one recipe, you start creating a collection. Those collections are referred to as cookbooks. And you may take an environment such as a large network where you have multiple nodes potentially hundreds of servers that have to all have a consistent and equal state environment, and you would put that cookbook and use that cookbook to ensure with Chef that the state of each of those nodes is consistent. And then Ohai fetches the current state of your nodes, and then the Chef client configures the nodes as defined within your cookbook. So let's step through the architecture and working environment of Chef. So for an administrator, a systems administrator, you only have to now work from your workstation. And from that workstation, you can then configure all the nodes of your environment. You can use different recipes that you create, and those recipes can be compiled into a cookbook that can be then applied to a node. The thing that's of value is that as you change the environment, as you move and mature as an organization, and your nodes need to mature consistently and quickly with your organization, all you have to do is roll out a different recipe to your nodes, and then the nodes will use the tools within Chef to make the updates. So you can create a second recipe or even a third recipe to be deployed out to your server environment. Knife is going to be the tool that does the hard work of doing the updates on the server. With the server, you have your collection of recipes in a single cookbook. However, understanding the state of the individual nodes is important to ensure that the information is broadcast from the server with the instructions on how to set up the network within those nodes. In this instance, we use Ohai, and Ohai will fetch the state of the nodes and send that back to the server and get the information from the cookbook using the Chef client. In your Chef node network, there is the potential at times that maybe one of your node fails. If there are two failed nodes, then a request is sent back to the server, and information on the latest node structure that is identified and defined in the cookbook will be sent to the failed nodes. If that fails to reset the nodes, then the workstation is notified, and you as the administrator will receive a notification to manually reset those nodes. It should be noted that this is a very rare occasion within the Chef network setup. So let's step through a use case. In this instance, we're going to look at Hapoleum and how they used Chef. So Hapoleum is a bank, and it's the largest bank in Israel. And they have a mixture of Linux and Windows servers that they have to maintain. And as you can imagine, this requires a lot of constant configuration and work, and this has led to issues in the past. So the challenge that the team at Hapoleum faced was creating and hardening software that ran the major tasks and was repeatable on those servers, that it didn't matter who the people were performing the jobs, that there was consistency in the work that was being done, and address the problem that the servers, including the hardware on the servers, was not consistent throughout the organization. Chef addresses those specific problems and became the go-to product for Hapoleum. They were able to write the recipes and the cookbooks that could be deployed out to the network effectively. And it didn't matter what the system was, the recipes reflected the standards that the system administration team put together. And they were able to ensure and test each script and use standard testing tools for those scripts. It didn't matter what kind of environment that Hapoleum had, if certain ports need to be closed, or if a firewall needs to be installed or modified, or if custom strong passwords had to be created. All of this could be done using the recipes that Chef offers. And once those recipes had been finalized, they could be packaged into a common cookbook that could then be deployed to the entire network, ensuring a consistency in results for the company. And also, it didn't matter whether the cookbooks were being deployed to Linux or Windows machine, because the scripts were being put together in the recipes and were written in Ruby. You could actually go through and update and modify those scripts depending on the environment. So if you needed to make a modification for Linux, you could make those modifications so they were consistent across all the Linux servers or all the Windows servers. And this really drove in the ability to harden and secure the environment in the entire network within a matter of minutes using Chef versus the days and weeks that it previously took. So if we take a before and after scenario using Chef, before Chef, tasks were repeated multiple times and it was just hard to keep track of all the people doing the work. And the reality is, because so many people were touching all the different systems, specific standards that the banks had established were simply not being met. After Chef, all of the tasks could be scripted using Ruby, and using the recipe and cookbook model that Chef has created, the Chef tool was able to deploy out to the entire network specific cookbooks that provided a consistent experience and consistent setup and operation environment for all the hardware. The end result is that the system administration team could guarantee that the standards of the bank were being met consistently. So in this session, what we're going to do is we're going to cover what and why you would use Puppet, what are the different elements and components of Puppet and how does it actually work, and then we'll look into the companies that are adopting Puppet and what are the advantages that they have now received by having Puppet within their organization. And finally, we'll wrap things up by reviewing how you can actually write a manifest in Puppet. So let's get started. So why Puppet? So here is a scenario that as an administrator, you may already be familiar with. You as an administrator have multiple servers that you have to work with and manage. So what happens when a server goes down? It's not a problem. You can jump onto that server and you can fix it. But what if the scenario changes and you have multiple servers going down? So here is where Puppet shows its strength. With Puppet, all you have to do is write a simple script that can be written with Ruby and write out and deploy to the servers your settings for each of those servers. The code gets pushed out to the servers that are having problems, and then you can choose to either roll back to those servers to their previous working states or set them to a new state and do all of this in a matter of seconds. And it doesn't matter how large your server environment is, you can reach to all of these servers. Your environment is secure, you're able to deploy your software, and you're able to do this all through infrastructure as code, which is the advanced DevOps model for building out solutions. So let's dig deeper into what Puppet actually is. So Puppet is a configuration management tool. Maybe similar tools like Chef that you may already be familiar with. It ensures that all your systems are configured to a desired and predictable state. Puppet can also be used as a deployment tool for software. Automatically, you can deploy your software to all of your systems or to specific systems. And this is all done with code. This means you can test the environment and you can have a guarantee that the environment you want is written and deployed accurately. So let's go through those components of Puppet. So here we have a breakdown of the Puppet environment. And on the top, we have the main server environment. And then below that, we have the client environment that would be installed on each of the servers that would be running within your network. So if we look at the top part of the screen, we have here our Puppet master store, which has and contains our main configuration files. And those are comprised of manifests that are actual codes for configuring the clients. We have templates that combine our codes together to render a final document. And you have files that will be deployed as content that could be potentially downloaded by the clients. Wrapping this all together is a module of manifests, templates, and files. You would apply a certificate of authority to sign the actual documents so that the clients actually know that they're receiving the appropriate and authorized modules. Outside of the master server where you'd create your manifests, templates, and files, you would have Puppet Client is a piece of software that is used to configure a specific machine. There are two parts to the client. One is the agent that constantly interacts with the master server to ensure that the certificates are being updated appropriately. And then you have the factor, that the current state of the client that is used and communicated back to through the agent. So let's step through the workings of Puppet. So the Puppet environment is a master-slave architecture. The clients themselves are distributed across your network, and they are constantly communicating back to a master server environment where you have your Puppet modules. The client agent sends a certificate with the ID of that server back to the master. And then the master will then sign that certificate and send it back to the client. And this authentication allows for a secure and verifiable communication between client and master. The factor then collects the state of the client and sends that to the master. Based on the facts sent back, the master then compiles manifests into the catalogs, and those catalogs are sent back to the clients, and an agent on the client will then initiate the catalog. A report is generated by the client that describes any changes that have been made and sends that back to the master, with the goal here of ensuring that the master has full understanding of the hardware running software in your network. This process is repeated at regular intervals, ensuring all client systems are up to date. So let's have a look at companies that are using Puppet today. There are a number of companies that have adopted Puppet as a way to manage their infrastructure. So companies that are using Puppet today include Spotify, Google, AT&T. So why are these companies choosing to use Puppet as their main configuration management tool? And the answer can be seen if we look at a specific company. Staples. So Staples chose to take and use Puppet for their configuration management tool and use it within their own private cloud. The results were dramatic. The amount of time that the IT organization was able to save in deploying and managing their infrastructure through using Puppet enabled them to open up time to allow them to experiment with other and new projects and assignments, a real tangible benefit to a company. So let's look at how you write a manifest in Puppet. So manifests are designed for writing out in code how you would configure a specific node in your server environment. The manifests are compiled into catalogs, which are then executed on the client. Each of the manifests are written in the language of Ruby with a .pp extension. And if we step through the 5 key steps for writing a manifest, they are: 1. Create your manifest, and that is written by the system administrator. 2. Compile your manifest, and it's compiled into a catalog. 3. Deploy. The catalog is then deployed onto the clients. 4. Execute. The catalogs are run on the client by the agent. And then 5. End. Clients are configured to a specific and desired state. If we actually look into how a manifest is written, it's written with a very common syntax. If you've done any work with Ruby or really configuration of systems in the past, this may look very familiar to you. So we break out the work that we have here. You start off with a package, file, or service as your resource type, and then you give it a name, and then you look at the features that need to be set, such as IP address. Then you're actually looking to have a command written, such as present or start. The manifest can contain multiple resource types. If we continue to write our manifest in Puppet, the default keyword applies a manifest to all clients. So an example would be to create a file path that creates a folder called sample in a main folder called etc. The specified content is written into a file that is then posted into that folder. And then we're going to say we want to be able to trigger an Apache service, and then ensure that that Apache service is installed on a node. So we write the manifest and we deploy it to a client machine. On that client machine, a new folder will be created with a file in that folder, and an Apache server will be installed. You can do this to any machine and you'll have exactly the same results on those machines.
Before you start understanding any automation tool, it's good to look back into what manual testing is all about, what are its challenges, and how an automation tool overcomes these challenges. Challenges are always overcome by inventing something new. So let's see how Selenium came into existence and how did it evolve to become one of the most popular web application automation tools. Selenium suite of tools. Selenium is not a single tool. It has multiple components, and we will be looking into each of them. As you know, every automation tool has its own advantages and limitations. So we will be understanding the advantages and limitations of Selenium and how do we work around it. Selenium jobs and salary. Very important, isn't it? You are here to learn Selenium. You definitely want to know what's the market demand on this skill, what worth you will be once you are skilled on this automation tool. So what we will do, we'll just discuss some stats on the job market related to test automation and Selenium in particular. Alright, so let's get started. Manual testing and its challenges. What is manual testing? Manual testing mainly involves physical execution of test cases against various applications. And to do what? To detect bugs and errors. So as a definition, if you can say, it is one of the primitive methods of testing a software. Execution of test cases without using any automation tools. It does not require the knowledge of any automation tools and can practically test any application. This could be as simple a definition can be. Let's do one thing. Let's take an example, right? Before we start understanding what are the challenges of manual testing and why we have to really look into any automation tools, let's take a simple example. Say we have a simple use case. As a user, I want to log into my web application using username and password. A very common use case, isn't it? And this is a common use case for any kind of web application under test. Now let's say, for example, I have a web application here. Say I have this community.simplilearn.com. For me to actually enter into this application, what I need to do is first log in into this application. So this is a simple login page which accepts a user ID or an email ID, a password, and you click on the login. Now as a tester, you would write multiple test cases to test this use case. For example, you will have multiple data test cases like valid credentials, invalid credentials, null value, and so on. You will also test multiple links on this page, probably the forget password link, the sign up now. So whatever links are made available, you're going to test that. Then you will say test this checkbox. So you will check the remember me functionality, and when you log in back again, you want to validate if all your previous data are filled up. You will also check for error messages on an invalid login. You will do accessibility testing. You will also do a performance on this page. Like say for example, response time after you click on login button and so on. So while you're doing a manual testing, literally you can do any kind of test you want. So this is what you do in the first place. And then you start executing these test cases one by one. You will find bugs, your developers are going to fix them, and you will need to rerun all these test cases again and again until all your bugs are fixed and your application is ready to ship. Now this is a very simple use case. Now let's look at a little complex use case now. Say you have an account creation form like this. So I have this online PAN application form, right? This is still a simpler form, I would say. Now look at the amount of data you need to fill here. Each and every field you need to test, and you need to test this with hundreds of transactions because you're going to have those kind of data sets with you, and then you're going to repeat them again and again until you are satisfied that your application is working as per it is designed. So now if you go back to our presentation, now this brings us to the first demerit of the manual testing, and what it is, this is very time consuming process, and hence it's going to get very boring for any manual tester. Also, it is more error prone. The risk of error is pretty high. Why? Because it is done manually and human mistakes are bound to happen. It requires presence of tester all the time. Since it's manual execution, tester's presence is required all the time. One needs to keep doing manual steps over and over again, and hence he needs to be sitting in front of his PC. Manual creation of logs and repositories. Creating manual reports. Grouping them. Formatting them so that they are like a good looking reports, sending those reports manually to all the stakeholders, say collecting logs from the various machines after you execute the test cases, consolidating all those results and logs, right? Creating repositories, maintaining them. Wow, this is a huge long list of mundane tasks one needs to do. And this you need to do again and again until your testing is completed, right? So this is going to be a manual process and it's going to be very tedious. And as I said, it is also error prone. Limited scope. The scope of manual testing is very limited. For example, say regression testing. Ideally, you would want to run all the test cases which you have written. But since it's a manual process, you would not have the luxury of time to execute all of them. And hence what you do, you will pick up, choose your test cases and then execute. That way you are kind of limiting the scope of testing. Also, say working with large amount of data, which is manually pretty impractical. What about performance testing? So you want to say collect certain metrics on various performance measures as a part of your performance testing. You want to simulate certain multiple loads on your application which is under test. Hence, performing this manually is definitely not feasible. And to top it all this, say you're working in an agile model where your code is being churned out by developers, say every week. Testers are building their test and they're executing them as and when the builds are made available to them for testing. Now this happens iteratively, and hence you will need to run all the test cases which you have created multiple times during your development process. And doing this manually is going to become definitely very tedious and boring. And is this really an effective way of doing it? Not at all. So what do? We automate it. So this tells us why we want to automate. One is for the faster execution. Two, to be less error prone. And the most importantly, to help you run your test cases frequently, as many times as you want. So there were many tools available in the market today for automation. So one such tool is Selenium. Advent of Selenium. Much before Selenium, there were various tools in the market like RFT, QTP, just to name a few popular ones. Selenium was introduced by a gentleman called Jason Huggins way back in 2004. He was an engineer at ThoughtWorks. He was working on a web application which needed frequent testing, and he realized the inefficiency manual testing his application repeatedly. So what he did was he wrote a JavaScript program that automatically controlled the browser actions, and he named it as JavaScript Test Runner. He also made this open source, which later was renamed as Selenium Core. And this is how Selenium came into existence. Since then, Selenium has become one of the most powerful tools to test web applications. So what is Selenium? Selenium is the most popular and widely used automation tool for automating your web application. It enables us to test web application on all kind of browsers like IE, Chrome, Firefox, Safari, Edge, Opera, and even the headless browser. Selenium is an open source and it's platform independent. The biggest reason why people are preferring this tool is because it is free of cost, whereas the QTP and RFT, which I mentioned earlier, are the chargeable tools. Selenium is also a set of tools and libraries to facilitate automation of web application. It is not a single tool. It has multiple components in it, which we will be seeing in detail in some time. And all these tools together, they help us test the web application. You can run Selenium scripts on any platform. It is platform independent. And why it is platform independent? Because it is developed in JavaScript. It's very common for manual testers not to have in-depth programming knowledge. So the Selenium has a record and replay back capability, and this tool is called as Selenium IDE, which can be used to create a set of actions as a script, and then you just have to replay that script. So mainly this is used for demo purposes because Selenium itself is such a powerful tool and it offers so rich functionality, you would want to be in a position to take the advantage of all its features. However, if you have testers who do not have enough of programming knowledge to start with, there is still this IDE, which is a record replay tool, which you can use to create your test scripts. It also provides support for different programming languages like Java, Python, C#, Ruby, and so on. So you can literally write your test scripts in any language you like or which you know of. So one need not again know a complete in-depth or an advanced knowledge of any of these languages. Selenium supports different operating systems and browsers. It supports Windows, Macs, Linux, and say if you want to run your test on Ubuntu machines, yes, that is also possible. Right? So on any platform of your choice, Selenium, you can run the test cases. Selenium suite of tools. So now let's go a little more deeper into the Selenium. So as I said, it is a suite of tools, and these are the major components of the Selenium. Selenium IDE, Selenium Remote Control, which is in short called as RC, Selenium WebDriver, and Selenium Grid. From Selenium 3.0 version onwards, you will not find the remote control anymore because it has been deprecated. But you still have your IDE, WebDriver, and Grid components. Now let's take a deeper look into each of these components and understand how they function in this suite of tools. Selenium Integrated Development Environment, which is called as Selenium IDE. So it is the most simplest tool in the suite of Selenium. It's an integrated development environment. It has a record and playback functionality, and it's very, very simple and easy to use too. However, it is mainly used as a prototyping and not used for creating the actual automation for your real-time projects. Why? Because of its own limitations, since it's just a record and replay tool. So this IDE is available as a Firefox plugin and a Chrome extension. So either you can use Firefox or the Chrome browser to record your test scripts in. The commands created in the scripts where you are going to record these commands are called Selenium commands, and these are the commands which interact with your browser. You can also write some of these commands manually while you're recording your scripts, and we'll see how to do that when we talk about the IDE in detail. And it is again a platform independent, so you can deploy IDE on any platform of your choice. So you can have it on your Windows, Linux and Mac OS. However, the only requirement is you should have either Chrome or Firefox browser support on that particular platform. Earlier, Selenium IDE was only a Firefox extension. It died with the Firefox version 54 or 55, I guess. So IDE was not supported from the 55 version onwards, and this was sometime during 2017. However, very recently, all new brand Selenium IDE has been launched by Apply Tools, and they have made it cross-browser. That is, it is available both on Chrome and Firefox now. So you can install this extension as a Chrome extension or as an add-on on your Firefox browser. It's a completely revamped version which was done by Apply Tools. They literally rewrote the complete code, and now they have made it available on the GitHub under the Apache 2.0 license. And it also comes with many new features now, like reusability of test cases. It has a better debugging technology now, and most importantly, it supports parallel test execution. It has introduced an utility called Selenium Side Runner that allows your test cases to run on any browser. So you can create your automation using your IDE on Chrome or Firefox. However, through this side runner from your command prompt, you can execute any of your test cases on any browser of your choice, and that's by achieving your cross-browser testing. You can also run parallel testing using Grid without writing any specific code to do this. Again, this can be done using the Selenium side runner and having the Grid installation done. So let's look at how IDE looks like and what are its components are and how do we work with IDE. Let's go to the Firefox browser now and launch the IDE and see how the IDE looks. So let me go to my Firefox. Now on this browser, if you can see here, there is an icon here which says Selenium IDE, and this appears after you go and install the Selenium IDE plugin. So now I'll just go click on this, and then I already have a project created. So this is the IDE window which gets opened for me. I have a pre-recorded script here, and what the script does is I just open Amazon.in website and I am searching for the product iPhone. Also, I have an assertion statement here which asserts for the web page title, and then I'm closing the browser. So let's first execute the script and see how it works, and then we will get into the details of what are the different components available on this IDE. So for me to execute, what I will do is IDE has a very beautiful feature here to control the speed of the execution. So what I'll do is I'll reduce the speed a little bit so that you should be able to see the complete execution step by step. Now to execute the script, I'll just go here and say run current test. So this opens the Firefox window and the Amazon.in website. It should search for iPhone product now. Then it is going to do the title assertion and close the browser. So if you look here, all the statements look in green now. So that means every step has been executed successfully and there are no errors. So now let's look at the components of this IDE. So the first component which you need to understand is how do you record the test. So there is a start recording button made available to you, clicking on which you can launch any website of the application under test and you can start recording your steps. And once you have recorded, you can use this play button, which is nothing but your run current test button, to execute your test. So if you want to execute multiple tests, then you have an option to do so here, which says run all tests. This particular window, what you're seeing here, right? So this is the window where you have all your commands, which gets recorded when you record your script. And these are pretty simple commands and they're very self-explanatory. Like say for example, open. So it says open and the target is Amazon.in. That means it is giving instruction to your browser to open this particular website. Setting the window size. Clicking on a button. So this is the search button which we have. And then typing what is the product which you're searching for. And then you have multiple assert statements made available to you in this IDE. So these are all called as the Selenium command and as simple as a close browser command. And now if you look here in this window, there is this log window. So every step which gets executed here, there is a log generated showing you the status of the execution of that step. So if at all there is a failure, you would see a red failed mark against that particular step. And the test case will not say completed successfully, it will say the failure occurred. Okay, so it is very simple and very user-friendly kind of an IDE. So let's go back to our presentation. So we saw the play button here and we saw how to record it. I also showed you the commands, the command window what we have. So these are the Selenium commands. And then we saw the log which indicated the execution of each of this command. Now saving the script. So let me go back to the IDE again. So once you have created your test scripts, you have run it successfully, you need to save your project. So for you to save the project, when you click on the save project, every IDE project, it is saved with an extension .sid, which is nothing but Selenium ID. So you just go ahead and click on save. Since I've already saved this project, I'm going to just say cancel. So that's the file extension it uses to save your project. For more details on how to use IDE, you can watch our video on Selenium IDE on Simplilearn.com. Selenium RC. This is Selenium Remote Control. So this was developed by Paul Hammond and he refactored the code and was also credited with Jason as a co-creator of Selenium. RC is used to write web application tests in different programming language. The server itself is written in Java language. It supports multiple programming languages like Java, C#, Perl, Python and PHP. It interacts with the browser with the help of RC server. It uses a simple HTTP GET and POST request for communication. This RC server is also a Selenium 1.0 version, but it got deprecated in Selenium 2.0 and was completely removed in 3.0, and it got replaced by Selenium WebDriver. We will see why this happened when we talk about the Selenium WebDriver. This is the architecture of Selenium Remote Control. So when Jason Huggins introduced Selenium, the tool was JavaScript program and he called it as JavaScript Test Runner, and it is also called as Selenium Core. So every HTML has this JavaScript statements which are executed by this web browser. There is a JavaScript engine which helps in executing this command. Now this had a major issue of something called as same origin policy. Now what is the same origin policy? Same origin policy prohibits your JavaScript from accessing elements or interacting with the scripts from the domain different from where it is launched. And this was for the security measure. For example, every web page in say google.com domain, like say your search, email, Google Drive can be accessible, but nothing outside this domain, like say if you want to access Yahoo or an Amazon, that was not possible due to security reasons obviously. So the testers had to install the Selenium core and the web server which contained your web application which you are basically testing on the same system, and this was not feasible and effective all the time. Now to overcome this, to overcome the same origin policy, what Paul Hammond did was he created something called as this remote server, which is Selenium Remote Control Server, and it acted like a proxy to trick the browser in believing that your core, which is your Selenium core, and your web application under test are on the same domain. Thus by eliminating your same origin policy. And this was called as your Selenium Remote Control, which was a version 1 of Selenium. Now, if you look at the simple architecture of this, what are the things it has? So one is your script, right? First, you need to write your scripts using any supported language, like say PHP, Java, Python, and Ruby, as I mentioned. Now, before we start the testing, what is the requirement of the Selenium 1 version is you need to install the RC server. Now, this RC server is a separate application. So once you install this Selenium server is responsible for receiving the Selenium commands. Now these are the Selenium commands which you have written in your scripts. It interprets them and it executes it on your browser, and the results are sent back to your test scripts. And this browser interaction happens only through this RC server. Again, as I said, using a simple HTTP GET and POST request to communicate. Now upon receiving these instructions, right, from the Selenium core, the response is sent back to this RC server from your browser and back to your test scripts. So the cycle starts from your test scripts. The Selenium commands are interpreted by your RC server. Those are sent to the browser, and it's a simple JavaScript which executed on your browser, and the results after the execution are sent back to your test scripts through your RC server. This is a simple cycle. Now this cycle is repeated for every command written in your test script until your complete test case is executed. Okay, so this is how the RC worked. Now this RC had few shortcomings, and what are those? One is the architecture of this RC itself was complicated. Why? Because of this intermediate RC server which we have between the browser and your test script, and this RC server had to be installed before running any test scripts. So that means this became an additional setup, and it acts as a mediator between your Selenium commands and your browser. Also, the execution of commands takes a very long time. It is pretty slow. Why? Because every command, it needs to make a full trip from your test script to your RC server, to the core and to the browser, execute the script, and then again back in the same line, which makes your overall test execution very slow. And now because of this shortfalls, WebDriver was introduced. So Selenium WebDriver. Selenium WebDrivers were introduced by a gentleman called Simon Stewart, and it was developed in the year 2006. It is the first cross-platform testing framework. It is a programming interface to create and run test cases. It makes provision to act on web elements. So basically there are multiple locating techniques which Selenium WebDriver provides us for finding those elements and to perform operations on those web elements. WebDriver does not require a core engine like RC, and it interacts natively with the browser application. So there is a direct interaction with your browser application, and it eliminates the need of having that intermediate RC server. And that makes the architecture pretty simple. This WebDriver, again, it supports multiple languages, which we already talked about, and also it has integration with multiple frameworks. So once you understand how the WebDriver works, what are its functionalities and what are its drawbacks, you will appreciate the fact that, so how does Selenium WebDriver overcomes this? Even in WebDriver, we have test scripts, we also have a web browser here, and then we have a WebDriver. However, what we do not have this additional server which RC required, and this makes the architecture of the WebDriver simpler. The browser is controlled directly from the operating system level. Now, due to this direct communication, the speed of test execution is much faster than RC. Now, how does this WebDriver work? So we have something called as client libraries or the language bindings. So we know now that Selenium supports multiple languages and you're free to use any supported language to create your automation script. And where are these libraries available? So if you go to seleniumhq.org, so let me go to the browser and show you that. So in the seleniumhq.org, if you go to the downloads, so here you will see something called as Selenium Client and WebDriver Language Binding. And depending on the language which you want to work with or which you want to create test scripts with, you can download these client libraries. So if you're working with Java, download the client library for Java. So if you're working with Python, you have a corresponding link through which you can download your client libraries. And then Selenium provides a lot of APIs for us to interact with the browser, and these are called as the REST APIs. So then we have the browser drivers through which we interact with the browser. Now, what are these browser drivers? So there are drivers specific to each browser. So let me show you that on our seleniumhq.org. So here, if you just scroll down, you have something called as third-party drivers, bindings, and plugins. For every supported browser of Selenium, you have a corresponding driver file available. Now, say for example, if you want to work with Firefox, Mozilla Gecko driver is what you need to download. And these driver files, so if you go and click here, you will get an executable driver file for any of the platforms which you're working. So if you're working on Windows, Mac OS or Linux, you can just download the corresponding driver files here. So these drivers, see, these driver files are the ones which interact with the actual browser. And how does this happen? This driver establishes the connection with the real browser without revealing the internal logic of the browser functionality. Now, what does that mean? Say we want to execute a test script. And how does this test script gets executed? First is it sends an HTTP request which is generated and sent to this browser driver which we just saw for each of the command in your scripts. And then this driver receives the request through your HTTP server. And this HTTP server does all the execution directly on the browser. And then the execution status, the complete status is sent back to your test script. So let me show you a simple use case how it works with the WebDriver. So for that, let's go to my Eclipse here. So I already have a test script written here in WebDriver, and what this basically does is it launches amazon.com, amazon.in website. It uses the Firefox browser, and then I'm also fetching the page title and printing it on the console. And then I'm closing the browser. This is a simple functionality which I'm doing here. So if you look here, so the Eclipse is the IDE which I'm using. I've already installed Selenium here and I've written a simple Java class. And this Java class, we have multiple methods. One is to launch browser, one is to fetch the title of the page, and one is to close the browser. Now while launching the browser, I said every browser has its own driver files. So somewhere in this Java class, I need to tell Selenium as which browser to use. And how is that done? That is done by these first two statements here, where I'm doing a system.set property and where I'm indicating that this is my driver file, which is the Gecko driver, to be used. And using this, I want the Selenium to launch the Firefox browser. And after this, all the operations, any operations which you want to perform on your web application under test, you can do it here. Now let's go ahead and execute this and see how it works. So simply what I need to do is I'll just say execute this as a Java program. So the Firefox browser is getting launched. So you can see amazon.in being launched here. And since we are not doing any operations here, what I'm simply doing is printing the title of the page and closing the browser. That is it. So if you see here, you can see the page title is online shopping site so and so. And this is what I'm printing through this method, which is fetch page title. A very simple way of writing a automation script using WebDriver. So now you saw how we write a small test script using the WebDriver function. Now say if I want to run the script on multiple browsers and on multiple operating systems, and I do not have just one test case. I say I've got hundreds of test cases. Now with this approach, what you can achieve to your best is you can sequentially execute on every browser available and all your 100 or 200 test cases, whatever you have. Now this is going to take quite a long time to execute, and hence to reduce the time taken for the execution, Selenium has something called as grid. Selenium grid. The main objective of the grid is to minimize your test execution time. This grid is designed to distribute commands to different machines simultaneously. In real-time environment, you always have the need to run test cases in a distributed environment. For example, a web application for which say you have automated thousands of test cases and you want to run them as a regression suite across multiple browsers and OS. What you need to do is you need to run them parallelly and not really sequentially. So grid allows this parallel execution of tests on different browsers and operating system. You also want an integration with reporting tools so that you can get a consolidated report after the tests have been executed on multiple machines. So grid can be integrated with such many other tools. How does the grid work? So grid has this hub and node concept which helps in achieving the parallel execution. Let's take an example. Say again, your application supports all browsers and it also supports different OS like the one which you're seeing here, like Windows, Mac and Linux. And your requirement is to run tests on all the supported browsers and operating systems like this one. So what you do here is you configure a master machine, that is this, which is also called as hub, by running something called as Selenium standalone server. And this Selenium standalone server can be downloaded from your Selenium HQ website. So let me show you that. Let's go to my browser, and in the downloads here, if you see Selenium standalone server version 3.1.4.59, and this is what you need to download. So using the server, you create a hub configuration like this. Once you do this, you also need to create nodes specific to your requirement, like a Windows 10, like a Mac machine with Firefox, with a Windows 8 with a Chrome, and Mac say with Safari browser. And the node configuration is also done using the same server, which is the Selenium standalone server. So you create a node configuration on this node machines. So once you have the setup created through your master, that is your hub, you can control on which nodes you want to execute which test. Say for example here, say you want to run some test on your Mac machine with Safari browser only. So you have a kind of smoke test which you need to run. Now through the master, you can control this complete execution. So what master does it selects this particular node depending on the configuration which you have set on the master machine. Also you could have multiple possible combinations, like say I want to just run smoke test on all my nodes. I want to run specific component test on say only Windows 10 with an Edge browser. Or I can say I want to just run my complete regression suite but only on Mac machine, and so on. And all this is controlled through your master. So what happens on the node? Once it gets the command from the master, the node actually runs the specified test on the browser. So you can check out our detailed video on Selenium Grid for you to understand how the grid works and how do we do this configuration and execute the test. To summarize the Selenium versions, Selenium version 1 comprised of an IDE, RC and grid. As we discussed earlier, RC was on its path of deprecation and WebDriver was taking birth. So Selenium 2 had an earlier version of WebDriver and also RC existed. From 3.0 onwards, RC was completely removed and WebDriver took its place. Also, there's a 4. Version around the corner. It has more features and enhancements. So some of the features which is expected are like W3C WebDriver standardization. They have an improved IDE, and also I believe there are some improvements done to the grid. Advantages of Selenium: speed and accuracy. Since there is no manual execution, your test can run faster, and with grid, it helps in parallel execution. So you can actually execute large volume of test cases within a short frame. For example, let's say before your release of product, during your last lap of testing, you find a bug and it has to be fixed. So the developer fixes the bug, and what you want to do is you want to run all the test cases pertaining to that area. Can you imagine the amount of time which will be required if you have to do this manually? But by automation, you can achieve this in a short duration of time, and you can also enable releasing your product in time and with less or no human error. The second advantage is it's an open source, so it's available free of cost and anyone can download and start using it. Supports a wide spectrum of programming languages. It is not restricted to any particular programming language. Whatever language you are comfortable with, you have an option to use that and to write your Selenium scripts. Selenium has support for almost all browsers and operating systems, including a headless browser. So this helps you to create test cases once and run them across all browsers and operating systems, and thus saving your time from manual execution. It also helps in achieving a broad test coverage. It's a pretty easy to use tool. You can check out all our videos and you can just master the skill of writing automation scripts. Reusability and add-ons. Of course, like any programming languages, it provides you a mechanism to reuse your code and avoid redundancy. Limitations. So like any other tool, Selenium also has certain limitations. So let's look at what they are and see if there are any workarounds also. Since Selenium is an open source, you do not have much technical support available. However, there are loads of documentation, materials, forums available which you can refer to. This tool is for automating web application. It cannot handle mobile application or desktop application automation. However, what Selenium provides is a support for integrating tools like APM tool for mobile testing. Selenium is not very good with image testing, since especially it is designed for web application automation. But then we again have many other tools which can be integrated with Selenium, like AutoIt and Securely. Selenium again has a limited reporting capability. It can help create basic reports, but we definitely need more. So it provides supports for tools like TestNG, ReportNG, Extent reports, which you can integrate and generate beautiful reports. Powerful, isn't it? Of course, it does not have a test management capability. A tool need not have all these capabilities. But again, you can integrate with the test management tool used in your organization. Since Selenium supports multiple programming language, the developer of the automation script need to have some basic knowledge of any programming language to write effective automation scripts. Of course, a deep advanced knowledge is not required. A basic knowledge is more than sufficient. So if you look at all this, Selenium still provides a complete solution for your automation need. And that's the beauty of Selenium. And that is what makes it the most popular tool today for automation. Selenium jobs and salary, a very interesting topic. So the market trends for test automation are continuously changing, and Selenium has seen an exponential growth in a very short time period. This Selenium makes it convenient for clients to receive an ROI much faster. And how does that happen? By reducing the number of test cycles involved in testing their product. In present scenario, Selenium is a perfect automation for any of your web application testing and automated web application testing. And it is the first choice of your automation tester as well as the companies also. So as the softwares are becoming more and more complex, so is the test automation. And Selenium is a key skill set for any test automation engineer to have. But of course, it's not the only skill set one needs to have. So if you look at a typical job description here, so gone are the days when the engineers were hired as a manual tester. Every company today wants to hire engineers who knows how to do automation. And since Selenium is the most popular web application automation tool, companies look specifically for Selenium automation engineers. And this is the typical job description of any automation engineer. To develop test cases to detect bugs and errors. Automation framework designing. It's not just about automating your test cases. One should have the ability to design the complete framework related to the project. To improve and automate test practices. To participate in communicating best practices. Defining test strategy, test manuals for tracking and fixing your software issues. Let's look at the compensation part of it. So compensation varies from company to company, and it also depends on your experience level. So according to the stats, if you look at the US market, it can vary anywhere from $21,000 to $150,000. Average could be, of course, somewhere around $90,000. And if you look at the Indian market range, it ranges anywhere from 2 to 10 lakhs per annum for a startup. with an average of 5 lakhs. So the more and more you're going to get experience, the better is going to be your compensation package. And the market has always been very lucrative for automation engineers. So since Selenium is so powerful web automation tools, there are some of the top-end companies who use Selenium in their various projects. They want to provide their customers the best quality software and help them reduce the time to market, and hence they go in for Selenium. So a lot of these companies have Selenium deployments.
Here we wrap up with Devops Basics. If you like this video, hit the like button and consider subscribing to our channel and hit the bell icon to never miss an update from Simplilearn. Till then, keep watching and keep learning.
Staying ahead in your career requires continuous learning and upskilling. Whether you're a student aiming to learn today's top skills or a working professional looking to advance your career, we've got you covered. Explore our impressive catalog of certification programs in cutting-edge domains, including data science, cloud computing, cybersecurity, AI, machine learning, or digital marketing. Designed in collaboration with leading universities and top corporations, and delivered by industry experts, choose any of our programs and set yourself on the path to career success. Click the link in the description to know more.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.